next few hours, you will be enriched with the new ideas and vistas in chemistry imparted by the eminent scholars like Dr. Raghavan B. Sunoj, Google Cloud Chair Professor, Department of Chemistry, and Center for Machine Intelligence and Data Sciences, IIT Mumbai. And the second session will be by Dr. Sashidhar B.S., Principal Scientist, Chemical Sciences and Technology Division, CSIR, NIIST, Thiruvananthapuram, Kerala. And in the afternoon, we will be having the third session by Mr. V.G. Nayak, Retired Deputy Director, Forensic Science Laboratory, Bangalore. From the bottom of my heart, I extend a happy stay to you all. We always feel proud to uphold the Indian tradition and culture. So, ladies and gentlemen, here we have Koyal, Ruchita, Chaitra, Vaishnavi and Sanshika to welcome you all through an invocatory dance. Thank you, students, for mesmerizing us with the beautiful dance. Here we are presenting a small video regarding today's seminar.
Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its fourth cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field.
such a beautiful video. Now, ladies and gentlemen, may I now request Professor Arunakumar B., Head of the Department of Chemistry, Student Welfare Officer, Convener of National Level Chemistry Seminar, Mrs. Veera Ida Pinto, and Dr. Babu M., co-conveners, Mrs. Jyoti M. Alfonso, Coordinator of Amrutha Mahothsava Seminar Series, to escort the dignitaries onto the rostrum. Yeah. Ladies and gentlemen, may I now request Professor Arunakumar B., Head of the Department of Chemistry, Student Welfare Officer, Convener of National Level Chemistry Seminar, Mrs. Veera Ida Pinto, Dr. Babu M., co-conveners, Mrs. Jyoti M. Alfonso, Coordinator of Amrutha Mahothsava Seminar Series, to escort the dignitaries onto the rostrum. With a big round of applause, let us welcome Professor Lakshminarayan Karan, Principal M.G.M College, Udupi, President of Inaugural Session, Chief Guest of today's function, CA BP Vardharaipai, Secretary, Academy of General Education, Manipal, Keynote Speaker, Dr. Raghavan B. Sunoj, Google Cloud Chair Professor, IIT Mumbai, Guest of Honor, Mrs. Malati Devi, Principal, M.G.M PU College, Udupi, Guest of Honor, Dr. Edwin S. D'Souza, President, Association of Chemistry Teachers, Mangalore University, and Mrs. Shailaja H., Head of the Department of Physics, IQAC Coordinator. Prayer is talking with God in order to achieve a good purpose. So here we have Spandana, Pratijna, and Deepika of 2nd BSc to invoke the God's blessings.
कुमिकरा अम्बासुत अमर विनुत लम्बोदर कुमिकरा सिद्धचारण गण सेवित सिद्धि विनायक ते नमो नमो लम्बोदर लकुमिकरा अम्बासुत अमर विनुत लम्बोदर लकुमिकरा सकल विद्या आदि पूजित सर्वोत्तम ते नमो नमो लम्बोदर लकुमिकरा अम्बासुत अमर विनुत लम्बोदर लकुमिकरा
Thank you, my dear students. May I now request Professor Arun Kumar B, Head of the Department of Chemistry, Convener of Chemistry Level National Seminar, to welcome the dignitaries, guests, and the gathering.
Good morning, everyone. It's a moment of extreme pleasure to welcome each one of you to this one-day chemistry national seminar organized by Department of Chemistry, M.G.M College, Udupi, in collaboration with Association of Chemistry Teachers of Mangalore University and IQAC of our college. M.G.M College, Udupi has completed 75 years of its existence, and we are celebrating Amrutha Mahothsava this year. On this auspicious year, our management has sponsored a series of academic programs for the benefit of students and faculty members. As a part of the series of academic programs, Department of Chemistry is organizing a national level seminar, New Vistas in Chemistry, NVC-2K24. Chemistry is a field that is constantly evolving with the new discoveries and innovations happening at a rapid pace. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants and to enlighten about the career opportunities available to chemistry students. This seminar brings together scientists, young researchers, teachers, and students, and to provide a platform for the interaction, discussion on the emerging new trends in chemistry. By working together, we can drive the field of chemistry forward and tackle the present challenges facing our society. It's my great pleasure to greet all distinguished guests, delegates, research scholars who have joined us here on this inaugural session. To inaugurate this seminar and to give keynote address, we have with us Dr. Raghavan Sunoj, an eminent scientist, Google Cloud Chair Professor, Department of Chemistry and Center for Machine Intelligence and Data Science, Indian Institute of Technology, Mumbai. On behalf of all, let me extend a warm welcome to you, sir. Professor Lakshminarayan Karanth, Principal, M.G.M College, Udupi, has agreed to preside over the function, who is always a driving force and supportive in all our activities. Sir, on behalf of all, let me extend a cordial welcome to you. Our chief guest for today's seminar is none other than our beloved CA BP Varadaraya Pai, Secretary, Academy of General Education, Manipal. From the management side, he is always a motivating personality and positive catalyst in all our academic activities. On behalf of all, let me extend a hearty welcome to you, sir. We have with us Srimati Malati Devi, Principal, M.G.M College, as guest of honor, who is always supportive in all our activities. On behalf of all, let me extend a cordial welcome to you, Madam. We are very happy to introduce Dr. Edwin D'Souza, President, Association of Chemistry Teachers of Mangalore University, as our guest of honor. Our association plays a vital role in all our academic activities. On behalf of all, let me extend a warm welcome to you, sir. We have with us Mrs. Shailaja H., IQAC coordinator of our college. Madam, on behalf of all, let me extend a cordial welcome. We have with us Mrs. Jyoti Alfonso, coordinator for seminar series, Mrs. Veera Pinto and Dr. Babu M., co-conveners of this seminar. Their support and effort is immense in organizing this seminar. On behalf of all, let me extend a warm welcome to madams and sir. I am very happy to welcome our today's resource persons, Dr. Shashidhar B.S., Principal Scientist, CSIR, NIST, Thiruvananthapuram, Kerala, and Mr. V.G. Nayak, Deputy Director, Retired Forensic Science Laboratories, Bangalore, who are present here. Welcome you, sir. I am very happy and proud to welcome our own alumnus, today's resource person, Dr. Nagaraj Nayak, Deputy Manager, Process Chemistry, Shravati Advanced Process Technologies, Bangalore. Welcome you, sir. I extend a warm welcome to all the invited guests, our retired staff members, invited student delegates, research scholars, and faculty members from different neighboring institutions. I extend a cordial welcome to all my dear colleagues who are present here in this inaugural session. It's my pleasure to extend a warm welcome to all print and media persons who are present here. Lastly, it's my great pleasure to extend a cheerful welcome to all my dear students and student volunteers who toiled hard in organizing this seminar. Welcome you all. I hope you will find this seminar to be a productive and inspiring experience. Thank you. Let's have a wonderful day ahead.
Thank you, sir, for your kind gesture. We shall now florally welcome the dignitaries. I kindly request Professor Arun Kumar B., Head of the Department of Chemistry, to present a bouquet to the President of today's ceremony, Professor Lakshminarayan Karanth, Principal, M.G.M College, Udupi. Thank you, sir. May I now request Professor Lakshminarayan Karanth, Principal, M.G.M College, to welcome the chief guest of today's program, CA B.P. Varadaraj Pai, Secretary, AGE Manipal, with a bunch of flowers. Thank you, sir. I would like to request Mrs. Veera Ida Pinto, Associate Professor of Chemistry, to welcome the keynote speaker, Dr. Raghavan B. Sunoj, Google Cloud Chair Professor, IIT Mumbai. Thank you, ma'am. May I now request Mrs. Jyoti M. Alfonso, Assistant Professor of Chemistry, to welcome the guest of honor, Mrs. Malati Devi, Principal, M.G.M College, with a bunch of flowers. Now I would like to request Professor Saraswati T., Head of the Department of Mathematics, to florally welcome the guest of honor, Dr. Edwin S. D'Souza, President, ACT, Mangalore University, with a bunch of flowers. Thank you, ma'am. May I now request Dr. Vishwanatha Pai, Head of the Department of Computer Science, to florally welcome Mrs. Shailaja H., Head of the Department of Physics, IQAC Coordinator, with a bouquet. Thank you, sir. I would like to request Dr. Babu M, co-convener, chemistry faculty, to welcome Professor Arun Kumar B with a bunch of flowers. Thank you, sir. I would like to request Mr. Devi Das K, Assistant Professor of Chemistry, Vijay College, Mulki, to florally welcome Mrs. Veera Aida Pinto, Mrs. Jyoti M. Alfonso, Dr. Babu M with a bunch of flowers. Thank you, sir. It's indeed a pleasure to welcome the retired staff members who have kindly accepted the invitation and graced the occasion. May I now request Professor Arun Kumar B, Head of the Department of Chemistry, to give a rose to the retired Professor Arun Kumar Sir as a token of love and appreciation. Thank you, sir. Light and brightness have always been equated with the positivity and motivation. To start it off on an auspicious note, we are having lighting the lamp ceremony. May I now kindly request all the dignitaries to come forward and light the ceremonial lamp. Now it's time to pay tribute to the founder of M.G.M College, Padma Shri Dr. Tonse Madhava Ananta Pai. Dr. Tonse Madhava Ananta Pai was a physician, educationist, banker, most well known to build the university town of Manipal. M.G.M College was his dream child and visualized to bring education to the doors of youth of Udupi and neighboring towns. He started M.G.M College in the year 1949, and then this was the only one college in the whole Udupi district. This year, our college is celebrating 75 years of excellence, academic excellence. We are fortunate enough to be the part of this celebration. We are glad to have Raghavan B. Sunuj, Dr. Raghavan B. Sunuj with us, who himself has a deep interest in the field of science and technology. With a great honor and respect, may I now request Dr. Raghavan B. Sunuj to deliver the keynote address.
Good morning to everybody. Dignitaries on the stage. I'm not a very formal person, so it is very difficult for me to give a formal speech welcoming everyone to this National Symposium. But I should admit that I'm indeed happy to be here first time in this part of the country. I've eaten Udupi masala dosa from around the world, and now I am in Udupi enjoying masala dosa in yesterday's dinner. It is indeed a pleasure to be here and experience the hospitality which has been exceedingly warm. A special mention to Dr. Arun Kumar, who has been instrumental in bringing me here. I should definitely thank all of you to have come here today morning. I'm used to giving technical lectures and motivational lectures to students, but not quite used to giving an inaugural lecture in a conference. So again, this is a transition, but what I believe is that given the mandate, that is, you are given a job, a duty, I should always live up to the expectation. So therefore, I'm here in front of the mic without any slide, without any technical content, just to tell you that I am indeed happy, not about visiting this place. I always find a lot of joy in interacting with young people, students. And I suppose most of you are undergraduate students, pursuing your BSc in chemistry. And the moment I walked into this room, a lot of memories came to my mind, how I used to be back in my BSc days. The sight of standard flask of varying dimension and varying color is indeed the color of chemistry. And in my lecture, the so-called pseudo-technical lecture later today, is meant for celebrating chemistry. So in the very celebration of chemistry, these colors and standard flask and any apparatus in a chemistry lab has been an immense source of inspiration for me in my personal career. Starting from school, when I was in 8th standard, very young, most of the time in hot, humid sunlight, I used to play cricket. But when I came to school one fine morning, the school had inaugurated a 4-storied building, and the 4th floor was meant for laboratories. Entire 4th floor of a good-sized building was dedicated for laboratories, chemistry, physics, biology, and computer science. The teacher who was my chemistry teacher asked in a regular routine lecture, "I want some help from you." We didn't know what the help was. The help was to shift laboratory from an old ground floor building to 4th floor of this new building. Shift the laboratory. That would naturally involve carefully shifting all the glasswares, chemicals, apparatus. All that was there had to be shifted. Without realizing, how this is going to be a life-turning event for me, I raised my hands, sir, I am interested to be the volunteer for shifting lab. 2-3 weeks that followed made such an impact in me as a young person that I decided that this is my life henceforth. Life pursuing chemistry became very clear in my mind that I don't want to do anything but chemistry. And what did we do in shifting? We did a lot of mischiefs. It was an unsupervised shifting of lab. We had access to chemicals, some labeled, some are not even labeled. We didn't know what is what. 8th standard, what do you expect to know? You mix this, mix that, sometimes fire, sometimes if there is no fire, we heat things up. We did lot of mischiefs for a week. And the excitement which I experienced was the key contributor in me deciding that this is my love, this is my fascination. And that commitment, that drive which I gathered from school, seeing all these colors, conducting experiments, unsupervised, unknowingly, no procedure, no lab manual, just did a bunch of experiments until the day we stopped doing this mischiefs was when we started getting hurt, not by chemicals, but by glass wool. The senior members in the audience would know how dangerous it is to mess with glass wool. So I had full swelling of my arms because I didn't even know what is glass wool. Later we found that the injury, the swelling was caused by piercing glass wool. Then I stopped doing that. But that did not deter me from being a chemist. And I was a very, very passionate chemist all through, even today. One of my hobbies were to collect chemicals. Of course, we used to collect stamps, postage stamps those days, different countries, different types of stamps. So we used to collect, many of my friends used to collect chemicals. The film bottle, the old SLR camera film used to come in a plastic container. So that used to be our bottle for collecting chemicals. We collected a lot of chemicals. Purpose unknown, just that we like, many of us like those chemicals for the very look of, the color of it, property of it, the crystallinity, how it shines, how it looks. And that transition stayed with me lifelong, and I became more and more curious about chemistry. Read a lot of books, spent a lot of time in library. That transformed me today, that the subject of chemistry gave me a career, gave me a life, gave me an outlook. I'm very proud of that. And if not for chemistry, my life would have been dull and boring. Whatever be the accomplishment, it's all because of my liking for the subject. And I still read a lot. And I want to share with you some of the excitements of chemistry. That is the reason I came over here, traveling all the way from Mumbai. I have hectic travel plan, teaching commitments, a lot of administrative duties. But I always wanted to interact with young people, people at your age group, and install a sense of pride, sense of belongingness to the subject, the fun and excitement, and how great this wonderful branch of science is. With that intent, I came down here. I hope I would live up to the expectation, and I hope I will be able to entertain you with the fun in chemistry later today. With this brief life experience sharing with you people, I would like to conclude. And once again, I thank you for this opportunity to be here. Thank you.
Thank you, sir, for sharing your college day memories and how you started liking the wonderful subject of science, that is chemistry. Today we have with us the chief guest of today's function, CA BP Varadaraipai, Secretary A.G. Manipal, who has always been a driving force in all our endeavors. May I now request you, sir, to address the gathering.
Good morning to all of you. Respected dignitaries on the dais, respected teachers and non-academic staff members of all three colleges, and delegates who are enrolled for this today's national level seminar. And today is a festival day. Exactly, Navaratri has started yesterday and today is the second day, and most of the houses are celebrating a new beginning of their harvest, and they bring in paddy, and they start eating new rice from today onwards. That's why we call it as Navaratra, and in Kannada we call it as Hostu. Similarly, M.G.M College is also celebrating its festival. The chemistry department especially is organizing a national seminar on the theme of new vistas in chemistry. New vistas means Hosatu again. And they also in their own subject, chemistry. And this seminar is organized in connection with the Amrutha Mahothsava of M.G.M College. So I think most probably this may be the last of that series. And after that, in the next month or so, they are going to conclude their Amrutha Mahothsava. And with this, the today's theme of new vistas in chemistry is very, very apt. And I read from their brochure, and they say current innovations and developments in chemistry, and breakthrough in green chemistry, and emphasizing on sustainable practices and environmental friendly processes, computational chemistry, and enabling precise molecular modeling, accelerating drug discovery, and optimizing chemical reactions with unprecedented accuracy. And this theme or objectives what they have selected is very, very apt. And I would like to say that I am a commerce graduate, and chemistry is a mystery for me. And nowhere after my SSLC I never studied any science subjects. But however, I really wonder what chemistry can teach you and all. And at the same time, when chemistry also starts from kitchen of every house, and main ingredient is salt, which is improves or which enhances the taste of our taste buds. There's a reason I think I do not know. Sometimes my wife, you call it as whether it's a mixture, whether it's a solution, whatever she prepares in the kitchen, really, really wonderful, and it tastes our taste bud. That's why I'm telling you, and this may be a totally different from chemistry what you are practicing in your classrooms and what you are preaching or teaching in your laboratories. But really, I'll tell you, and this chemistry seminar definitely is going to open several areas of innovation, research, and definitely it will, ignite very young minds to go for research and continue their studies and research collaboration with so many agencies where they can get a research grant and all. And definitely this is one of our objective for getting all the teachers and all the undergraduate students channelize their energy, channelize their intelligence, or channelize their efforts towards getting research grants and writing research papers, so that the accreditation, we will get a better ranking in this, because nowadays accreditation research has got a very, very pivotal role in getting accreditation rankings. So this seminar is very apt, and I wish this seminar every success. And I thank the organizers for giving me an opportunity to speak on this occasion. And thank you very much, and wish you all the best. Thank you.
Thank you, sir, for your inspirational words. May I now request the guest of honor, Dr. Edwin S. D'Souza, President of Association of Chemistry Teachers, Mangalore University, to share his thoughts.
Respected dignitaries on the dais and off the dais, invitees, guests, speakers, and my dear students, a very good morning to you all. It is both an honor and privilege to stand before you today as the President of Association of Chemistry Teachers of Mangalore University. At the very outset, I congratulate the chemistry department and all my colleagues for organizing one-day national level seminar on behalf of the Association of Chemistry Teachers of Mangalore University. And also, I extend my heartfelt gratitude to the organizing committee for this remarkable opportunity to gather and share our passion for chemistry, a field that continues to shape our outstanding understanding of the world and drive innovation in countless ways. As we convene this national level seminar, we celebrate the incredible strides we have made in realm of chemistry, but we must also reflect on the challenges that we lie ahead. Today, we find ourselves at a pivotal moment in specific scientific inquiry. The pressing issues of climate change, public health crisis, and the quest for sustainable energy sources demand our attention and expertise. Chemists play a crucial role in addressing these challenges. It is our responsibility to inspire the next generation of scientists, equipping them with the knowledge and skills to innovate and solve the problems of tomorrow. I encourage everyone gathered here to collaborate, share ideas, and explore new avenues for research and education. Let us embrace interdisciplinary approaches that unite chemistry with other fields. Such collaborations can yield breakthroughs that are not only scientifically significant, but also socially impactful. As we embark on this seminar, let us remember that our collective efforts in chemistry have the power to change lives. Let us challenge ourselves to think boldly and creatively, to push the boundaries of what is possible, and to uphold the values of integrity and ethical responsibility in our work. I am excited to see the discussions that will unfold, the knowledge that will be exchanged, and the partnerships that will be forged during our time together. Thank you for being here, for commitment to advancing the field of chemistry, and for your dedication to the pursuit of knowledge. Let us make this seminar a catalyst for progress and inspiration. Thank you.
Thank you, sir, for sharing what actually is the importance of chemistry in the future. Now I would like to request the guest of honor, Mrs. Malati Devi, Principal, M.G.M College, to address the gathering.
Good morning, all of you. Respected dignitaries on the dais, off the dais. I welcome to our national level seminar and colorful chemistry national level seminar today. So we are honored to have such a distinguished delegates and group of teachers and students joining this program. Today's event promises an engaging and enlightening experience for all of us. Let's open our minds and hearts to new facts and share our knowledge. I would like to warmly welcome our guest speakers and facilitators. We have generously agreed to share their expertise with us. We have an exciting lineup of topics and activities for the day. A big thanks to our organizing committee for putting this seminar together and for all the hard work. Have a good day. Thank you, one and all.
Thank you, Madam. It's time to listen to Mrs. Shailaja H., Head of the Department of Physics, IQSC Coordinator. Madam, with the due respect, I would like to invite you to the podium to share your thoughts with us.
Respected dignitaries on the dais and off the dais, participants from various colleges, my dear colleagues and students. I am delighted to welcome all to this national seminar on New Vistas in Chemistry. This seminar presents a remarkable opportunity to explore the evolving horizons in the field of chemistry, from green chemistry to nanotechnology and artificial intelligence-driven research. The scope of chemistry is rapidly expanding. These new vistas not only push the boundaries of scientific discovery, but also contribute to the solving global challenges like climate change, healthcare, and sustainable development. I encourage all the participants actively engage in this section and discussions, and they will lead to the new ideas, collaboration, and important solutions. Best wishes for the successful and thought-provoking seminar. Thank you.
Thank you, Madam, for the beautiful message. May I now request Mrs. Jyoti M. Alfonso, Assistant Professor of Chemistry, Coordinator of Amrutha Mahothsava Seminar Series, M.G.M College, to deliver the message.
Good morning, everyone. Respected dignitaries, distinguished delegates, my fellow colleagues, and all present here. I extend a warm welcome to you all. I feel honored to say a few words as the seminar coordinator of the college. We are excited to announce that today marks the 7th seminar in a series commemorating our college's 75th anniversary celebration, Amrutha Mahothsava. Today we are witnessing a one-day national level seminar titled New Vistas in Chemistry. It has been organized by our department in collaboration with Association of Chemistry Teachers of Mangalore University and IQSC. This seminar continues the momentum from 6 successful prior seminars, bringing together experts in the field to explore latest advancements and innovative research in chemistry. I would like to express my heartfelt gratitude to each one of you for joining us, especially our delegates who have traveled so far to be here with us today. Your presence is a testament to the seminar's significance and reflects our shared dedication to excellence. To the paper presenters, I wish you the best of luck in sharing your research and ideas. Your contributions will enrich our knowledge and bring out better perspectives and understanding. As we look to the future, our college is dedicated to continuing this tradition of hosting seminars that drives growth, innovation, and progress. Once again, I thank each one of you for your presence and participation. And as I conclude, I wish you all a wonderful experience and look forward to many more successful events in the years to come. Thank you, one and all.
Thank you, madam, for the inspirational message. It gives me immense pleasure to invite the president of today's program, Professor Lakshminarayan Karan, Principal M.G.M College, Udupi, to deliver the presidential remark.
Respected Varadara Bhai sir, Varadara Bhai sir is mainly responsible for organizing all the series of seminar in our college. Varadara Bhai sir and our president Satish Bhai sir, they are encouraging spirit for conducting these kind of academic programs in connection with the Amrutha Mahothsava. Thank you very much, sir. And all other dignitaries on the dais, invitees, my dear students. Of course, I may not be able to give presidential remark on this seminar because I belong to economics section. I am odd to this seminar, of course, okay. But the thing is that, see, chemistry is one subject, it is linked to all other science subjects. It's the central subject connecting physics, biology, mathematics and others. In chemistry, it is very much scope for application, new vistas. That is, the analytical part is now very much today. Research and other areas got much importance today's seminar is concerned. We have a rich legacy of chemical research from the ancient wisdom of Ayurveda to the modern innovations in pharmaceuticals and material science. Today's seminar is a testament to vibrant academic environment of our college, where we encourage curiosity, critical thinking and creativity. As I heard that among all the inventions, two inventions are very important. One is money from economics and commerce side, other is fire from the chemistry and science is concerned. Without these two inventions, no development as concerned. And some of their observations are there, even destruction is also because of these two inventions. And say, today's seminar is mainly highlighting about analytical part, new vistas, new innovations in the field of the chemistry. Chemistry now is very much important to everyone, even person who is not interested in chemistry also very important. One example is that every day in the morning we are taking medicine, BP or sugar, This is the contribution of the chemist. So if there is no chemist, we have no life at all. So great thanks to chemistry teachers and faculties here. So this seminar, let us discuss about many more new things. Here our young band of students are there. You encourage them and motivate them. So thereby this, this science, especially science subject, chemistry subject, many students hereafter take as the degree subject. So I wish a seminar a grand success. Thank you one and all.
Thank you, sir. It's always a pleasure to listen to you, sir. Gratitude is the best attitude. Now it's time to say gratitude to the dignitaries who have spent their valuable time in spite of their busy schedule. May I kindly request Professor Arun Kumar B, Head of the Department of Chemistry, to present a memento to Professor Lakshminarayan Karan as a mark of respect and gratitude. Thank you, sir. May I now request Professor Lakshminarayan Karansu, Principal M.G.M College, to present a memento to the Chief Guest CA BP Varadaraya Pai, Secretary A.G. Manipal, as a token of honor. And also to the guest of honor, Dr. Edwin S. D'Souza, as a mark of respect. Thank you, sir. As a token of love and respect, may I kindly request Professor Arunakumar B to present a memento to Mrs. Malati Devi, Principal M.G.M College, Udupi. And to Mrs. Shailaja H, Head of the Department of Physics, IQSC Coordinator. It's our custom to express gratitude to our guests and dignitaries. Ladies and gentlemen, I would like to invite Mrs. Veera Aida Pinto, Associate Professor of Chemistry, to propose vote of thanks. May I kindly request Professor Lakshminarayan Karanth, President of today's function, to give a memento to Raghavan B. Sunoj. Dr. Raghavan B. Sunoj, sir. Ladies and gentlemen, I would like to invite Mrs. Veera Aida Pinto, Associate Professor of Chemistry, to propose vote of thanks.
Feeling gratitude and not expressing it is like wrapping a present and not giving it. Good morning, everyone. Respected dignitaries on and off the dais, and dear students, I, Mrs. Veera Aida Pinto, deem it a great honor and privilege to propose vote of thanks at this inaugural ceremony. First and foremost, on behalf of everyone, I extend my sincere thanks to the Almighty God. With His blessings and grace, we are able to make this seminar. I would like to thank the torchbearer of this event, our respectful principal, Professor Lakshminarayan Karanta, for leading and inspiring us towards the goal of conducting this seminar. We are thankful to him for his huge support all the time. We are grateful to Dr. Raghavan B. Sunoj for inaugurating this seminar and enlightening us with this novel approach and ideas on the core issues of the seminar, and also for sharing his life experiences. Thank you, sir, for sharing your knowledge. I express my deep gratitude to the chief guest, CA BP Varadaraya Pai, who, despite of his numerous and rather tight schedule, has found time to grace this occasion. We are grateful to you, sir. I would like to express my appreciation to our guest of honors, Mrs. Malati Devi, Principal, M.G.M College, and Dr. Edwin Santan D'Souza, President, Association of Chemistry Teachers of Mangalore University, who have taken time out of their busy schedules to grace this occasion with their presence and enriching words. Your presence has added an extra spark to this seminar and made it more special. Thank you. My heartfelt thanks to our HOD and convener of the seminar, Professor Arun Kumar B. for his unwavering support and guidance. His valuable insights, leadership, and encouragement were instrumental in making this event. Thank you, sir. A big thank you to co-convener Dr. Babu M, coordinator Professor Jyoti M, Professor Shailaja Madam for their valuable contribution and guidance. I take this opportunity to extend our sincere thanks to all distinguished resource persons, special invitees, former staff of our department, delegates, and my dear students for blessing us with your presence and marking this seminar possible. Special thanks to Mrs. Pushpalata from the Department of Chemistry for comparing this session. I hope that this seminar will prove to be a milestone in terms of learning on new vistas in chemistry and have way for more meaningful discussion in the future. Thank you, one and all.
In a short while, we are commencing today's first session, that is modern chemistry and its importance in life and survival, by Dr. Raghavan B. Sunoj, IIT, Mumbai.
Chemistry take this opportunity to welcome each one of you to the first session. I would like to begin with the words of wisdom said by Marie Curie. Nothing in life is to be feared, it is to be understood. Now it is time to understand more so we may fear less. With these beautiful thoughts, let us begin the first session on modern chemistry and its importance in life and survival. I request Dr. Raghavan B. Sunuj, Google Cloud Chair, IIT Bombay, to occupy the seat on the dais. I am very delighted to introduce the resource person to you all. Dr. Raghavan B. Sunuj has received his PhD from Indian Institute of Science, Bangalore, working with Professor J. Chandrasekhar. He was a postdoctoral researcher in the laboratory of Professor Christopher M. Haddad at the Ohio State University before joining IIT Bombay in 2003. His research interests are in computational chemistry, machine learning as applied to asymmetric catalysis and reaction mechanism. He also serves as a scientific advisory board of World Association of Theoretical and Computational Chemists and Asia Pacific Association of Theoretical and Computational Chemists, and on the editorial boards of Chemical Society Review, Chemical Science, Organic Letters, and Chem. He is an associate editor of the Journals of Organic Chemistry and an elected fellow of the National Academy of Science, India. He also received several national and international recognition, including highest scientific honor in India for research, Shantiswarup Bhatnagar Prize for Chemical Science, and National Award to Teachers for Teaching. He is currently a professor of chemistry and a Center for Machine Intelligence and Data Science and holds the Google Cloud Chair, IIT Mumbai. On behalf of Chemistry Department, I would like to express a cordial welcome to you, sir. Welcome, sir. I request Mrs. Rekha Ma'am from Department of Chemistry to florally welcome Dr. Raghavan B. Sunuj. We are eagerly waiting to listen to you, sir. Kindly address the gathering.
Timing, who will, duration. So I don't have any watch with me. I don't have any watch with me. Back there. Audible? Very good. Actually, I don't like to stay on the stage. That's not my style. So I will come down. I like to be among the crowd of young people. I hope it would be an entertaining experience listening to my views about the subject of chemistry. But at the beginning, I should also tell, you that, see, chemistry coexists with other subjects. It's an ecosystem. Science is an ecosystem. And so is commerce, so is economics, so are very, very many other disciplines. A large block of engineering, medicine, law, life, living, everything coexists. It's not as though one subject is superior to other. Every subject is equally superior. For example, in the Western countries, there is a very popular card or a greeting. My dad is the best dad in the world. You would have come across such a greeting. My dad is the best dad in the world. My mom is the best mom in the world. Which has to be true. Because one person can have only one dad, one mom. So it has to be best, right? So if I'm a chemist, chemistry is best, which makes sense. For a mathematician, math is best, which also makes sense. But when you look at coexistence of different disciplines, each discipline had contributed to the other. Each discipline. We talk about chemistry. We talk about atomic orbitals. You have studied atomic orbitals? Atomic orbitals, what is the configuration of helium? Atomic configuration of helium? 1s2. Who told you? Textbook. Who told you that 1s2 is helium configuration? Good, textbooks told. Now let's ask, how could textbook tell that 1s2 is the configuration? Which is 1s2, 2s1. Which element is that? Lithium. Who told you? Textbook. Right? Textbook told that this is the configuration. Where is this configuration coming from? Where are atomic orbitals coming from? These are all elements in chemistry. We are familiar with helium, lithium, beryllium, boron, whatnot. We are all familiar. What we can do is we can do chemistry with those elements. We can make compounds. We can bring two compounds and make a new compound. We can make materials. We can make a lot of wonderful molecules. Some are colored like this. The standard flask is colored. How many of you can guess what is possibly this flask containing? This, the big one, big flask at the center. Potassium? Ah, very good. And how about this? Potassium dichromate is common, or so? Is it potassium dichromate? Seems like. You have seen it. At least the crystal, the solid, it looks like this color. And how about this one? Copper sulfate. Is it just copper sulfate or copper sulfate dot something? Water of hydration, right? So we are all familiar. We can deal with compounds. We look at the color, we take measurements, we can mix them, form new compounds. That makes us chemists. But atomic orbitals come not necessarily from chemistry. It comes from physics. And it wouldn't have come from physics through what area called quantum physics or quantum mechanics. Applied to chemistry, it is called quantum chemistry. That was my fascination when I was in teenage. I read a lot of books about quantum chemistry, and I chose my research area based on what I read at your age, BSc. I used to spend a lot of time in the university library, which was just next door to my college, and there used to be bookshelf after bookshelf with full collection of books. So I used to read, and in the last page of each of those books, I would put a very small initial that yes, I have seen this book, I issued this book, I read at least few pages in this book. So that initial used to be there in the last page. Nobody would notice. I know that I have put that initial there. Several books I read. For each concept, let's say atomic structure, I did not read just one book because I was not satisfied. There would be something more in some other book. So I went on reading that. And each time when I read new books, it gave me a new perspective about atomic structure. Then I started respecting the fact that a very complex area, such as quantum mechanics, when applied to atoms, when quantum mechanics concepts are applied to atoms, as a result of it, what we call a solution of Schrödinger wave equation applied to atoms, such as hydrogen atom, that is the birthplace of orbital. That is where you came across 1s orbital, 2s, 2p orbitals. It's not really chemistry. The orbitals came as a result of solution of Schrödinger equation when those equations, those wave mechanic concepts were applied to atoms. That is more in the territory of physics. Now, if physicists become too proud of the fact that they contributed atomic structure, I have a problem there too. When they were trying to solve the Schrödinger equation on hydrogen atom, which contains a nucleus and an electron, that is hydrogen atom, the most simplest system you can imagine from the world of atoms, hydrogen. It's called a two-particle problem, a nucleus and an electron. When physicists were trying to solve it, they came across a bottleneck. They couldn't go any further. They got stuck. And the problem, to be more precise, was in solving radial and angular part of wave function. So one needs to solve radial and angular part, and there are two famous polynomials. One is called Legendre, another one is Lagrange polynomial. This polynomial is neither physics nor chemistry. These polynomials are the critical contributions from mathematics, but these polynomials were available more than 100 years ago. 1926 to 35 is the time when these atomic Schrodinger equations people started worrying about. It's an exciting area that one can solve. But these polynomials which I am referring to are available from 1820, 1840. These polynomials were developed by mathematicians without having any clue where and when this will be useful. Look at the beauty of it. These polynomials were developed for sake of developing. That is, mathematics for mathematics. Mathematics for no one other than mathematicians. Now think of the combination. We talk about atomic configuration 1s2, 2s1, and we are proud of identifying that configuration as belonging to lithium. We identified helium as 1s2. Textbook told it is 1s2. But take a step back and think about, how do you know? Oh, it is a result of solving Schrodinger equation on atom. And during solution, without those polynomials, you wouldn't have been able to solve these equations. Look at the coexistence of math, physics, chemistry all together. Let's be proud of being a chemist. Let's also be appreciative of all other branches of life and our existence on the planet. Do you get it, what I'm saying? It's all important. It is as much important as best dad and best mom in the world. You are the best person in the world. You, each one of you, are the best person in the world. You are supreme. You are good. Not trying to make you get self-glorified, but I am presenting plain facts that you are an important person. When you look back, you are an important person as much as any branch of science, as much as any important concepts in the field of science. You are important. Realize the value of you. It is not the awards, rewards that make a person. You are important. And when you dedicate yourself for a cause, for a purpose, it could be pursuing chemistry, it could be pursuing science or something which you are very passionate about. Like I saw beautiful dance performance today. Invocation, the song, everything was so fantastic. That's a celebration, which is more tending towards culture and art. We as scientists, the practitioners of chemistry, we do celebrate in various forms. This sort of gathering, called a workshop or a seminar, is also our culture. It's a culture of science to celebrate by way of coming together and listening to each other, discussing. We call it a seminar. It's our artistic expression of our branch of science. So I will show some examples to tell you where chemistry influences, the area of chemistry influences. At the outset I told you that all branches are important, but here today we are here for celebrating chemistry. That's the way I look at it. We are going to celebrate our subject. It's wonderful, it's great, it has its own excitement, while respecting all other branches, all other sciences, all other human endeavors. Somebody may be an artist, maybe a photographer, maybe a traveler. All these are important, but today it's time to celebrate chemistry, which permeates, touches each one of us in every minute. Our enzymes are at work without we realizing. The process of vision, the chemical processes that go on in retina that help us see each other. The senses, the biological process, enzymes, everything keep us upright. The ATP, ADP conversion gives us energy to stay upright and listen to each other. All this is happening in the background. There is a lot of chemistry there. Food and agriculture, it's very important. I will tell you stories after stories, so that the lecture is never boring, right? Lectures are usually very boring. You agree? Lectures are usually very boring. Lectures are a nice place, and that too with air condition. Lectures are a nice place to sleep. And if the lecturer is so good, it induces sleep, right? You will have an accelerated version of sleep. So last night I took 1 hour to get sleep, but today 1 minute to go into sleep. That is how good lectures are. So stories are a way to hold you not from sleeping. So I will tell some stories. That is from agriculture. And you have seen, when I was coming from airport yesterday, I saw a lot of paddy field. Very green, sunset on the left side of the car. I enjoyed my ride because I like nature, because I am part of nature. So on the paddy field, I will quote a story from Maharashtra. The story is about cotton plantation. The cotton plant you would have heard of. In cotton plantation, there was a new pesticide which was marketed by one of the companies. New pesticide. The claim of the company was that you have to use 1/100 dilution. 1/100. That means, let's say, 1 mug of pesticide concentrated form mixed with 100 mugs of water. That was the dilution recommended. And farmers got this and they applied, sprayed, and cotton had very good produce that year. They were very happy. Oh, this is the magical pesticide. We are going to use it in every other year, every other time when we go for harvest. This is the pesticide. This gives us a ray of hope. I am quoting story from agriculture. So next time, new plantation, they applied 1/100 dilution. They sprayed and they started seeing this guy. What is this guy? The pests of different kinds. Some are visible, some are not. Some are not visible. Only you will see that the leaves are falling. It is becoming yellow in color. Some part of leaf is missing. There is a hole, but you don't see any of these guys. So the crop production reduced. The profit reduced, but still it was okay. Year 3, they realized that this dilution is not going to help. They added 2 mugs and whatever is that. So basically they doubled the concentration, almost double. And some improvement. By year 5, they put the entire mug, no water, and these guys were moving around. How will we survive? You think of it. How will we survive if this is the rate at which pathogens, this is one example, the rate at which pathogens adapt to whatever we provide. We think that we are technologically very well advanced. Humans are very pompous about, very proud about their technological advances. But the truth is, if we were so proud, we were so effective in containing pathogens, be it a bacteria, virus, then we wouldn't have had lockdown. You wouldn't have to sit in front of stupid computer taking your classes. I can see a clear difference between the first year undergraduates whom I teach in IIT Bombay, first year undergraduates who came, their 11th and 12th spent in front of computer, and 11th and 12th spent in real classrooms. I can clearly see a difference between those batches of students. Right now I taught a batch, very good batch. 2 years before, the batch was so bad they would not interact at all. My classes are very interactive.
They used to ask a lot of questions, and this batch again went back to the same old 18 batches of BTech first year students I have taught. 18 batches out of my 21 years of stay at IIT Bombay. It's a great experience. How many of you follow cricket? Only few of you? Cricket you don't follow? Oh my God, things have changed. Things have changed, generations have changed. Only few. Which game you follow? Football? Which game do you follow? Kabaddi or what? Which game? What is your favorite game? Not audible. Cricket. Okay, so then I will discard that example of cricket. Okay, it's not going to work. So I will drop that example. So go back to the story that pathogens adapt so fast. Why are they fast? Why are they effective? Why are they so smart? We think that we are smart. Huh? We think that we are smart. And they are looking at us and saying that why these people are staying inside this hole, in this cave, what they call as apartment complex. They have windows, they go inside that hole at night. We can freely move around. We don't have to have a home. We think that we are smart. And if power goes off, we are done. We cannot even see. We are very proud, humans, very proud. But then one virus, novel coronavirus, had halted all of us, pushed us inside the hole called home, and we were stuck there for months and months. Just an invisible pathogen. They have evolutionary advantage. They evolve very fast. In 24 hours, some of these pathogens, bacteria for example, can evolve 100 times. That means 100 offsprings, 100 generations happen in 24 hours. Each time an evolution happens, they become adapted to the given condition. You put a bacteria in 100% saline brine, that is saturated sodium chloride solution, initially they will not survive. Give them 30 days or 1 year, they will happily move around in brine and then laugh at us. Oh, you thought that you can kill? No, we will not get killed. That's the spirit. Now, this brings us a very important point, that if pathogens are so smart, why are they so smart? Not just the evolutionary advantage that science talks about. Who is senior on earth? Here in college hierarchy, senior is very important, right? There is a definition in IIT Bombay. How do you define a senior? Senior is defined as one who is always right. One who is always right is called senior. So let's talk about human versus pathogens, single cell organisms, amoeba, bacteria, virus. Who is senior on earth? Who is senior? Bacteria are senior to us by a few million years. Just by a few million years only. Oh, that's not much of a seniority. Do you think few million years not much of a seniority? They are way more senior to us. They are always right. We are still discovering how they function. We are still discovering so that we can suppress their activity. But if you suppress to the extent, if you think that a bacteria-free world is what our goal should be, then also we will not survive. Why we will not survive? Bacteria-free world is very dangerous. We cannot survive. If you just look at the intestine, gut, stomach, add how many colonies of bacteria exist, starting from mouth, the entire alimentary canal. There are numerous number of bacteria. Lot of them are very important for our survival, useful bacteria. So we cannot eliminate bacteria. There is no world without bacteria. Virus is another domain. But I am telling food agriculture based on that example. Slowly moving to healthcare, where we discover new compounds to be used as drugs. If you have a headache, what medicine you take? Headache? You drink buttermilk or what? No? You will take some medicine, paracetamol, right? Painkiller. It's a bad habit, by the way. If you have headache, you should take rest instead of taking medicine. Don't depend on medicine. It damages kidney. It damages liver also. If you take very often, it's not good. So you take painkiller. That's a chemical compound. And there are many chemical compounds which are used as drugs. These are called small molecule drugs, many of them. And there are many compounds which are called antiviral, antibacterial, antifungal. So there are many chemicals which are used in market as drugs. But the story associated with drug discovery, story is that it takes about 10 to 15 years. 10 to 15 years to discover a new drug and bring it to market. So that means if you have a coronavirus problem today, after wiping out the entire civilization, we will discover a new drug 15 years. So wait in the queue for 15 years. By then we are done. That's smart pathogens are. So we have to be very active, on our toes, ready for pathogenic onslaught. We have to always be alert. And that is where chemistry plays a major role, because it is chemists who can make new compounds. Tomorrow some of them may be drugs, very useful drugs. It is chemists who can make it. Now I will say, hold on a second. Yeah, you can make it in what quantity? Few milligrams, few microliters, milliliters. That's not sufficient. If you want to produce 1 million paracetamol tablets in 2 days, do you think that these standard flask will help? It will not help. You can make some compound with high purity, but nobody is going to take from your standard flask or conical flask or beaker and consume. Nobody is going to do that. Even water used in chemistry laboratory, we will not drink, because we know. We will not drink water from chemistry lab. We will not take that sodium chloride and put it in our food and consume it. We don't do that, right? So chemists are not going to be able to make drugs in their lab. We need help. Whom do we turn to? We turn to process chemists. We turn to chemical engineers. We turn to companies which can make in bulk quantity with assurance that it is pure, no contamination or negligible contamination. We cannot be overly proud if we want to live. If we want to survive, we need help from chemical engineers. So I am adding one more to the list. How big is the list now? Started from physicists, then maths, chemistry was part of it. Now I added chemical engineers, one branch of engineering. Now you made something like 100 kilograms of paracetamol in the form of tablet. And do you think that you can go to every bus stop and railway station, paracetamol, 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 one for 5 rupee? Can you sell it? You cannot sell. You need people who can market it. You need branding. You need companies which can sell it. There is a supply chain. If it is made in Udupi, it has to reach Mumbai. It has to reach Chennai. Who will take it? We need an ecosystem. And it has to be profitable. So we need people with MBA degree who would make this production and marketing more profitable. Otherwise, company will close. You will make only 100 gram and 100 kilogram, and then over. Your career is over. So we need all kinds of people. That's the outlook a young person should have. You may have your passion. Pursue that. Be proud of it. But you also need other areas, other disciplines. That is very important. Now, environmental matters, healthcare. It's not reaching there. It's fine. So, environmental matters. I will show some slides. We are going at such a rate. Plastic is banned in many cities. Our campus, I saw some no plastic zone here, and this college is not promoting or do not want to see plastics. Our campus is supposed to be becoming plastic free. So we have produced at such a rate, oceans are flooded with plastics. Thermocol and many other non-degradable items, we are damaging environment. That is one aspect we should be worried about. Biological systems. There is a lot of chemistry in biological systems. I will show one particular molecule as a representative example in the slide. And then I will also talk about fun with molecules next. And some of you are wondering, if I go at this rate, only 3 slides done till now. If I go at this rate, lunch will be sacrificed. But I will not go. I asked Arun sir to stop me and warn me 10 minutes more, and then I will speed up and stop. So nice pictures in the slide. There are medicines. There is a glass of water at the corner. It has to be pure for us to drink. Water is a major problem. There are different forms of contamination. If you want to purify water, you have to use a lot of chemicals. Alum is one such chemical used for sedimentation, accelerating sedimentation. And then you use chlorine, bleaching powder, to disinfect water. So there are many chemical processes behind door before a bottle of water becomes potable, safe to drink. So there is a lot of chemistry there. Coffee contains several hundreds of compounds. Only one compound we talk about, that is caffeine. There are several hundreds of compounds. Chocolate has similarly hundreds and hundreds of different compounds, and some of those compounds are understood what their function is. Only some of them are understood. And it is also traced that chocolate makes us happy. You heard of this? Chocolate makes us happy. Not due to the sweet taste of it. Chocolate, several compounds in chocolate makes us happy because it interferes with serotonin, dopamine balance, which is connected to so-called, feeling good. Feeling good. So chocolate is used in celebrations because to make people happy, there are certain compounds which induces that, sense of being happy. So there is chemistry everywhere. Agriculture I mentioned for food production, and preservation is another domain. Now before I go further, since that agriculture harvest ready rice from paddy field picture is there, I should mention one more story. The story is about a survey which was conducted by one of the leading magazines in the world, journal we call it, called Nature. Nature is a magazine, highly reputed. They have conducted a survey many years ago, asked scientists, what do you think is the greatest discovery of humans? The greatest discovery. So it went for poll, voting. They took opinion from thousands of scientists. Eventually, can you make a guess? Can you make a guess as to what do you think would have been the winner of this greatest discovery across all human existence? What is the greatest human discovery? What do you think? Any idea? What transformed our lives? What is the greatest discovery of humans? Anybody? Yes. Make an attempt. Huh? Yeah, discovery of wheel. Fair enough. Yes, this was one of those top polled discoveries, but it is not the winner. What do you think? Discovery of iron. Yes, yeah, that's also very important. Yes, discovery of iron, but not the winner. Not the winner. So missing something. Fire. Yes, again polled very well, but fire was naturally occurring. Okay, we had controlled fire. Yes, that was also polled well, but not the winner. Any other guess? Any other guess? Discovery of zero from math, not the winner. The winner is, the winner discovery, the best ever discovery which made a transformative impact on human life on earth is silence. Silence should descend down so that the discovery gets attention. That is N2 plus X unknown, H2 giving NH3. Haber process. Haber process is the highest voted best discovery of mankind. Humans, the best discovery is Haber process leading to ammonia, that is called nitrogen fixation. N2 from air, H2 combining to give ammonia. You want to write a balanced equation? N2 plus 3H2 giving 2NH3. And this is a catalyzed reaction, very, very inefficient reaction, but this is the discovery that transformed our lives. I will tell you why. World population grew. If you have a chart showing number of people, world population and year. Okay. Before Haber process discovered, world population was like this. Up, down, some pandemic, down, next year better. So world population was steady. After Haber process was translated to industrial scale, you will see a huge increase in world population. Why? Is because we could feed ourselves with food grains. It is because ammonia is used in manufacturing of urea, which is a fertilizer, and that fertilizer is the reason why ammonia discovery is regarded as the best discovery in the history of science. You get the connection. Take N2 from air, convert into ammonia, ammonia to urea, fertilizer could grow food grains in much more efficient manner without urea. That is, artificial fertilizer was possible because ammonia production was industrially a real possibility that was discovered by chemists. So what I'm saying that, if at all you are proud of being a chemist, you have a reason for that. You have a reason to be proud of being a chemist because you are the one, your chemistry is the one, you know that it is very difficult to break N triple bond. It's very difficult to break N triple bond and combine with H2 and make ammonia. It is you and your mindset, your knowledge about chemistry that will help you transform N2 to ammonia and then ammonia to urea, and people could feed themselves because of this chemical reaction. You understand the value? Still, the same process is followed for urea manufacturing, fixation of nitrogen from air to ammonia and then to urea, and that process is inefficient, energetically inefficient. A lot of research is going on in making that process, fixation of nitrogen, more efficient by discovering new forms of heterogeneous catalysts. That is being done. Even as I speak, there will be at least half a dozen papers published in 2024 in N2 plus H2 conversion to make it more energy efficient. Haber process is not very energy efficient with efficiency of less than 30%. What energy you put in to make this happen, it's very bad, but that is the main process. So agriculture got hugely benefited by Haber process, which is a simple chemical reaction. Next slide. And you know that I don't have to tell chemistry is colorful. One click. Chemistry is colorful, and a lot of those colors are there on the slide and in real life right in front of us. Chemistry has smokes, yeah. So I played this mischief. I mentioned mischiefs which I played. So iodine with another compound which I forgot, it's done in school, adsorbed on filter paper. You place it on the floor. If someone steps on it, it makes the tap sound. Iodine and tincture of iodine. Yeah. So we played this thing, and when teacher walks into the, you can imagine the fun, right? When teacher walks into the classroom, and teacher would make this tip tap tip sound, and we were like so happy, but we were not caught. That's the fun part of mischiefs. We do this mischief, but we are not caught. And I did many mischiefs. I cannot describe in a public space. In school, I did so much mischiefs. College, I was very quiet. Studies. So coming back to this, chemistry is colorful. It produces smoke. Yes. It can explode. There are many reactions which are highly explosive. Some chemical reactions are very slow. For example, if you look at your aldol reaction, a Diels-Alder cycloaddition reaction, it takes hours, sometimes days to complete. But some inorganic reactions are so fast. Something which you can immediately connect is take a dilute solution of sodium chloride, aqueous sodium chloride, add few drops of aqueous silver nitrate into it. What you will see? White precipitate, immediate, instantaneous formation of white precipitate. But instead of sodium chloride, if you take sodium bromide, what will you see? Pale yellow, but it takes some time. If you take potassium iodide, still you will get a precipitate, but it takes longer time. Inorganic reactions are fast, and that need not be the reason to like inorganic chemistry, okay? Because inorganic reactions can also explode. If you are a safe player, you may not want to touch many of the inorganic compounds which can explode. And it can also implode. There are compounds which would implode, the opposite of explosion. And it's colorful, yes. And it's also peaceful science. Chemistry is peaceful. Next. And it presents us with an array of exciting visual impression that inside that cup, it's liquid nitrogen. Liquid nitrogen, it will flow and create this heavenly feel. You know, solid carbon dioxide also creates this heavenly feel. That is what is used in movies, and these days movies do not recreate heavenly. In our times, romantic scenes used to be in heavenly setting. Okay, the hero heroine would be in a heavenly dream, and then the entire floor will be like fume, but that is solid carbon dioxide. It presents very fascinating, interesting visual impact on the observer. Chemistry creates a very interesting visual impact depending on which among them you would use it. And every bomb will have lot of explosives. Next. If you don't practice chemistry safely, the heavenly feel will transform to entry into heaven. Okay, so that is also important for us to realize, and that's a fun part of it. Chemists know the danger. If someone else does chemistry without knowing what is the danger, they will have the door to heaven very quickly. It would be an accelerated entry into that space. Next. It is adventurous, but the very fact that chemistry is adventurous, very fact that it is likely to explode, you know, what is the fun? There are different aspects of invoking a joke. Suddenly, if I go to the stage and start dancing, you all will laugh. You all will laugh because you did not expect that I'm going to go to the stage and dance. So anything which is like totally disconnected, you bring together, there is a fun element. The fact that a lot of reactions are risky, it can explode any moment, you will be more careful. Still you want to do that reaction. That is the inherent spirit of chemistry. You know that it's dangerous. You know that sulfuric acid is dangerous. You know that concentrated nitric acid would burn your finger. You have experienced also. Sometimes when you pipette out, I don't know whether the blowing pipetting is still a practice or you use this. It's still there, right? When you pipette out and when you do titration, it's very clear that what you can pipette, what you cannot do pipette. There is certain liquid taken in only burette but not in pipette. You should think about it. Why acid is always in the burette but not through the pipette? Because there is a safety. That's what chemistry is exciting, that you know the danger but you still want to play with it. You want to play with that danger. You want to play with that danger. You wish to go to the sea and enjoy the wave, but you don't want to get drowned. That's the fun part. You want to go to the cliff and look at the valley from a mountain top, but you don't want to take one more step. Then it will be door to heaven. So you will not do that. But you really want to go to the edge, right? You want to go to the edge. Lot of chemistry is on the edge. On the edge. If you do 2 seconds of wrong step, you're done. Then you will come back with full black, tarnished. If you have a goggles, of course, you are saved. Otherwise, the full face will be black. So there is a fun associated with dealing with risky things. Next. Next. there can be many situations where the reaction that you're doing would have explosive potential. And that doesn't mean that you should not do. You do with all the safety precautions. Safety in chemistry is very, very important. Next. And that is why the chemistry of azide, just to show that azides are extremely dangerous. It is responsive to shock, responsive to heat, it will explode. The very fact that azides are risky, you know azide, what is azide, right? A-Z-I-D-E, azide. Azide is N triple bond, N, linear unit of N3. You have done diazotization, right? Diazotization, amine to diazonium salt. So chemistry of azides is exciting because it is risky. So a lot of people, their faces are shown there. You don't have to worry about who they are, but they spend their entire life, some 30, 40 years of research working with azides. Look at the fun. They know that it's explosive, but they want to tame them. It's like, Jallikattu in Tamil Nadu, that you really want to tame those bulls and take them under control. That's the spirit. You know that it would explode any time, but with precaution you want to deal with azides. Very interesting. Next. Sometimes on the peaceful side of chemistry. Next. Your senses, sensory perceptions get stimulated by certain types of compounds. That's also interesting fascination. It comes under the lifestyle, and how chemistry permeates in your daily life. I mentioned the vision, the cis-trans isomerization in a molecule called retinol is very important. Some compounds will have characteristic smell, characteristic odor, and don't assume that everything will smell like an ester, right? Ethyl acetate. How many of you are familiar with ethyl acetate smell? Or any ester smell? Ester, yeah. See, this is a question you can easily raise your hand because I cannot prove you're right or wrong. If I ask you this question, how many of you are familiar with ethyl acetate smell? I am familiar. But even if you are lying, I cannot prove. How will I, use a detector in your nose and prove that you are wrong? No, I cannot do that. So ethyl acetate is a pleasant smelling liquid, and there are many pleasant smelling compounds. At the same time, there are certain compounds, if you smell once in your life, just once, if you smell certain compounds once in your life, you will never ever forget. That bad it is. That bad. If you thought that, oh, this is foul smelling, I don't like this odor, not in that range at all. There are certain compounds, if you smell once. So during my BSc days, reaction I forgot long time ago, there was a confirmatory test used for amines by converting into isocyanate or carbylamine reaction. So we mixed everything. Amine was there for sure, but this was supposed to be a confirmatory test. We mixed everything, nothing is happening, and foul smelling odor will evolve. That is what was told in the manual procedure. And we are like using the test tube, taking it closer, no foul smell. And then one of my friend thought that, okay, maybe we should warm it. Okay, so they put this Bunsen burner. Warming is different from heating. Yeah? Heating and warming are not the same. Warming means you have the burner, you will do it, take it off, do it, take it off, and shake it. This is called warming. What this guy did is that Bunsen full, just kept it and talked to someone. How is it going? Okay. And after some time, the whole lab, the entire batch of students rushed outside. It was so stinging that nobody could bear it, and it's also harmful. This was a bunch of boys, so like all boys college, and someone told that it would affect your reproductive organ. So boys started running faster. They ran away. They ran away by the very advice sir had given that this is bad, go away. And they were all fearing their future. They all ran away, and we would, even today, that smell is in my nose. Even today. Another story is that we have to make stock solution. There is no attender in the lab. MSc. I was doing MSc in the same college, government college. No attender. So we are searching for making stock solution, something like, 50 liter or 40 liter, big for the entire batch for whole semester. So I saw a nice glass vessel, no label. It's a 50 liter big glass vessel. I think it is 50 liter. It would be this tall. This shape, this tall. I saw it inside a cupboard. So I took it out. I thought I should clean it. But then me being a chemist, I wanted to see what would have been stored in this before it dried off. So what I did, I opened the lid. Okay, I opened the lid, tried this usual recommended way. Nothing is happening. Then what I did, this is the neck of the huge bottle, 50 liter. I just put my nose inside. All I can remember next few minutes is there were some arrows coming out from my eyes outward and some arrows coming out from my ear. Really, I had felt this something piercing through my eyes, corner and ear. I cannot describe how bad it was. The bottle contained ammonia, dried off, but bottle was used in the past, ammonia. I had life experience. So when we deal with chemistry, sometimes certain episodes you will never forget. And that's the fun with playing with compounds. And we don't have anything dangerous here in this slide. Slides are passive. So next. Another very, very important aspect which we should realize, the importance of chirality. Those who are sleeping, I will suggest you an example to install a sense of feeling regarding what is chirality. I'm not interested in this formal definition. That's not the way I teach. I'm not a formal definition person. I want students to feel what it is. Absorb, imbibe, inculcate. So what I'm going to ask you is to give a gentle shake hand, not a break hand, shake hand. Gentle shake hand to your next person. Can you give a gentle shake hand to the next person? Yeah, shake hand to the next person. Shake hand to the next person. Yeah, yes. Yeah, okay. Now, all of you by default offered right hand. The other person also gave you right hand. Yeah? Your nearest neighbor gave you right hand because you offered right hand. Now I want you to give your left hand for shake hand. Left hand shake hand. Do it please. Left hand shake hand. Yes. So that is also a successful shake hand. Yeah? Both these are successful. Right hand with right hand, left hand with left hand. Now you do a mismatch shake hand. Right with left. You see a mismatch? It's not happening, right? It's not happening. There is a mismatch. Yes or no? Yes. There is a mismatch. When you give right hand and other person offers left hand, there is a mismatch. No, there is no mismatch. You are just holding hand, you are not shaking hand. These are two different things. Shake hand, there is a mismatch when you offer right hand for a left hand. There is a mismatch. You felt it or not? You felt there is something incorrect, something wrong. The feel of shake hand had not come. The feel was missing. Yeah, feel was missing. And by the way, those who work in corporate sector would know the importance of shake hand and non-verbal communication and body language. I don't have time to go into that, but whosoever is interested can meet me after my lecture. There are so many aspects about non-verbal communication corporate companies are interested in. And in their hiring, there are not just experts of the subject, there are experts who would assess. I'm talking about like huge multinational corporates. It won't happen in a small startup. Don't mistake me for that. So huge multinational corporates, there are experts who are brought into the committee to assess, to judge candidates EQ, CQ in addition to IQ. IQ is judged by subject experts. EQ, what is EQ? Emotional quotient. Emotional quotient. Now, companies have realized CQ is more important than EQ. What is CQ? CQ is called compassion quotient. Compassion. How much you care about others. How compassionate you are, they have strategy, techniques to assess this. And if your CQ is low, IQ, EQ is good, you still don't get the job. Okay, so we can talk about like the shake hand exercise. 10 minutes. The shake hand exercise is a demonstration that chirality is very important because your hands are chiral. But if you were to use a sellotape and tie this thumb in this manner, right hand, right hand, right hand, left hand, left hand, left hand, all will be successful shake hand. Because it's a thumb which makes the difference. It is that this thumb makes the shake hand successful or mismatch. So chirality is omnipresent in nature of things. In our enzymatic system, there is a cartoon shown here, a drug molecule binding to a receptor. The cartoon on the top is the yellow block is the receptor, which could be an enzyme or a binding pocket in a biological system. And if you use the opposite chirality, that means interchange the position of substituents on the chiral carbon, that opposite chiral compound will not fit into, that is like your mismatched shake hand, it will not fit into, therefore it will not be able to do its job as an efficient drug. So chirality is omnipresent, and it is again the territory of chemists who understand chirality, who understand optical rotation, who can also make optically pure chiral compounds. It's hugely a territory of chemists. What is known as a broader area known as asymmetric catalysis or asymmetric synthesis, chemists can make compounds with high optical purity. Next slide. There were dangers we have learned from the history. Dangers, I'll just go through this second example, thalidomide. Thalidomide was a dangerous lesson which we learned in the practice of drug discovery. This compound was given to pregnant women in the US for many years, about a decade, in the form of a racemic compound. It was administered as a racemic compound. You see at least one chiral center, star carbon, that's a chiral center, the hydrogen is not shown there. 4 different substituents on that carbon makes that carbon chiral. So it could exist in R or S enantiomeric forms. The racemate will consist equal proportion of R and S. That is how the drug was administered. And several babies born during those decades had birth defects, and some were born dead. So this is a serious thing. But this was a startling revelation of how important chiral compounds are when you use it as a drug. You have to be very, very clear that both enantiomers are non-damaging. Okay? It was true that our enantiomer was useful to suppress nausea in the first trimester of pregnancy. It was useful. It was effective. But the other enantiomer was very bad. So chirality is important in our life and living. Next. I will skip this enzyme slide. I'll go to something which is now I'm prioritizing what I should be talking. So I talked about ammonia. I talked about Haber process. This compound, which looks very small and innocent, that is the basic backbone of penicillin. One of the greatest discoveries. It was also an accidental discovery. This compound, you look at the first line, the discovery of antibiotic. Before antibiotics, average life expectancy globally was 47 years. After antibiotic was available for treatment, life expectancy in 10 years of antibiotic discovery gone up to 78. This is in Europe, unfortunately. Yeah, so this is European statistics. That's impact. This is a compound which could save lives. A small compound which could save lives. And if you think that, okay, what is the use of saving life? But if you are interested in money, you can make a lot of money also. That compound, beta-lactam antibiotic, is sold by SmithKline Beecham. It's one of the largest pharmaceutical company. They make a lot of money just by selling one compound. And there is a lot of money also in chemistry. Just that your compound should click and become a life-saving drug. Next. It overlaps with many other fields which I would not like to go into. Next. There are lots of equations. This is just to tell you that all these, what chemistry could accomplish, was due to a very simple approach chemists have taken, that they believed in power of observation. All of them believed in the power of observation. And we are all trained to observe, but we don't translate that into action. Many interesting observations which you would have come across, we just observed and ignored. These people who discovered great things, they did not stop merely by observing them, but they went ahead and thought about it, worried about it, lived through those observations, wanting to find a reason, what is behind it, that makes a person a scientist. The power of observation. And I have a very interesting long-term project for school children to inculcate this value of observation. Some fascinating molecule fun with chemistry. You studied a carbon-carbon single bond distance is 1.53 Armstrong is what textbook would say. Very fact that it is 1.53, people wanted to make longer and longer carbon-carbon single bond. Here is a compound which is shown. The carbon-carbon single bond is 1.64 Armstrong. Does it matter? I would say, oh, it doesn't matter to you. But look at the scientists who wanted to make the carbon-carbon single bond longer and longer than what is known. That is again spirit of chemistry. Again, spirit of chemistry is to think about unusual situation, think about rare situation, and go and accomplish that. That is again something which is interesting. We have certain names and there are analogous compounds also. Pina colada, you would have tasted it in some parlor, right? Pinacolato-diborane. First row, pinacolato-diborane. There are some similarity, but pinacolato-diborane you cannot drink. If you drink, way to heaven. Cubane. And chemists did not stop there. These are real compounds. Huh? They made it. It was not easy to make. They made it. If cubane is there, I want to attach a handle and make it basket. So there is a compound called basketane. They made it. Here we are celebrating chemistry. If there is cubane, oh, why not attach a handle so that I can carry it to market? So they made basketane. It's a diselenide compound. Selenium. It's instead of diketone, oxygen, sulfur, selenium, the same group. So it's a diselenium. What do you think the name of this compound should be? Who is this? Famous pop singer, Celine Dion. What's the name of that compound? Celine Dion. Next. You know that yellow character? Your favorite childhood character? Pikachu. And there are compounds named after Pikachu. Picachurin. It's a protein. There are many, many fascinating compounds. People made it for sake of making it. You understand that spirit? Art, you make a painting, not for sale, not for anybody's satisfaction. You make it because you like it. You made an artifact. You made it because you like it. That is again the spirit of chemistry. Chemists like to make compounds, and they're made and given all these. Pac-Man. Pac-Man is a game. It is a game of 80s, 90s, but not anymore. You have like much better. Is chemistry related to rocket science? Yes, there are many rocket propellants. Next. I will not have time to go into molecular motors, self-propelling molecular motors, Nobel Prize winning discovery. Next. Yeah, so future of chemistry, this is of some relevance to you. It's overlapping increasingly with many other domains. For example, my laboratory looks at use of artificial intelligence in chemistry, in discovering new reactions, in discovering new catalysts. That is my interest right now for the last 5-6 years. That is one direction it is going. Sustainable chemistry, green chemistry. There are some mention about that. There are some presentations in this conference itself. These are new directions. But chemistry is going to survive as long as we live on the face of the earth, because it is so much needed for our survival, and that is why we wish to celebrate chemistry. And that was my objective today, to share with you some examples, share my personal anecdotes, and to install you a sense of belongingness to the larger umbrella of science, and be a proud chemist who coexists with every other branch. And in regards to your future, career ambition, long-term plans, there are so many opportunities. If you can work hard and come to the top 5%, top 10% of meritorious students. Come to that top 5%, 10%. It is very easy to be in top 5%, 10% in your class, in your university, in your college. Why is it so easy? Because 99% people are not interested. So if you study little bit, you will naturally migrate to the top 5%, top 2%. If you are in that top 5%, 2%, you have a great future. Many of my former students are in exceedingly well-paid jobs in pharma industry, in companies which does materials chemistry work, companies which are involved in drug discovery, the kind of drugs which I talked about for equipping or making us ready for next pathogenic attack. There are many of my students who work in industry, and many of them are professors, faculty members, but they all were in that top 5%, 10%. And how do you come to that group of 5%, 10%? It's left to you, it's your choice. What is that choice that you have to make? Work hard. Keep your phones away. Don't look at WhatsApp for next 2 hours. These are very simple recipe. You know it. I don't have to tell you. You know where the enemy is. In your own bag. In your own pocket. Enemy is within. No one is attacking you. You are allowing these devices to attack you and letting it be a surrender point. So if you are willing to work hard, you don't have to, at the BSc level, you do not have to read not more than 5-10 books. And I can give you a list also what books you should read. But if you can read those books relevant to topics that you study as part of syllabus, you will definitely be in that top 10%, top 5%, top 2%. Then you can aspire to be someone, a chemist who would be proud, who would be willing to contribute to the world. With that note, once again I wish you all the very best. Study well. Chemistry is wonderful, and chemistry will give you a life. That's the message. Thank you.
Thank you, sir. Now it is time for question and answer session. I request the audience to participate in the interaction. Sir. Any questions?
See, they all have question, but they don't want to ask in public. Because if you stand up and ask a question, your heartbeat will be 110 per second, not second, minute. But they all have question, many of them have question. But our social, cultural setting is such that whole life revolves around what others will think about you. I work at that bottom level. I work at the mindset of students. I encourage a lot of questions by directly talking to you, but it may not be very easy for you to get up and ask a question. I totally understand. But if you have a question, do meet me after outside this auditorium. I'll be happy to answer. If someone is able to control their heartbeat, may still try asking. I told you can ask outside the auditorium. Some people have already left. They are waiting.
So I sincerely thank Dr. Raghavan B. Sunuj for spending his quality time and sharing his valuable thoughts about the importance of chemistry in daily life and in laboratory, including the uses and applications of various compounds of chemistry and how chemistry affects our daily life through insightful presentation. Thank you, sir. Now I request Dr. Babu M., Department of Chemistry, to present a memento to the guest speaker as a token of gratitude and respect. Thank you, sir. Now there will be a short tea break for 5 minutes. Immediately after that, we will begin the second session. On a concluding note, I express my gratitude towards all the members of organizing team for giving me this opportunity of comparing this session. Thank you one and all.
Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field.
we will start our second session. So I kindly request everyone, please take your seat. A very good afternoon to all of you. I, Mahesh A, Department of Chemistry, stand in front of you to welcome for the second session of this national level seminar. It's my immense pleasure to be a part of this session. Now, I request our resource person, Dr. Sasidhar B.S., Principal Scientist and Associate Professor, CSIR, National Institute for Interdisciplinary Science and Technology, Thiruvananthapuram, Kerala, occupy the seat on the stage. It's a proud privilege for me to introduce a most eminent speaker, Dr. Sasidhar B.S., to the gathering. Dr. Sasidhar was born on 23rd August 1984. He did his BSc in 2004 at Vijayanagara College, and then his MSc in Organic Chemistry in the year 2006 from Gulbarga University. Sir obtained his PhD in 2012 from Gulbarga University for his research on the topic entitled Synthesis of Novel Heterocycles of Biological Importance. With over a decade of research and professional experience in chemical science, his contributions covers multiple domains including chemical biology, medical chemistry, natural product chemistry, process chemistry for APIs and agronutrients. Dr. Sasidhar has a very high professional experiences. His professional journey includes several key positions, processing from a scientist C to the current role as a principal scientist at CSIR NIIST. In addition to his role at NIIST, Sir also serves as an associate professor at Academy of Scientific and Innovative Research. He has been honored with numerous awards and fellowships throughout his academic and professional careers. He secured 4th rank in his MSc in Organic Chemistry at the university level. He received University Merit Fellowship for Research in 2007 to 2008 and the UGC Research Fellowship in Science for meritorious students. He has also been awarded the Young Scientist Award by Mysore University, the Indian Society for Analytical Scientists, and the Kerala State Council for Science, Technology and Environment, Government of Kerala. Additionally, he earned the CSIR Senior Research Fellowship, Associate Fellowship of the Indian Academy of Sciences, Bangalore, and the CSIR Young Scientist Award in 2019 from the Ministry of Science and Technology, Government of India. Sir has completed nearly 15 projects funded by major agencies like CSIR, the Kerala State Council for Science, Technology and Environment, along with 5 industrial projects. In addition to his research, Dr. Sasidhar is deeply committed to education and mentorship. He has successfully guided 6 PhD students to completion, and currently 8 students are pursuing their PhD under his guidance. He also mentors postdoctoral fellows and research associates. Over the course of his career, he has published approximately 90 papers in peer-reviewed international journals, and more than 40 conference papers were presented. He has filed 8 patents and 2 more patents are under filing in the area of drug discovery and process chemistry. These reflect his innovative contributions to the field of chemistry. Dr. Sasidhar regularly serves as an external examiner for PhD Viva work examinations at various universities across India. He also serves as a reviewer for many prestigious scientific journals. He is actively involved in a number of scientific organizations, including American Chemical Society, Royal Society of Chemistry, Indian Chemical Society, and many more. With this, I am very happy to present to you Dr. Sasidhar B.S., a humble person with immense caliber. Sir, we are very happy and proud to have you in this event, and a very warm and heartfelt welcome to you, sir. Now, I request Mrs. Priya florally welcome our resource person, Dr. Sasidhar B.S. Thank you, madam. I would now request Dr. Sasidhar to take over the session on the topic modern chemistry, technological advances and career horizons. Over to you, sir.
Professor Arun Kumar, my sincere thanks to you and all the organizing committee members. So I sincerely thank Principal as well as Professor Arun Kumar sir for inviting us and giving this opportunity to share our experience and thoughts on the advances in chemistry as well as the interdisciplinary advances in chemistry and associated areas of research. So Professor Sunoj has made my job easy because he already gave a quite nice introduction relating to the associated relation between chemistry as well as the other subjects of science and the other subjects of commerce and other things with the chemistry as well as with our life. So my job is now made easy. So I will be talking to you in the next 30 to 40 minutes what are the important opportunities in chemistry and associated areas, along with the what are the recent advancements in the chemistry and what are the important areas of associated chemistry and then areas which you people will be interested in pursuing after your MSc or during your MSc course. So before I just start my presentation, I would like to give you a brief introduction or some concepts in the SDGs. You all know what is SDGs, right? Sustainable Development Goals. So being a scientist or being a common man, we need to be responsible in protecting our universe, in protecting our society, in protecting our surroundings. So to eliminate this or to protect this, the United Nations has come up with some sustainable goals. So what are the sustainable goals? So these are some of the important sustainable goals. I have a pointer. Can I get a pointer? I'll check. If it is working, then I'll use. Yeah, to some extent. Okay. So these are some of the important, or these are the 17 sustainable goals which is formed by the United Nations organizations along with in discussion with all the scientific nations. So what are these? No poverty, okay, zero hunger, food, health and well-being, quality education, and there are so many other things. So among this, there are very important things as a chemist or as a scientist or as a professor or as a researcher or even as a common man, we want to contribute to these, some of these sustainable goals. Otherwise, we cannot see the next generation, right? So among them, no poverty, right? Zero hunger, quality education, health and clean water. These are the, some of the important areas where chemists as well as science can contribute to in conservative way. Okay. So we all say that sustainable goals, sustainable chemistry, sustainable science. What is sustainable? As Professor Sunoj rightly pointed, so we came at the end, or we are not the first to come on the universe, right? Already there were a bacteria, there were a plants, there were animals, so we came after them. So when we talk about chemistry, when we talk about science, we have to keep in mind that whatever we develop, whatever our advances should not affect the plant community. It should not affect our microbial community. So we are part of that, or we are associated with them. So that is what happened, the viruses, or you can see that there are a lot of other microorganism affected pathogenesis. So these are all evolving because of our intervention with them. So we are trying to destroy them. So we should not destroy them. So we have to live along with them. Then only we can survive. So the sustainable chemistry or sustainable science is done in association with the people, planet and profit. So what it says, it should be bearable, it should be viable, it should be equitable. Whatever we do advancement, either it is a chemistry, physics, mathematics, AML, anything, right? So you have seen a lot of AML, artificial intelligence. So we have a more positives, and more than positives, we have a negatives in the drawbacks in the AML. I am not demeaning anything, but we have to use it in a proper way. So more technology is more dangerous. At the same time, if you use it for the proper way, technology can take to us in a higher levels. Okay, and we call a health. See, we all talk about health. So health is not only about our human beings. So health, when we say one health, so one health is concerned with the animals and plants, right? So whatever we do, developments, we should keep in mind that it is not only for the human beings. Our science should help society, universe, in total. As he rightly pointed, there are some climate change impacts, right? Chemistry can definitely contribute to that. Physics can definitely contribute to the biotechnology, biochemistry. All these branches can definitely contribute to the climate change, in conserving the climate change. What are the issues in recent times? What we have seen the reasons for the climate change: increased salinization, increased floodings, rising sea levels, increased droughts, increased desertification, increased temperatures, increased CO2. So these are all because of climate change. So who are the root causes? Who are the responsible for this, for climate change? We are the people who are responsible for the climate change, right? Unplanned urbanization, unplanned usage of chemicals, right? Unplanned urbanization, and then we are using overusation of chemicals, and so we are using, for example, we are using antibiotics, right? So antibiotics should be used in a proper way. It is a prescribed medicine. If you see now in most of the places throughout India, so we don't go to even a hospital or take a prescription from the doctor. So when we have a sore throat and we have a slight fever, we immediately go to the medical shop and take azithromycin, which is not correct, because as he pointed out, but he did not continue the discussion, Professor Sunoj. So why this antimicrobial resistance is coming? Has he taken example of agricultural pesticides? After 5 years or 6 years, so they could survive even a full complete concentrated pesticide. With that they could survive. The insects, the pesticides could survive because they got a resistance. Similarly, if we keep on taking the continuous usage of these microbials, antimicrobials, or what we call it as a antibiotics, so we are going to face in few years, maybe in few decades, another 1 decade, we are going to face a problem where no antibiotics will work. no antibiotics will work. You forget about cancer, you forget about COVID, right? You are going to be affected with a small microbial infections. See, during the any surgery or during the any operations, a simple operations, after that people are given antibiotics to heal the inflammation, right? Assume that a patient with a cancer has been treated, but he is supposed to treated with antibiotics because that inflammation has to be cured, or he has to be protected with the surrounding microorganisms. Assume that if it is the antibiotics is not working in a particular person, so there is no point in curing a cancer. It again recaptures because you are going to be affected with the microbial infections, pathogenesis. So now at present we are almost having, I think, 5 to 6 antibiotics. Once upon a time when we were kids, or when during my father's generation, we had around more than 15-20 antibiotics, but now only 5 to 6 antibiotics are more effectively used, because all other antibiotics are now resistant to the microorganisms. They can eat the medicine and they can survive. That is because unpracticed way of usage of antibiotics. So based on this, in the last few years, I think in the last 5 to 6 years, throughout the India, including Karnataka government, Kerala government, in association with the health ministry, they have given a strict guidelines that we should not use the antibiotics even for small things. It could be taken under the strict guidelines of doctors. So keep in mind, this is a great guidelines I am giving. And then of course, impact on agriculture, increased disease severity, lower disorder. These are all impact on, at one side we are improving our science, at the same time we are actually destroying our surroundings, our soil. Like we are overusing the pesticides, we are overusing the herbicides. So these are all to be stopped. We can look into the organic farming. That is a one major implementation, or we can look into the more controlled way of farming. Okay, I will just take a quick tour. What is the research? We are all talking about research, right? It is nothing new. There were incidences where our ancestors, they have done research, but only they did not call it as a research, because they have discovered our ancient traditional medicine. We have a lot of examples. What is the research actually? So make an observation. It is nothing but just make an observation. If something is moving in front of you, or something color changes, or if you are seeing that there is a sudden rain, right? It's not a rainy season, but there is a sudden rain, huge rain, which is not supposed to be. So you need to make an observation. You need to find out why it is raining. This is not a rainy season. So there may be some root cause for that, right? So these are the questions you need to ask. Why? See, we are affected with the COVID. So why it came actually? What is the root cause? So that is called as a research. So you need to observe and need to ask questions and come up with the solutions. So what is the research? Make an observation, ask a question and form a hypothesis that answers the question. What is the hypothesis? What is hypothesis? What is the hypothesis? So putting forth your ideas and finding a root cause or finding a reason for it. So that whole process is called as the design process is called as a hypothesis. And do an experimentation and analyze the results, and then if the hypothesis is correct, report the results. See, without reporting a result, so no science survives. You have to report a science. So this seminar, see, I am talking to you, I am sharing my knowledge. This is kind of a reporting my knowledge to you. So similarly, there are many ways where you can report your knowledge, where you can report your results, where you can findings you can be reported, discussed with the audience, scientific people, non-scientific people. That is actually sharing a knowledge. That is a very important thing in the research. Until unless you share your knowledge, your results, your hypothesis, research is nothing but a waste. Okay. And if the hypothesis is incorrect, okay, but still you need to report the results. Why we need to report even though it is a false or it is a wrong, but still we need to report a results, though it is a wrong. Why? A wrong result also gives a kind of information to the society, so that nobody should follow this hypothesis, nobody should follow this idea. So they should not waste their time by following this. They can try a new ideas, new findings. Okay. So this is what a simple research definition or a hypothesis looks like this. So as I said, what is chemistry, or what is the research, or what is the research in chemistry? It is, as this picture shows, it is very big, it is humongous. There is no limit for it. You can see that, right? A guy is standing here and then looking at a top of a hill with a large waterfall. It is like this. You can have a n number of observations, like, right? There is no limit for your imagination. There is no limit for your observations. So that is called as research. So nobody will stop you. It is an infinite, right? And why we need to do chemistry? I will take you to the next slides. Okay. So after doing chemistry, or after pursuing a science, so where we are going to end up, right? In an education system where you can be a teacher, professor, or a lecturer, you can be a tutor, and in industry, right? It can be an institute, or it can be a private funded, government funded, or it can be an industry, or it is a small company where you can yourself start an entrepreneur, you can become an entrepreneur. This is the era of entrepreneurs. Now a MSc student can become an entrepreneur. Even a graduate can, BSc student can become an entrepreneur. Nobody stops you from becoming an entrepreneur, right? There are a lot of opportunities, there are a lot of progress. Even engineering kids are becoming entrepreneurs. You have an open platform. Ideas can be shared. It can be shared with the international community. You can get a fund from the different countries. You need not to worry about what is happening in India. If nobody supports you in India, your ideas can be shared with other people. Any globally, global platforms are there. So what is important is, you need to think, make an observation, and try and attempt, give an attempt to solve the problem. You need not to have a degrees, you need not to have a PhD degrees, in fact, right? A serious committed attempt in solving a problem can take you to the global level. There are n number of people, but a serious try, a sincere try is required, right? Without giving 100%, nothing can be achieved. So where chemistry could take you, right? It can take you to the exciting areas. Every day is exciting for us. Every day we do research, every day is exciting for us. Hundreds of failures will give us a path to the next idea. In the last 15 years, in my research at CSIR NIST during PhD, I might have failed few lakhs of times. So success rate in chemistry is only 1%, or less than 1%, right? But there are lakhs of ideas which failed, but that failed ideas will give me a boost, a inspiration, a power, energy to pursue, come back tomorrow, think today night and come back tomorrow, start again one more reaction, start doing it, a new catalyst synthesis, a new material for biomedical application, a new material, a fluorescent molecule, right, which can sense a toxic chemical around us, which can sense a virus around us. These things are happening presently in India. You forgot about other countries. Even in India, we have a sensors. You just put it on a door, you can sense a virus. You can even sense a virus within a few minutes. You need not to sample it and go to the HPLC, go to the biomedical, go to the hospital. Sitting in a place you can sense. You can kill the viruses. You can kill the bacteria by using a small AC kind of a setups. These are all innovations, these are all advances in the chemistry, these are all advances in the science. So these are all coming from people like us. Those people are so once upon a time graduates from M.G.M College or from S.D.M College or from Vijayanagar College, right? In and around, these people were like us. So the chemistry is exciting, it is highly challenging, right? Chemistry is very challenging because it deals with a everyday problem. You have lakhs of problems. See, right, starting from, I'll go to the what are the the recent advancement, what are the key areas which you can pursue. So in a nutshell, we have a problems or issues, challenges related to medical field, right? Until we survive, we need a drugs. Can you imagine a day in a human's life surviving on a earth without a medicine? Right? Impossible. We need a medicines, because we are facing continuous, in the last, I think especially in the last 1 decade, we are facing so many new diseases. You take an example of COVID. There are n number of viruses, especially in the Kerala and then Mangalore and this area also. There are Palakkad. There are so many the viruses originated from the bats, animals, and then new pathogens are coming up. So these are all, we are facing a big challenges. So we need to come up with the more advancement, stringent advancement, very quick advancements, right? We cannot take a, see, as he pointed, the drug discovery starts from a almost 10 years to 12 years. It's a timeline is 12 years, 10 to 12 years it takes to discover a molecule which is from the lab to the market. During COVID, what happened? Did we take it 10 years? How many months we took? How many months we took to market the anti-COVID drugs? Any idea? In principle, according to the classical rules or practically, it takes minimum 8 to 10 years, even if it is the quickest. But during the COVID, how many months we took? Not years, you forget about years. How many months we took? 3 to 4 months we could release the medicines for a COVID, right? So fortunate to say that we were also working on some of the antiviral drugs during the COVID. So just 2-3 days we took a rest, and then immediately PMO office called us, like labs like us, and they are given a charge of around 15 drugs which could save our life. And from the next day, once the India got hit with the COVID, we were working on this medicines, new drugs, process chemistry, and revisiting the existing drugs. So these drugs are there already for the some other viruses. It is not for COVID. It is for, there are so many viruses, right? The drugs are used for so many viruses. So it can be, so what our job is to see that whether it can be used for the particular COVID, and do analysis, do the tests, in vitro tests, in vivo tests, in collaboration with so many labs. This terminology is called as a repurposing of drugs. Drugs are existing, but whether it will work for a COVID, we want to revisit its application. That is called as a repurposing of drugs. So that is one of the existing process, but we took the advantage of that process during the COVID, and we could generate at least 6 to 7 molecules, and then the ICMR, Indian Medical Council, had tested this, and within 3 months they could release this and give a notice that yes, this can be used for a, not for a complete use, for a emergency use, only for emergency use. Okay, and as I said, chemistry is yummy, right? Why it is yummy? So in pizza, right, every day we taste pizza and then KFC chicken, right? So it contains a lot of additives, right, pizza, and it contains a lot of sweeteners, edible sweeteners, which are allowed to add into that, a lot of ice creams. So where these come from? These are all identified or synthesized or prepared by a chemist, right? We take a morning, every day we take a mug of coffee, right? So to make a coffee more tastier, there is a difference between each brand. You start from a local brand to the Nescafe, there is a huge change, right? So there is a R&D going into that. There is a huge R&D going into that. So they make a different formulations. Chemistry people work on different plant varieties. They make a different formulations, lakhs of formulations, and based upon the taste, based upon the immunity boosters, based upon the health benefits, they fix the cost, right? There is a 100 grams, there is a 200 rupees coffee, there is a 1000 rupees coffee also, right? There is a 100 gram quantity, there is a 1000 rupees coffee brands also. Why it is so costly? Because of there are some health benefits in the coffee. So each formulation contains, or each coffee variety contains a different kind of a secondary metabolites. These are all called as a secondary metabolites. Secondary metabolites means molecules. There are a lot of chemicals present in that. Okay. So chemistry, if you pursue, it is ME. So don't worry about jobs. People may say that no, we don't get a jobs. Chemistry people won't get a high paid jobs, but that is false. I can show you this very nice graphics which is released in 2022. See where the chemistry people will end up. So chemistry graduates or chemistry researchers, where they end up, how they get the jobs. See 15% are basically work in the biomedical applications, around 30% is in the university, and 20% in the consumer goods and other manufacturing. Around 16 to 20% basically work in the medicine and research fields, around 15 to 20. And there are miscellaneous people, miscellaneous percentage where they work in the energy and then environment. And there are so many opportunities like discovery, right? We see a lot of discovery channels. You know, there is a huge requirement of chemists there, huge requirement of environmental scientific people from there, because what they do is a high discovery. They discover things, they do a lot of research. So even chemists are needed for the discovery people. NGC, right? These channels actually do a lot of science, a lot of chemistry. They spend a lot of time in the forest, in the waters. So these people also required a support from the chemistry graduates. So chemical scientists are well paid. Don't fall for the media reports and all. So chemistry graduates get 15% high started salaries compared to the average graduates, right? And chemistry graduates have a high employment rate. 70% of the chemistry students enter a professional managerial roles, right? Don't think only IT, BT is good. So you have a chemistry, physics, there are basic sciences. There is a huge opportunity for the basic sciences. So basic sciences, chemistry, physics, mathematics, botany, zoology, everybody will have a huge opportunities. Only thing is you should have a focused attempt. So what is chemistry? You all know. I don't want to go into the, but if you look into the what is modern chemistry, so modern chemistry is a study of matter, its properties and changes it undergoes. So importance is foundation for various industries, like as I mentioned, pharmaceutical industries, biomedical industries, nano, materials, and now recently there are so many dyes and pigments which are having a huge applications in day-to-day life, security, sensing, right? So these are some of the important areas one can pursue. So integration with technology, sustainability and interdisciplinary. Now the present end is interdisciplinary. So if you are sitting alone in the chemistry lab and working, you are not going to reach to the higher levels. You are not going to achieve your target. So it is all about a interdisciplinary. So you need to collaborate with the chemistry, you need to collaborate with the physicist, you need to collaborate with a mathematician, you need to collaborate with a biochemist. So it is a global research. We need to collaborate with the different people, take ideas from them, share your knowledge with them, and then we can do wonders. So these are some of the key technological advancements are next, at least for next 10 to 20 years, one can think of, or once you enter into the MSc, you can think about these areas which will be there for at least next 2 to 3 decades, which you have a scope for the growth. So one is green chemistry. Of course, green chemistry started long back, but still even today, green chemistry is the way forward. Without green chemistry, we are not going to do the more innovations, more advancements, because so the government is stopping throughout globe, even in India, they have stopped usage of n number of solvents. We cannot use now chloroform, right? We cannot use, now European countries have stopped using the dichloromethane. Until now it's still India is using, we are using, but now they have stopped using a dichloromethane. DCM they have stopped. Chloroform is stopped in many countries. Acetic anhydride is banned. You cannot purchase acetic anhydride. So what we have to do? We need to do a lot of reactions with acetic anhydride. DCM is required, chloroform is required in many fields in chloro. So what is our next way forward? So we need to look for the alternatives. What acetic anhydride can do, can we have a replacement for it, which is a greener chemical, which is a less hazardous than the acetic anhydride. Any replacement is there for a chloroform, any replacement is there for a hexane, dichloromethane. These are some of the new innovations required, alternative chemicals, alternative solvents. So when you think of alternative solvent, first thing comes to our mind is water. Water is the universal solvent which anybody can use, nobody can stop us. Can we create a good chemistries? Can we do a chemistry? Can you do a reactions? Can you replace with the methanol, ethanol with the water? Yes, we can do. Yes, we can do. There is a huge research is going on. By adding a water, we can do n number of reactions. There are so many people, fresh PhDs in various countries, including India. So water research has been funded hugely. If one among you is interested in doing a water research, believe me, you have a huge scope. Because water is cheap, water is non-hazardous. Anything you do with the water, it will be a pure gold. It is more than gold. Okay. How to do a reactions in water? Because solvents, as I said, chloroform or DCM, they have a activation energies. Water doesn't have a activation energy wherein it can activate the chemicals. Externally, we have to supply a activation energy by means of what? Catalyst, right? Again, if you are using a chemical catalyst which are hazardous, again you are spoiling the environment, right? So the new catalysis comes into the picture, that is photocatalysis. This started around 5 to 6 years back. Of course, photocatalysis was there even when my guide was doing a PhD, but that is different. This is a visible light photocatalysis. So by using this LED light, one can do a huge number of cycloadditions. One can do a Suzuki coupling, one can do a Miura coupling. Lot of reactions are now people are pursuing in water with a activation by using a photocatalyst, right? Photocatalyst is non-hazardous. It can be preparable indigenously in India. So these are some of the areas which are very, very important and which will be having a bright future in coming years. So example, use of renewable resources and eco-friendly solvents. Another important eco-friendly solvent is ionic liquids. Ionic liquids are non-hazardous. So you can replace with the chemicals or you can replace with the hazardous chemicals and you can use the ionic liquids. The advantage with the ionic liquids is you can reuse it. It can be separated from your reactions in day-to-day reactions and it can be reused. Not all, but there are few ionic liquids. And then photocatalysis I already mentioned. Nanotechnology, you know very well in nanotechnology. So nanotechnology has a wonders for us. Still nanotechnology, chemistry related nanotechnology or scientific related nanotechnology is having still a huge boom because of design of nanomaterials for electronics, healthcare, energy. So there is a nanomedicine for targeted drug delivery. So what is the difference between normal medicine and targeted nanomedicine? Do you know any examples? What is the advantage? Targeted nano delivery or just a medicine. So any medicine can be converted into any medicine. Any medicine can be converted into nanomedicine and it can be made into a targeted delivery medicine. What is targeted delivery? What is the difference between normal medicine and targeted delivery medicine? Even if it is wrong, no problem. So you can just tell your ideas, what you feel what is targeted delivery. So let us take an example of COVID is anyway, more examples we have taken on COVID, we will take an example of cancer, right. So when we take a chemotherapy, a person when undergoes a chemotherapy, what happens? So the cancer may be a lung cancer or a blood cancer or a bone cancer or a breast cancer. There are different cancers are there. But a person when he is undergoing a chemotherapy, what happens? Do you feel that it only treats a breast cancer, or it only treats and affects only a particular lung cancer? Only that it can kill a lung cancer cells. Is it true? Medicines people may claim, right? Brands may claim, but in general, in reality, 70% of the normal cells also get affected, right? Whatever we have a third or fourth generation or a second generation anti-cancer agents, right? Cytotoxic agents. In India, we don't have any medicine which can kill selectively the cancer cells. But of course, in abroad, they have some specific medicines which can kill specifically, selectively cancer cells. That is the reason when you see that there are a lot of celebrities, lot of sports people, when they get affected, they will go to abroad and they take medicines from the abroad, which are not available in India. But the price is around 100 folds. Chemotherapy itself is a huge, right? It is a huge burden, financial burden. It takes more than some crores. The medicines which in European countries or USA, for the same cancer, what they are giving to their patients, it is much costlier. I am saying 100 folds, because it can selectively kill. That is through the target delivery. So they use nano carriers. Or these drugs are made to attract specifically to a particular receptors. There are receptors in the cells. So these molecules can go and affect only that receptors which are responsible for the cancer. So in this case, nano deliveries, nano medicine will help us, right? Of course, artificial intelligence. So I am not expert in this. So Professor Sunoj was expert in this. Now we have a lot of boom in the artificial intelligence. So at the same time, there is a huge alert in artificial intelligence. It can destroy a world, because it is easy to sit here and then mimic a similar kind of a person in elsewhere, and it can do what 100 peoples can do. So it can take away 100 people's job. So there are some alerts. So I will not go into the artificial intelligence, but at the same time, if it is used for the right way, it can benefit. It can give an idea how to design a catalyst, how to design a molecule based upon your existing knowledge, based upon your existing models. So this is again one more important areas or specific areas where one can pursue your areas, like material science. Material science is now a chemist, a physicist can pursue a material chemistry, and he can easily enter into electronics, medicine, environmental remediation. What is environmental remediation? A chemical or a material which can degrade a plastic, right? Plastic is a huge problem. It is an unsolved problem throughout the globe. If somebody comes with the idea where a chemical or a process can degrade a plastic, it is going to be a $1 million company, or it is a $1 million entrepreneur. He can become $1 million. He can be a global hit. So think something where without causing a environmental pollution or hazardous, if we can break down this plastic into a small polymers or small fragments, so it can be a game changer throughout the world, not only India, because plastic is entering into our body, not only ocean. Plastic is entering into our body through meat, through fish, through chicken we eat, right? A cosmetics we use lot of cosmetics, right? Creams, facial creams, face wash, all these contains a microplastics. All these contains a microplastics which you are unable to see, but there is a huge amount of microplastic present in that. Where it goes? When we wash our face, it will go into the water, again it will go into mix into the environment. We use chemicals, we use shampoos, everything contains a microplastic. Green chemistry, medicinal chemistry. So medicinal chemistry, I will talk about medicinal chemistry in the coming slides. Of course, as I said, go back. Yeah, so of course, as I said, climate change, environmental chemistry, quantum chemistry, you can see there are n number of applications from the smart materials. This is the era of smart materials. Everything we want as smart materials. The phone we use has at least 50 smart materials in the phone. 50 smart materials in the phone. A battery, a coating material, a glass, right? And the keypad, it is a smart material because it is weightless. Your entire application comes with a lightweight mobile phones with a huge applications because of everything is embedded into this much pocket, right? So these are all smart materials. If you see around 10 years back or 20 years back, mobile phone used to be very big, around 300 to 400 grams, but now everything comes in a maybe less than 100 grams or less than that because of innovations in the smart materials. These are all smart materials. The glass I am wearing, it is a smart material because it can sense the radiations, it can stop the radiations, it can cut the radiations. When I am driving, it can allow only whatever the radiation, whatever the light I can, whatever light I can see or whatever light my eyes feels okay, right? So now we can see the health gadgets, right? It's a wonder, right? We have a lot of health gadgets. Every day we use just hold it onto your watch, which is wearable device, and it can measure your heartbeat, which can measure your pH, right? By sitting at an office, one can monitor a kid sleeping at home, right? A parents, they can monitor a baby, a 1-year-old baby who is at home, or she is at home, a baby is at home. So of course, ayas will be there, caretakers will be there, but they can monitor their health. If baby is having a fever, if baby is having some kind of a stomach pain, if everything goes with the baby, everything can be monitored sitting at office by wearing a smart wearable devices. Just by wearing a small patch on your pad or on your neck, on your chest. So these are all high discoveries, right? See, otherwise, so can it possible to monitor a baby sitting at home and then sitting at office? Even you are traveling, you can take care of your babies, right? These are all much required innovations. So this is possible because of discoveries in the smart materials. Smart materials, these are called as smart materials which can sense your sweat. Through your sweat, all these things are possible. So sweat, it reaches to your sensor, sensor will disperse the message and it will give an idea of what is baby is going. If baby is hunger, it can show that yes, baby is hunger. Yeah, advances in drug development. So this is my core area where I work. So this is a huge area. So until the universe is there, until the life is there, we need a drugs. We need a discovery of new drugs. There is no end, right? So we have a lot of challenges. There are different approaches. One is repurposing of drugs. Repurposing means we are repurposing it. It is already there. We are revisiting a medicine and see that whether it can be used for different disease. It can be used for different application. So this is a short way of discovering a medicines. You need not to have a 10 years. That is what happened during the COVID. It is a repurposing of existing drugs. Application, target, only target is different. It is existing as a medicine. So this is one area where people are working. Process chemistry, right? What is process chemistry? You all know. So doing a different process, coming up with a new process. It can be a green chemistry or it can be a cost effective. It can be a cost effective process. So because now we are all exporting most of the 90% of the chemicals for pharmaceuticals from China. So now we have stopped Atmanirbhar Bharat or Make in India. So because of that, we have a huge challenges in come up with the processes, manufacture, produce everything in India, right? So for this, we need a chemist to come up with a new processes, new catalyst, because China, if you want to compete with China, so we should have more innovations, more affordable technologies, more affordable processes. So these are some of the areas one can pursue. Sir, how much time I have? 10 minutes, okay. So again, high throughput screening. So this is one of the important area where innovations are required, or already some innovations are happening. The time taken for normal screening for doing for example, assays, like we want to do assays, different kinds of testings. So whatever we could do in a 10 days time, it can be done in even a 1 minute. 1 minute. There are different kinds of high throughput screenings. 1 lakh samples can be screened in one go. You just feed the samples, it can be done in 1 minute. In vivo assays, in vitro assays, there are a lot of high throughput screenings, not only for your assay, it can be for the automation, drug repurposing, as I said, it can be tested by utilizing various instruments which are now into the market, or we can come up with the new ideas where we can reduce the time and at the same time we can reduce the cost. Yeah, I was mentioning about this smart materials or devices, wearable devices. It has changed our normal life, right? So we could see that it has completely changed. It can measure our complete body monitoring, it can monitor our bodies, and there are n number of simple patches which comes with the chemistry materials which is embedded with the alloys or networking systems. So this can give you ample information, whichever. So until unless you feel it is something you cannot control, then only you are supposed to go to the hospital. Otherwise, you are okay. It can monitor even a heartbeat. So these are some of the shape memory alloys. This is one important area you can see. See, any part in the body can be replaced with your shape memory alloys. These shape memory alloys have a tendency to remember what is your previous. For example, a bone is fractured in a particular place, hand or a leg. If you fix with this, it can regain the metal alloy, which is SMA. It can make your regenerate your tissues, and it can make your bone to regain its original position. So these are all very, very, very micro structures, nano structures, but these are all new innovations. Even in India, many people are working in this area. As I said, thermochromic materials, fluorescent materials. So now the conventional way of checking expiry dates, for example, in a food, right, in a groceries, or the water we take or juice we take. So usually we see the manufacturing date and expiry date. Assume that if the label is replaced with a tampered, though the food or whatever it contains, though it is already expired, but the label is replaced, how we will identify? So for a conventional things, for a small cost effective things, of course we follow conventional, but there are innovations. For example, if you want to monitor the drugs or the whatever I showed, this vaccine vials, there is an innovation where you come up with a fluorescent material taggings. It can immediately change once the medicine is expired or the medicine is actually not decomposed, or its composition changes, it can immediately change its color. So these kind of innovations are possible with the support of chemistry, with the support of materials. Yeah. So to reach or to pursue these areas, what is required? We know that chemistry is associated with the life, and we know that there are n number of areas or advancements are going on. So what is required? How we need to acquire these things? How we need to enter into these things? We need a synthetic techniques. We need a AML techniques. If you have a AML technique, if you can become an expert in this, definitely you have a scope. You need to have a spectroscopy. You need to have a chromatographic techniques, right? And interdisciplinary. As I said, this is the era of interdisciplinary research. We need to collaborate with people. And data science, right? Collaborations, problem solving, innovation, design, sustainable, and of course you should have a most important thing is communication skills. we should have a communication skills. If you are unable to communicate what you want to achieve or what you want to propose, so it is very difficult to communicate. You should have a very good communication skills. So I will just quickly go through some of these areas what we do at NIST, because it is just a introduction to you. Like NIST, there are so many labs including IIT Bombay. There are so many IITs, ICERs, NITs, CSIR labs which are pursuing the research in this whatever I mentioned. One example is small molecule based drug discovery. Another one is phytopharmaceuticals. The phytopharmaceuticals is introduced in the last, this is one area where states like Karnataka or Kerala can contribute to the phytopharmaceuticals. This is a new area where a plant based medicine can be converted into a allopathic drug. Till date, no drug has reached a market. This is just 7-8 years back. It is US FDA along with other drug ministers this approved. So a plant based medicine can be adopted into the allopathic drug, or what we call it as English medicine. These are all plant based medicines, right? This is a new area, phytopharmaceuticals. Of course, diagnostics. Sickle cell anemia, it is a big burning issue throughout globe, including in India. So we don't have any medicine for it at present. There are some drugs which are in the clinical trials, and of course NAFLD. Till date, we don't have any drug for non-alcoholic fatty liver disease. So if anything comes, it will be a huge relief for the many people who are suffering with the non-alcoholic fatty liver disease. Similarly, nutraceuticals, immune boosters. Now many people are started working in the immune boosters because of pre-COVID, post-COVID. So immune boosters can avoid to some extent your regular medicine. If you can improve your immune boosters through your natural like food habits or natural resources, definitely you can reduce your load of medicines, which will protect you, which will increase your lifespan. This is again a very interesting area, organic, inorganic based photovoltaic devices, wherein usually the photovoltaic devices are solar panels we say, so which is basically based on the solar light, but these are all new kind of things where you need not to have a solar light. With the light, existing light which is sufficient, this kind of a light is sufficient to, next slide, which is this kind of a light is sufficient to even power the requirement of this auditorium. The light generated can be converted, around 30% can be converted into a storage. See, for example, these are the devices, some of the innovations where a solar indoor photovoltaic can be put into your bag, and that light is sufficient to power your power bank, mobile chargers, headphones, which is more than sufficient. These are all into the market now. And there are vertical facades, and then your car roof. This is another example, indigenous battery making. I am not going to the details. Yeah, this is one area where many industries are looking. There are a lot of innovations are going on, pigments, dyes and pigments. So if we can reduce, see there are so many areas in India and there are other states which now every year we are facing a increase in the temperature, right? In Delhi, in Rajasthan, even in Karnataka, Andhra, Telangana, there are now temperature is risen to 45, 46, 47. How to control? See, over usage of ACs is not good. Everybody cannot afford ACs. But there are some technologies which are affordable. For example, these are all paints. So these paints can reduce 4 degrees of your temperature. If you coat on your roof, so it can definitely reduce 4 degrees, 3 to 4 degrees. And there are some paints which are coated on your, for example, there huge supply of these gas lines, right? Country to country. There will be connections in between countries, and then there is a supply of these solvent systems or a gas, natural gas. So if you coat on that, there is a lot of heat generated on that. So it can absorb that and it can be converted into another form of energy. So these pigments are very much important in the advancement of our conservative life. Yeah, this is one more area where many people are working in this area. This is a, for example, what we call it as a counterfeiting. So there are a lot of fake notes are there in the population, in the circulation, right? So there are, I mean, currency notes, or bond papers, certificates, your certificates, fake certificates. So how to authenticate it? How to protect it? So there are smart materials which, if you see the 500 note or a 1000 note, a tagline is there, a fluorescent material. Now, earlier we used to export it from China, but in the last more than 10 years, we started using our own indigenous technology from India. So that fluorescent tags comes from the, which is discovered in India. But only thing is, we cannot, the government cannot disclose it, who discovered and all, because it is a secrecy. So all these secret materials, fluorescent taggings, all these are actually very, very important in smart materials, smart life, in the advancement of our life. So I will, maybe couple of slides I can go. Yeah. This is a pure chemistry, what we do. I would like to show one or two examples. Yeah, this is one example, how a simple observation or a simple revisiting your traditional, because we eat lot of ginger, right, at home. We eat lot of, and people say that these have a lot of medicinal properties, our lime, tulsi. So one such example, what we did is, from the mango ginger, we have isolated lot of secondary metabolites, compounds. And I just want to tell you how a simple observation, how an intervention from a chemist can come up with a important drugs or lead molecules. So these molecules we isolated, and we transformed this molecule into semisynthetically into some other molecule, and which shows very important properties. These molecules are basically from the ginger. Our day-to-day life we use lot of ginger, right? So from that we isolated some molecules and we transformed this into a modified molecules, and we could see that it can show a lot of health benefits. Yeah. Another best example is, so we see lot of meat, fish and lot of sea products in the market. Assume that if it is not stored in a cool temperature less than 10 degrees or even a 5 to 10 degrees, 15 degrees for even a 1 to 2 hours or even a 3 hours. So can you identify whether it is degraded or whether it is spoiled? Can you identify a fish? I am taking an example. Have a fish, and can you identify whether it is a expired or whether it is degraded, whether it is spoiled fish? By looking at the fish? No, right? Very difficult, because already the fish smell is different, so we cannot identify. So by utilizing a simple molecules, we identified a marker compounds. There are some marker compounds in the fish. Once it spoils, for example, if it is not kept in the 2 hours, 3 hours under the refrigeration or in the ice, it starts emitting some chemicals, right? So those chemicals we captured and sensed without even touching your whatever the fish material or a chicken. So one can detect the spoilage of these so-called materials in a 20 to 30 seconds by utilizing your simple lab-based chemistry. So this is what I want to say. So we can do wonders with the chemistry. What we need is a observation. We need to observe where our discoveries are required, where our interventions are required. So those things you can definitely do. So as I said, there are huge career opportunities. So one can complete your MSc and then pursue your PhDs. There are huge number of institutions which provides a institutional fellowships, which provides a CSR fellowships, UGC fellowships, right? And then DBT fellowships, ICMR, huge number of fellowships are there. So those who are interested in pursuing PhD, you need not to worry. You need to just qualify some exams and approach a right people, go and knock the door, meet them in person, Okay. See, now everything is available in the media. You need not to go to IIT Bombay, you need not to go to IISER Trivandrum, NIST Trivandrum. You can, by sitting here, you can contact them and you can express your interest, right? So that is more than sufficient. You will get a lot of opportunities. Only thing is you should have a dedication. You should have a dedication, right? You need to have a passion for science. You need to do something for the society. So if you have these things, definitely at the same time, by protecting your passion, by protecting your sincerity, everything, you can save the society, you can contribute to the society, at the same time, you can earn money, right? After all, we all do job and we pursue science, of course, we also need a salaries. So by pursuing chemistry, you also get a good salaries. So thank you one and all. So I will be more happy to take one or two questions. Yeah.
Check. Thank you, sir, for your wonderful presentation. So I have one question. Like we all know that green chemistry is well focused, and it will enhance the sustainability in our environment. What are the real limitations that you have come across using green principles, and how can you overcome those?
Yeah, see, green chemistry itself is it's a big topic. So I will quote one example, as I was mentioning for example, if you want to replace a hazardous chemical, like any solvent with the water, the first problem is solubility. Most of the organic molecules are soluble in organic solvents, and it's not vice versa. It cannot be soluble in water. So to make it as a water soluble, you need some additive or some media where your reactant is soluble, and you can continue from that until unless your reactant is soluble, or it has to share the energy with your another reactant, right? If you want to do a multi-component reactions or a components between two components, you want to do reactions, there should be sharing of energy, that the molecule should interact. Until unless this interaction goes on, otherwise there is no reaction. So one is solubility, otherwise there should be interaction. So organic solvents usually help. So to replace this, we should have a plan B. So water is one of the best, or water ethanol mixtures. To some extent, you add a water and then you can add some solvent. So by doing this, even you can save a 50% of solvent, right? But challenging thing is, of course, reaction rates will be different. It will be very slow, and then yields will be very less. So these are the problems. But yes, we have see, when there is a problem, then only we will work for the solution. If there is no problem, there is no research, right?
Sir, linking to this question only, like if we use the different catalyst, okay, different catalyst.
Yeah.
Okay, is it possible using greener techniques to enhance the reaction rate?
Yes, definitely. So that is what I am saying. See, reaction kinetics depends on different parameters, solvent, and then the quantities, the stoichiometric quantities you are adding, and the temperature, right? And if you are adding any additive, if you are adding any coupling agent, if you are adding any base, if you are adding any acid, and then number of hours. So all these parameters will make or impact one reaction. It is not one individual. So if you want to do a successful reaction, you need to take all these parameters into consideration, and one by one you need to optimize. You first keep all other things impact, and then you play with the temperature. And then once you optimize the temperature, you fix temperature, you go to the addition of the quantity of catalyst or the type of catalyst. So that is what I said, like Professor Sunoj, and there are so many people who are exclusively involved in the catalyst design, new catalysts, right? There are new catalysts to increase the reaction yields, to increase the reaction kinetics. So catalysts will definitely help us.
Thank you, sir.
Any more questions?
sir.
Yes, very good.
Sir, for wonderful presentation. If most of the compounds are soluble in water, and how to isolate that, sir?
No.
Because we need organic compounds.
Yeah, I
sir.
am saying it is actually soluble. Most of the organic compounds are soluble in organic solvents,
Yeah.
less soluble in water.
Yeah. Now, in case if they are soluble in
Ah.
water, how will we come back to the
Yeah, this is a nice question because you are avoiding we are trying
Organic
to
layer.
avoid organic solvents.
Yes, sir.
Instead of, for example, in the lab scale, okay, we are just doing with a 10 milligrams or 100 grams, very, very less quantity, 25 grams. If it goes, as rightly pointed, paracetamol, which is a bulk drug, per day there are, I think, quintals of paracetamol is prepared, right? We will take an example of paracetamol. So, if you want to prepare, if for example, 100 grams of paracetamol, 100 kilos of paracetamol, you need to add at least a 5 folds of solvent, right? If you can avoid that solvent, I am just putting an idea, if you avoid and do a reaction with water, at the same time you can use a organic solvent to extract this compound from your water, right? You need not to have a same quantity, that 5-fold quantity of organic solvent to extract. You may be required a very less quantity to extract, or we can do a phase separation. There are techniques where water can be separated by utilizing some phase separation catalyst, right? You might have studied in the BSc also. So that those can be utilized and can be separated. There are some polymers, there are some polymeric materials which when you can filter it, the water contains it, right? So it can selectively separate your material and then water can be separated. There are some materials and then there are a lot of biomaterials also.
Thank you.
But these are all still not into the market. So people are working. Some extent there are innovations, but when it comes to the larger scale applications, industrial applications, there are some issues.
Yeah,
but that is what we are actually trying.
But there will be some changes in yields, sir.
Yeah, definitely. There will be some changes in the yield, but still we can compromise in the yields. If we are replacing a organic solvent or a hazardous solvent with the water, even we can compromise 50% of yield. Whatever we are getting an organic solvent, if you are getting, for example, 80%, if you can get a water 40%, still okay. Because you are replacing with a very cheapest solvent, water, and it is abundantly available.
Thank you.
So no more questions. So I feel that either you digested completely, otherwise you could not understand anything. It is the other way, right?
Thank you, audience. I hope you enjoyed this session. Now, it is the time to express our gratitude to our esteemed resource person, Dr. Sasidhar B.S. On behalf of MGM and Chemsem, I extend my heartfelt gratitude to Dr. Sasidhar sir for being with us today. Sir, my sincere thanks for your exceptional presentation at this event. Your insights and expertise have made a significant impact, and we are truly grateful for your valuable contributions. Thank you once again for sharing your knowledge and helping to make our event a great success. Now, I request Mrs. Pushpalata P, Department of Chemistry, present a memento to our resource person, Dr. Sasidhar B.S., as a token of love and gratitude. Thank you, madam. There is a half an hour lunch break. I kindly request everyone to head over to Geetanjali for delightful meal. Please enjoy, and we will gather again here at 2 p.m. sharp for the third session. Thank you one and all. Have a nice day.
One small announcement. Those who are doing oral presentation, please submit your full paper in the registration counter and be ready with your slides in the laptop which is placed there.
Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national level seminar under the title New Vistas in Chemistry NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national level seminar under the title New Vistas in Chemistry NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with a mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with a mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national level seminar under the title New Vistas in Chemistry NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with a mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national level seminar under the title New Vistas in Chemistry NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with a mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its fourth cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its fourth cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies. It also hopes to enlighten about the career opportunities available to chemistry students. This seminar brings together experts, young researchers, teachers, and students to provide a platform for scientists, industry, academia, researcher, student interaction on chemistry for discussion in diverse array of allied disciplines like forensic chemistry, computational chemistry, research field. Welcome to Mahatma Gandhi Memorial College, Udupi, an iconic institution in coastal Karnataka. Established in 1949 by the visionary philanthropist and Padma Shri awardee Dr. T.M.A. Pai, this college was created with the mission to provide value-based education to the youth of rural areas. M.G.M College has earned an A+ grade from NAC in its 4th cycle, highlighting its role in transforming the region into an educational and cultural hub. Situated on a sprawling 46-acre campus, M.G.M College continues to be a beacon of academic excellence and community growth. To commemorate 75 years of the glorious existence of M.G.M College, Amrutha Mahothsava celebrations have been organized. As a part of the series of programs, the Department of Chemistry is organizing a national-level seminar under the title New Vistas in Chemistry, NVC-2K24. This seminar is an attempt to provide an overview of the current innovations and development in chemistry. The rapidly advancing field of chemistry is witnessing breakthroughs in green chemistry, which emphasizes sustainable practices and environmental friendly processes. The main objective of the seminar is to kindle innovative ideas among young minds towards research in chemistry and to throw light on getting research grants from different funding agencies.
From the Department of Chemistry, extend a warm welcome for today's third session on the topic, The Art of Forensics, How Science Solves Crime. May I now kindly request our resource person of the session, Mr. V.G. Naik, retired Deputy Director, Forensic Science Laboratory, Bangalore, to grace the seat on the stage. It's my distinct privilege to introduce our resource person, Mr. V.G. Naik, to the gathering. Mr. V.G. Naik has done MSc in Chemistry and also postgraduate diploma in Forensic Chemistry and Toxicology and has various experiences in forensic field. He has joined as a scientific assistant in 1985 in Forensic Laboratory, Bangalore. He also worked in all the divisions of FSL for a brief period and continuously worked for more than 28 years in toxicology section in different capacity. After working in different capacities in forensic science lab nearly for about 34 years, he got retired from his service on August 2019. He also served in regional laboratory as assistant director and also as deputy director. He also served as in-charge director of Forensic Science Laboratory, Bangalore. He analyzed more than 7,000 cases in toxicology section. He tendered evidence in more than 800 cases in different honorable courts and also helped in solving number of sensational cases. He has presented various papers in national and international conferences. He also delivered lectures in different fields of forensic in national and international conferences and CMEs. He is awarded with the Chief Minister's Silver Medal in the year 2003 for excellent service in forensic science in Karnataka. It's my immense pleasure to welcome you, sir, for this session. Now I request Mr. Vineet Rao, Coordinator, Gandhian Study Center, to florally welcome Mr. V.G. Naik. Thank you, sir. Now I would like to request Mr. V.G. Naik take over the session. Over to you, sir.
Follow. Good afternoon, everyone. So, first of all, it is my pleasure to be here in this national level seminar. Special thank you to the organizers to give me this opportunity. And today we will dive in the subject. This topic is art of forensic, also science, how this will solve the crimes. So, as such, forensic science is a combination of meticulous scientific techniques and methods along with the investigating skills required to solve the crimes. For instance, we can take one or two examples. One example is a single strand of hair or a small speck of blood from the crime scene. That will be the key to solve that particular crime. It not only solves the crime, but so many times it will exonerate the innocent person who has been wrongly accused in that particular case. That's why in this session, I will start with some basics of the forensic science. I want to give you some basics, which are the divisions, how forensic science works. Then I will explore some of the scientific techniques, mainly chemistry-based techniques, which are used in solving some of the sensational crimes. So feel free to ask any questions in between or your thoughts, or keep it at the end. We will address that one at the end. So let us start with this one, because given time is 1 hour. It is very difficult for me to explain basics as well as while giving the example of the crime, it will take more time. So depending upon which type of case I am taking. So start. The word forensic, it is actually a Latin word, means forum. Earlier in Roman days, criminal charges pertaining to any case, the criminal charge on the accused as well as the accuser, they will present their theory in the public. Whoever presenting the best, he will win that case. That was the earlier trend in the Roman period. That's why the word forensic came from the forum, that is public forum. Next. So in forensic investigation, there are two main forensic investigations. One is forensic science, one is forensic medicine. Forensic science, earlier definition was broadly defined as the application of science to law. It was called as criminalistic. And forensic medicine is application of medical knowledge to solve the crimes. That is forensic medicine. Forensic medicine is mostly from the medical field, doctors who are conducting the post-mortem and this thing. Forensic science are the scientific experts who are working in the forensic science lab. So forensic science is for the public, due to this dramatization of this TV serials and most of the TV drama fictions like crime scene investigation or CID serials, you might have seen it, how they are dramatized. So it has increased the public awareness regarding the forensic science, as well as unrealistic view how the process works. They will show that each and every crime scene will get the physical evidence clue for the forensic, that is called forensic evidence is available. It is not true. And unrealistic expectations to solve the crime by the forensic science. And they solve all the issues within 30 minutes. In one serial, they will solve the case. But in forensic science, it is not true. So it is completely differ from what they are showing in the TV serials and TV dramas. Sometimes single case will take months together, or sometimes years, or many times that will not solve at all. That is, so many times unsolved cases are there. So it is very important on the part of the forensic who are working in the forensic science or forensic medicine, responsibility lies on them, because depending on their results or their reports, so it will affect the criminal trial. So person may be behind the bar or he may come out from the jail depending upon his results. And if it is applied in the sports or athletic field, sometimes the test will be conducted in so many athletics on the international level. So sample will be taken for analysis whether he has taken any performance enhancing, sports performance enhancing drugs or anabolic steroids like that one he has taken or not. If he are wrongly detected something, his career will be lost. So in the multinational companies, the random check will be done on the employees, whether they are taking any drugs or not. If it depends on our results, so they may lose their job. In criminal trials, so many compensations they are asking, and our results will depend on the denial of compensation money. So that's why what we are doing, it should be accurate. Next. So from last 5 decades, tremendous advances in scientific technology, because earlier speakers already told, due to the research and this thing, new techniques are coming. And due to that one, it is affected on the forensic science also. We are now having large array of the scientific tools for investigation. In last, whichever new techniques have come in the field of research, in the other field or chemistry, something as new has come, it is definitely helpful in the forensic investigation. Next. So some of the important strides I will take, because long lists are there. I have listed very few, but time is not there, so I will take 1 or 2 examples. So you can see a small magnifying lens in Sherlock Holmes books, and you can see front page with Sherlock Holmes picture having the lens in his hand. That may be magnifying power hardly maybe 5 to 10x earlier. Now due to the inventions, we are having the scanning electron microscope. You might have heard it. It has having the magnification powers more than 1 lakh now. Higher ends are more than 5 lakhs. So with that much facility with the scanning electron microscope, very tiny particle we can see under the microscope just like a boulder. So not at all to see it, then we can identify that particular particle, because we are having the hyphenated technique. With the scanning electron microscope, the X-ray diffraction is attached. So energy dispersion X-ray is bombarded on that particular particle. We can identify the particular particle. That much facility is available. So whenever the explosion took place, so which type of chemical has been used for explosion, we don't know. What we are getting is, after explosion, the total area, mud and debris will be collected and sent to the forensic lab. From that one, we have to see the very small tiny particle which refers to that chemical. That one we have to see first under the scanning electron microscope, then we have to identify that particle. That much facility is available now. You can take the blood grouping. Any speck of blood, if you have seen in the crime scene, we have to fix that blood speck from where it has come, to whom it has belongs. So earlier we are having the only facility A, B, A, B, O, only 4 groups were there. So it will not solve the problem. So if A group is there from that small blood speck, we cannot fix that particular person with the A group, because so many persons are there with the A blood group. But definitely it will exonerate the innocent who is having the B group. But now we are having the DNA fingerprinting. With that small particle, we can identify the particular person. So that much facility we are having. From calculators to computers, we have come into last 25 years, computers developing, and so many digital era is there now. And same time, new types of crimes are happening, using digital devices. So that in forensic science, new division has an opened, that is forensic, computer forensic, mobile forensic, audio video forensic, new type of this forensic divisions have been come into the effect to identify this type of crimes. So drug toxicity, there are so many firecrackers, now we are having the high explosives are there. Next I will go, because very little time I have to give the basics and I will go to the actual, no, one, back, one back. Fingerprint powders. Now earlier latent fingerprints were developed by the fingerprint expert using some powders, depending upon which surface they are developing. Now they are laser beams. You might have seen it in biometric. If you have laser beam will find our total fingerprint, it will be scanned and it will record. That technology is used in the crime scene. So we are having one more, I can give you the symbol. In a crime scene, if you are having one latent fingerprint, the person can be identified without any this thing, because 99% of Indian population is having the Aadhaar card. All the population, all 10 fingerprints are with the Aadhaar card. UDI, they are having the database. But only thing is, they are not sharing for the crime investigation. That is personal, this thing, it is, our constitution has not given the permission to share the personal thing for investigation. That's why it is not possible now. One day come, in future definitely, due to some changes it will come. And if you imagine, if DNA is attached to the Aadhaar card, only Kuwait, only country is having total population DNA profiling, they have having the database. Because when in Kuwait there some big explosion was there, they have made the rule. Whoever goes to Kuwait and they want to stay in the Kuwait, they have to give their blood sample and your DNA profiling will be stored in the database. So in any crime scene, if small speck of any biological material is found, from that DNA profile will come, it will go to the matching to the database, the person can be identified. But in India, it will take long time. So interrogation, in police station, third degree interrogation, all of you know. Now we are having the scientific interrogation. Forensic psychology has come into effect. So lie detector test, brain mapping test, narco-analysis test, these are all scientific techniques. So muzzle loading, so guns from manual, muzzle loading, now we are having the high-end automatic weapons like AK-47, AK-54, now AK-74 in place. Once you have triggered, within a fraction of second, 600 bullets will be fired. If that weapon has been used in any crime, how we have to identify? As a forensic scientist, we have to update our knowledge and our facility in the lab to find out this type of crimes. Photography, recorded voice to forensic acoustic, that voice identification. Depending on the voice, the person can be identified. Like that on signature, now digital cryptography. In the bank, there is no manual matching now. Once your signature is stored in the database, whenever you are given a high amount checks, immediately they will scan and match with this thing and check will pass. Earlier, we have to wait for hours together to pass the check, 1 lakh or 2 lakh checks. Now it is due to this digital cryptography, everything is fast, and meantime it will be used in our forensic field also. Next. So who are the agencies? Mainly investigating agencies like police department, CID, CBI Central. They are the main user of forensic services. And courts, sometimes court directly refer the sample to the forensic lab. Excise department, health and other department for food adulteration and other things. Forest department, now where we are having the wildlife forensic. Railways department, they will refer the samples. Banks and financial institutions, mostly frauds in accounts or forgery in the document, or private organization, and one personal individual can also refer the sample to the forensic lab. Now government order is there, with the specific fee they have to pay in the treasury, and they can refer the sample to the forensic lab. They can take the services of forensic services. and send it to the lab. And sometimes they have to preliminary test to be conducted at the crime scene itself to know whether blood stain is there, whether seminal stain is there, whether which type of drugs. That type of test can be done, preliminary test, and afterwards the same sample will be referred to the forensic lab. There, using all high-tech instruments, it will be analyzed. Next. And after getting the data, after analysis, they have to give the interpretation and give the final result obtained. That will not end. Really, it will start afterwards. After giving the report to the investigating officer, now we have to testify in the court of law. We have to defend ourselves what we have given is correct. Because defense lawyers are also very clever. They will hire the experts and they will cross us. We have to defend ourselves how we have done the analysis. Whatever the analysis report we have given is correct, that one we have to defend ourselves in the court. Afterward, devise the execute suitable training program to the user agencies. They know what it is, forensic, especially investigating officers, magistrates, they should know, because we are giving the evidence in front of magistrate. They should know what is the forensic science, because most of the magistrates, they are not with the science background. There we should not compromise with the science, and with the layman, for the layman, with the simple words, we have to explain our things to them. So to the scientific person, along with the scientific techniques and names and everything, we can explain them. But to the non-scientific person, we have to convince what we have done, how we have done. Next. So forensic science works on these 7 principles and laws. Law of individuality, principle of exchange, law of progressive change, principle of comparison, principle of analysis, law of probability, law of circumstantial fact. So next, I will not take much time in this explaining all these laws. One, law of individuality. 2 objects may be indistinguishable, but no 2 objects are ever identical. That is the basic for us. Next. And this is the main law for us, Locard's principle. So Edmond Locard, also known as Sherlock Holmes of France. So he has given this principle. Whenever 2 objects come into the contact with each other, there is always a transfer of material. This is applied in the crime scene. So criminal leaves behind trace. If I come here today, tomorrow definitely I have left some of the evidence here, or I have taken some of the evidence from here. So exchange of this evidentiary material, that is the main physical evidence for the analysis. On the physical evidence only forensic lab will run. Just like petrol and diesel, the vehicles, automobiles will run. So for run the forensic lab, this physical evidence is required. Next. Everything changes with the passage of time. Law of progressive change, principle of comparison, only likes can be compared. Next, these are the next thing. I will not take much time. All the identification, definite or indefinite, are made consciously or unconsciously on the basis of probability. We have to start with the probability. At the end, conclusively, we have to say what it is. And law of circumstantial fact. Facts do not lie, but person will lie. That fact definitely does not lie. These are the main principles and laws. On this basis, we will work in the forensic lab. Next. There are so many expertise in these things. Few I have listed, because earlier definition of the forensic science was application of science to law. Till 2 speakers have enlightened upon the basics of chemistry and other things. For here, it is totally applied one, not any basic. But who is applying this chemistry to the solving the crime, he should have the very basic knowledge of the chemistry and everything. So basic of the science should be very strong. Otherwise, you will lose in the evidentiary materials and the thing while analyzing. Forensic anthropology. Whenever the skeleton is found in the crime scene, So study of skeleton, bones and other things to give the details about what was the age of that person, male or female, like that one the anthropologist will give. Forensic accounting. So here science with background, science background can't do anything. Any large scale accounting problems in the big companies, only with the background of accounting can help. Here chartered accountant will help. So forensic accounting, so chartered accountant will work in the forensic lab. So acoustic, voice analysis, ballistics related to the guns, biology, so biological fluid analysis, I will take some of that now afterwards. Chemistry, mainly chemical analysis of the evidentiary material. Document examination, so forensic document examination also I will take. So engineering, whenever the big buildings or bridges have collapsed, they required analysis of the material used is substandard or the structural design itself it is a problem. So then engineering background with the civil engineer, he has to help us. So entomology, if very totally decomposed body was found in the crime scene and totally maggots and flies on that decomposed body, we don't know how many days back he has died. To estimate the time of death, the entomology who is studying the insects, who is expert in studying the insects is called entomologist. He will help us to know the exact time of death. So odontology, so dentist, some sexual assault cases on the body, dental marks are there. Dental marks, studying the dental marks, we have to fix that particular person if 2-3 suspects are there. So all persons dental marks, this design will be taken by the dentist and he will study and compare with that one who is that person. So for example, I can give you in Delhi, Nirbhaya case, Nirbhaya's body on dental mark was there. So odontology help has given from the Karnataka, M.G.M Dental College, Dharwad. He was the professor, he was expert in that one. He has given his experience and he has given the report in that case. Like that one, each and everything not available in one single forensic lab. Whenever some such type of professional requirements are there, we have to contact the other person, other institutions who are having that facility to solve that crime. Psychology, I told you, forensic psychology, forensic photography, forensic physics, toxicology, mainly toxic substances analysis. Here also mainly depend on the chemistry. And digital forensics, I have given you an example. Digital, under the digital, computer forensic, mobile forensics, then audio video forensics, like that one it will come under this one. Next. So we will concentrate on the chemistry now, because I have told that only not chemistry, they are having the other backgrounds also, chemistry with physics or chemistry with biology, like that one. So I have concentrated on chemistry, but because all the sections to give this thing, it is 1 hour is not really sufficient. To name it itself, it will take 1 hour, all the divisions. So forensic chemistry, all types of chemical examinations which include the exhibit received under the Dowry Prohibition Act, explosive substances, unexploded sometimes, or totally after explosion, the material collected, that one we have to analyze. Food adulteration and petrol, diesel, kerosene adulteration, Prevention of Corruption Act. Earlier you might have known phenolphthalein is covered with on the notes and given to them, and this Lokayukta or ACB will ride and catch hold him, and his hand wash has taken. So there, that hand wash analysis we have to Prevention of Corruption Act, sample under Excise Acts. Excise department, so many illicit liquors are in the market, so they will refer that sample with the standard company liquor to compare that one. So we have to say whether it is a illicitly prepared or company that particular company product or that one. Like that one, depending on which type of analysis, most of these are using the chemistry background, chemistry techniques, chemistry methods we have to use in this one. Next, forensic drug analysis. Drug, name itself is a dangerous word. So, very, very dangerous word because NDPS Act is there, narcotic drugs and psychotropic substances. They have listed, government has listed, some of the drugs are totally banned because no medicinal value. Some of the drugs having the medicinal value, but restricted drugs. With the prescription, you have to sold because they are used for one or the other treatment of some other this thing, just like depressants, stimulants. Some drugs are available in the counter medical stores, but they are restricted drugs. So here challenge is forensic drug analysis deals with the identification and quantification. Existing and emerging illegal drugs. Emerging I am using because every day we are having, earlier speaker has told, with the new nanotechnology and this thing, new drug molecule will be identified and that will come into the market because who are criminals are very, very intelligent and genius. Who are in the research field, they can take much time to identify new molecule, but they will change the molecule with the existing drug and with the new molecule which is having the more effect than the existing one, and that will come into the market with new name. But if you have caught hold that person also, it is very difficult to punish him because that drug is not listed in NDPS Act. So by that time we have to analyze and know it, and we have to update our NDPS Act. One more new drug will come. So that is the challenge in this narcotic drugs and drug analysis. So we have to available analytical techniques and procedures, we have to identify the drugs. Next, toxicology, name itself suggests toxic substances. Any unnatural death, the body will go for the postmortem. The medical officer will collect the internal organs and body fluids of the dead body and send it to the lab. In the toxicology section, it will be analyzed to know which type of toxic substance is there and what is the quantity present. Just to say this is present, it will not solve the problem because that, for example, alcohol. If I have detected the alcohol in his blood, can I say that the person had died due to alcohol? So many people are drinking alcohol. So quantification is important. How much quantity is present in that blood? Whether due to that one only he has died or not. So most of the time quantification also required. Here extraction is very, very important and challenging because one thing you remember, whatever research or pharmacy, new drug or pharmaceutical company, 99.9% is pure compound. 0.1% only impurity, they are studying the impurity. Here entirely, totally reverse of that one who are working in forensic lab. We are having 99.9% impurity. In that one, only 0.1% is our suspected compound. We have to detect and quantify that one. Next, forensic ballistics. So deals with the guns, all types of arms and ammunition recovered under Arms Act, we have to say. And in the crime scene, if cartridge case or a bullet case has been found, or in the body bullet has been recovered, subsequently 2-3 weapons have been seized, and from which weapon it has been fired, that one we have to identify. So it will fix the particular weapon because that all marks and other things coming on the bullet or on the cartridge case are the fingerprint of that particular weapon. No two weapons are equal. That's why first I have given no two are same. Maybe indistinguishable, but they are not same. So this is what. And one more important is hand wash analysis. This is main chemical analysis. So in sometimes the body is found from the close range, he has been fired with the gun, and the same gun has given into his hand. So staged crime scene. Look like he himself fired and he has committed suicide, but it is not the fact. Somebody has killed him and weapon has given into his hand. Then this hand wash analysis will give the clue whether he himself triggered the firearm, he has not triggered it. That thing hand wash, I will explain with this one with the case. Next. Document examination is most of the time white collared crimes. So with the signature, forged signature or handwritten, we have to identify the person, authorship of the person, who has written this, who has signed it. And examination of forged document, addition, alterations, overwriting, disguise writing, undertake examination of typewriter, computer printouts, and from which instrument it has been printout has been taken. And sometimes we have to analyze ink analysis. But in most of the cases, destruction of document is not permitted by the court. So if it is a check keys of 1 crore, in blue ink it has been written, one is just altered with 7. One stroke has been added with the blue ink. So it has come 7 crores. So in writing also they have corrected it, altered. Then ink analysis is very important. So pen to pen, for naked eye it may be a blue color one. So with nanotechnology, without distracting much, very minute quantity of that different strokes have taken and analyzed it. We can say the inks are different, or video spectral comparator, non-destructive method instrumentation is there. There also we can see the changes with the different inks, different company pens with the same blue for the naked eye. Next, forensic physics, analysis of soil, paint, glass, dirt, very minute particles. If somebody has killed here, body has been shifted from here to somewhere, and from this area mud and the mud added to his garments has been collected and compared. So if it is not comparing, he has not killed there, somewhere other place. From the suspected place we have to take the mud, because from place to place it will not match. So restoration of the oblique marks, writing number plates on the vehicle, or chassis numbers, engine numbers have been changed. There we have to decipher the original numbers. So etching method, with perchloride and nitric acid etching solution, slowly etch the superficial layers. So in the beneath we will get the original numbers. Like that one chemistry we can use there. Examination of duplicated items, skid marks, marks on the accident case, tire marks in accident case, we have to compare physically. Next. So this is what, just given some example, because it is time is limited. I have taken only 3-4 sections, and 3-4 cases I will take and explain how we will use the chemistry there. So this is what the earlier speaker has told. Any research or in the forensic field, same thing. First observation of the physical evidence, and we will go through the case history, go through the details given by the investigating officers. Then what we have to answer in this particular case, that question, then hypothesis, how we have to proceed. Because we don't know at the end what results we are getting, and what we have to look for we don't know. We have to start. So then go on doing the experiments, collect the data, they come to the conclusion and give the results. This is what probability theory we have to apply here, because each and every case will not give the exact how we have to proceed. Case to case vary. No two cases are same. Today one case and same case will not repeat, because in my experience 34 years I have not seen two cases are same. Every case is different, different type of same chemicals may be used as a toxin, but how they have used is different. Like that one, different types of physical evidences have came. Like one, each case we have to take the decision how we have to proceed. And first thing we have to use the maximum non-destructive methods. Get the some data, then go for the finally for the destructive method, because once you have used, you don't get the same sample repeat. For repetition, no samples are there, very minute tiny particles are there sometimes. So using that one, we have to come to conclusion. So before going to that one, we have to maximum use the non-destructive methods. So once you have used the destructive methods, you have to get the final result. Otherwise, no sample for repetition, no sample for further analysis. Next. So I will start with few 3-4 examples how we have solved the crime. This is in 1991, Shakira. She was the granddaughter of Mysore Diwan. So she was wife of Khalili. He was the ex-ambassador to Australia and some other more countries. And in 1985 onwards, she was having the affairs with the Shraddhananda Swami. He is from Madhya Pradesh. So she was living with him in the very big bungalow in Bangalore. And with so much property and these things, they both traveled all over the world. And in 1991 end, the Shraddhananda Swami giving to the one of the police station complaint that she is missing. So since local police has investigated, nothing has come out. Since it is a very high profile case, it has given to the CCB. City Crime Branch, it has been handed over. So they have investigated for 2 years, nothing has come out. So with the sting operation, they came to know that this Shraddhananda Swami himself, he has killed the Shakira and body has been buried in the same bungalow where he is staying. So they interrogated Shraddhananda Swami and they opened this thing, exhumed the body. So body was in the box, wooden box, just like coffin, after 2 years. So next. So here, why I have put it? So how much intelligent he may be, he will do the mistake. So while committing the crime, definitely he will leave some evidences. That one we have to explore. So next. So he has prepared to kill her 6 months earlier itself. He has made the box and kept it in his house. So what happened in this case? She has been not killed and buried. She has been buried alive. She was alive at the time of burial. She has given some clue that she has been given some sedation, sleep-inducing drug, and after she was in sleep, body was kept in the box and nailed, and box itself buried in the courtyard of that bungalow, plastered, painted, and he was staying in that bungalow itself from the last 2 years. So when it came to know that it has been exhumed, here what mistake he has done, he has not buried as it is. He has put that body into the wooden box. That's why total decomposed mass was there in that box with the skeleton. So any unnatural death, I told, postmortem will be done and internal organs separately it will come, stomach, liver, kidney and blood sample. Like that one it will be sent to the analysis. Here nothing was there, total decomposed liquefied mass. They have collected, put in the big bucket and sent to the forensic lab. Analysis it and to know which type of drug has been given before burial. That was the challenge. We don't know which type of drug it was. So what we have done, so I have put this case because it was analyzed by me. 6 months I took for extraction. Every day I have to take about 200 ml of liquefied mass using different techniques, extract and keep it aside. So total extract is mixed, then purified it with the different technique. Most of the time chromatography technique has been used for separation. So all the impurities have been separated. Preliminary this thin layer chromatography has been done to remove all the impurities and concentrated on the under UV where they are giving the some fluorescence, that area scrapped and re-extract and go on concentrate that one. Then start analysis. We have to go which type of drug may be induced sleep available in the market. That one we have first concentrated on benzodiazepine and barbiturate group of drugs. Took all the market available benzodiazepines and the barbiturates and go on analyzing with HPTLC, HPLC. Just I have put the next HPLC results are there. I have given few of them. So benzodiazepines, chlorodiazepoxide, diazeform, oxazoform, because every HPLC chromatograms are different. Middle one is extracted from the total decomposed liquefied mass and overlay. Overlay you can see first peak very small in the viscera because chlorodiazepoxide was matching with the second one. We have analyzed and hydrolyzed this thing chlorodiazepoxide. The first peak will be very little. Then we said that okay, due to this it was hydrolyzed and still it is there in that liquefied mass because here basics work. That's why I told you basic is very important. Basic of science, what is basic? Matter cannot be created, cannot be destroyed. After 2 years also we thought that it is there because he has given when she was alive and after death nothing will happen, it will be there only, that compound. Only thing is how we have to extract and analyze, that is the challenge. The material definitely it will be there. So on that basis we have told that chlorodiazepoxide was given before death. So question comes, chlorodiazepoxide is a depressant drug. Any mental health, it is for that purpose the depressant will be given. One thing is if long exposure of any drug to any person, it will deposit into their hair. So that is the thing. Here blood was not there to quantify how much was given. So only we have rescue came as her hair because hairs were not decomposed total like a token it was in the box. So we have no restriction how much hair we have to analyze. Total token we have got it. All the roots have been cut and taken for the analysis and we have tried to identify chlorodiazepoxide in the hair root. It was not there. Then we have given the opinion that it is a short time exposure, not long time exposure. So this is what the chemistry works here to identify that one. I took nearly 9 months to give the report in this single case. So afterwards it was challenged in the court to testify what I have given it. Two famous lawyers, C.V. Nagesh you might have heard and Hanumantraya you have heard. These are the two famous criminal lawyers of Karnataka till now. They were against. C.V. Nagesh was the special public prosecutor and Hanumantraya was from the Shraddhananda Swami side. So I was in the witness box for 1 week, daily morning to evening. So I have to justify what I have done it because I have given total technical which are the tests we have conducted because I don't have time to give all the details here. Next challenge was to identify that skeleton, whether it is really belongs to Shakira or not. So at that time, we don't have the DNA fingerprinting in our lab, Karnataka. It was recently come into the effect, 85 it was been introduced with DNA fingerprinting. We have sent it to the CCMB Hyderabad. The hairs and the molar tooth of the skeleton is sent and for comparison her daughter Shaba Karili's blood has been sent to compare whether it is Shakira Khalili's skeleton or not. So that DNA has proved that that belongs to Shakira. Like that one, the chemistry has helped in this case. Next. Some of the mysterious deaths we have seen in the so many times, most of the times in Bangalore and big cities. This is first case near to our Madiwala police station. Our lab was in Madiwala. Next to Madiwala is BTM layout in Bangalore. So one of the physiotherapist clinic, this was the crime scene. So physiotherapist assistant was in the bathroom like in this position and her head was in the bucket of water. So second is in Banshankari, same thing in bathroom. So function was going in the house, and two children, one is of 13 years and 15 years, they both at a time gone into bathroom to take a bath. After some 10-15 years, the 15 years old boy opened the door and come outside and fell unconscious, and 13-year-old boy was inside the bathroom, found unconscious. Both have been shifted to hospital, and 13-year boy was died, brought dead, and 15 years boy was survived. And third one is, I don't have the crime scene photograph. So engineering student, she is having the exam on that day. She has gone to take bath. After 45 minutes, she not came out. So broke open, the door has been broke open, and inside she was found dead. This is what completely continuously happening in the bathrooms. So what we have, it is from the beginning I am telling, there are so many cases till in Bangalore FSL, every month at least 2 cases are receiving bathroom deaths. So here you can see each bathroom having the gas geysers. So next. So all the thing, whenever the gas geyser has been used, there is sufficient oxygen is required to burn the gas. So in small bathrooms in the city, close the door and close window and on the gas geyser, and they are doing washing the cloth or something more than 10-15 minutes they are in the bathroom. What happens? So it is glowing, and slowly oxygen supply will be less to the gas geyser. So instead of producing carbon dioxide, it will start producing carbon monoxide. Next slide, afterwards you have to come back. So it produces carbon monoxide when there is no oxygen deficiency. Well functioning new geysers also produce the carbon monoxide. And carbon monoxide is colorless, odorless, tasteless, heavier than the air, it will come down. And hemoglobin binding is 240 times more to the carbon monoxide than oxygen. It will take first carbon monoxide. So carboxyhemoglobin will be there. So once it is carboxyhemoglobin is converted to that one, it will not carry the oxygen. So oxygen supply will be the less to the brain. So person will come unconscious, he will not dead. So still he is breathing, still he breathe more carbon monoxide. So carbon monoxide saturation go on increasing. So once it is crosses more than 20, the person will die. So this is what next, previous. So here first case we have seen the carbon monoxide, carboxyhemoglobin saturation in the blood of the first case, the female, 30 years, 10.6. That is not sufficient to kill a person. But what happened? She has unconscious, fell into the bucket, her face has gone into the water, and due to the drowning effect she had died, because in the lungs the water was there. So he has breathed and water has gone into the lungs and she had died, not because of carboxyhemoglobin saturation. Others are more than this. So this is here, culprit is gas geyser. So next. So whenever this type of cases are coming, we will consider as a preventive forensics. So we have to give the wide publicity how to use it. Very cheaper, we know. Use this thing. I am not saying that don't use the gas geysers, but how to use that one next. Install the instrument outside the bathroom. Everybody is installing instrument in the bathroom and cylinder outside. Cylinder will not blast. You keep the cylinder inside the bathroom, nothing will happen. It is having the added smell. So whenever leak is there, the mercaptan will give the smell that gas is leaking. But most of the time, the instrument is inside and cylinder is outside. And use good ventilation. Bathroom, after switching off the geyser, you go into the bathroom, sufficient water, you collect 1 or 2, 3 buckets of water, then you switch off the geyser and go inside the. So here carbon monoxide sensors are required. This is very costly. And next, so I will not go much about this one. So here UV spectroscopy method has been used to identify and carboxyhemoglobin saturation to calculate that one. Here chemistry background is very much required in such type of cases. Next. So advanced technology, I will, next. So I will say that this is related to the drugs. Drugs, I already in brief I have told you the drugs. Drug facilitated crimes are there, drug facilitated sexual assaults are there. So some of the drugs have been named as the date rate drugs. Rohypnol, that is one of the benzodiazepam, flurazepam, one of the drug. GHB, ketamine be used in the surgeries. It is available in the medical store. These are the drugs which has been mixed with the alcohol and given in the parties, and person will be incapacitated. Then the sexual assault will be happen in the nighttime parties and drugs. And these are called mind eraser drugs, because they don't know when they are incapacitated or in unconscious stage what has happened, nothing will be remembered. That's why these drugs are called mind eraser drugs. Like that one, new types of drugs have been used in the parties. So it is very challenging. Without knowing anything, we have to analyze all this type. And one thing is, when it is mixed with the alcohol, synergic effect, any drug combination with the alcohol is more dangerous. So like that one, sometimes death may occur because of this synergic effect. Next. And alcoholic pills. He said new molecules will come. So one of the London research scholar, professor, he has announced that he has found the new molecule. It will mimic the alcohol. It will give all the effect which alcohol will give with one pill. But intoxication and other things is not that much of alcohol. If the person is driving the vehicle with this alcohol pill, and if he has been caught hold and asked us to analyze whether he has consumed alcohol or not, we are concentrating on alcohol. But this type of pills are available now. So what we have to do, only 1 to 2 ml blood will be sent for analysis. Within that one, we have to analyze everything. So this is very much challenging. That's why I told you, all cases are not solved. Most of the maximum cases are unsolved because of the limited quantity of the sample. Within that, we have to maximum how much analysis we can do, we will do. Next. And drug analysis, only presumptive tests, microscopy, microcrystalline, these are the non-destructive. Then we will go for chromatography, spectroscopy, FTIR, mass. But what happened, this traditional analysis approach will not sufficient to rule out all types of drugs. Then we have to go for number of challenges in forensic analysis. Precise and specific and sensitive instruments are required. Next. I am going somewhat fast, okay, so I have to complete another 2 cases. So here hyphenated technique will help us, because nowadays these hyphenated techniques are indispensable tools in forensic field. Like we are having the GCMS, LCMS, LCNMR. Now we are still coupled 2 or more techniques, LCMSMS, GCMSMS. Like that one, we are going to the higher with the library, because we don't know which type of compound it is. We will analyze with this one and compare the results with the existing library, drug library. It will give the nearest matching 4 or 5 drugs. Then we have to take that one, and with those 5 standards, each and every analysis, all type of analysis we have to do. Totally from unknown, we will come to closer. From that one, we have to identify and finally come to the conclusion which drug it is. Next. And one more challenge is, this is for the direct drug sample. If the person has consumed the drug, and investigating officer to know whether he has consumed this drug or not, in the rave party, 50 persons have been arrested, whether they have consumed this drug or not. So by that time they have arrested, by that time their blood sample has been collected, there are so many time gap is there. So here challenge is, in the blood, drug will be maximum 1 to 2 days it will be remaining. So urine up to 3 days will get, and here advantage is non-invasive, maximum urine can be collected. But Blood he can't draw 100 ml, 200 ml, only 2 ml doctor can draw from the living person. So within 2 ml it is very difficult. So then oral fluids are there, sweat is for weeks, hair only months or years it is available in the hair if he is a long duration exposure. That's why in 1970 suitable retrospective toxicological analysis has been introduced for the drug analysis in the hairs. So if he is a person is addict, so every month our hair growth is 1.5 centimeter. So past 1 month he is taking means from root to 1.5 centimeter it will come. So past 1 month he has not consumed this drug, but before that one he has consumed, it will above 1.5 centimeter and below 3 centimeters. So segment analysis will be done in the drug analysis in the hairs. Every 1.5 centimeter hairs will be cut and segment analysis will be done. It is very critical but challenging also. So here we can identify from how many months back he is consuming drugs. And this is not only in head hair, all parts of the body hair, there the drugs are available, because some of the persons they know once they are arrested the head will be completely go to the barber shop and completely clean it, and hairs are not available for it. So body other parts of the hair also having the drug. Next, identification of shooter. I already told you how it is possible. Next slide. So gunshot residue analysis is important, principally composed of burnt and unburnt gunpowder analysis, because gunpowder, the source of gunshot residue is primer. Here in the primer, antimony sulfide, lead stipnate, barium nitrate will be there, propylene, nitroglycerin, nitrocellulose will be there. That will burn and bullet will gain the energy to pass. So previous. Here, once the gun trigger has been pressed, what happens? So gunpowder will burn and bullet will start moving. But invisible, this fumes and gaseous form, this gunpowder residue will be on the hand of the shooter who has triggered the firearm. So it is invisible, but it will be deposited on his hand who has triggered it. So here on his hand, the back, next. On the palm, left hand or his right hand, or he has handled the gun with both the hands. So here on the upper portion and inner portion of here, the gunshot residue will be deposited. It is invisible. That thing is we have to identify and collection. Here collection is very important. Next. Here it will be collected using the 5% nitric acid or total distilled water with using the earbuds, pure cotton, and control sample will be taken for the analysis. Next. So here bulk analysis will be done using ICP-EAS, inductive coupled plasma with atomic absorption spectroscopy, or AS atomic absorption, flame atomic absorption spectroscopy, any bulk analysis, or you can go for the particle analysis I told you in the scanning electron microscope with energy dispersive X-ray analysis. That will give the next one. These are the instruments we are having in our lab. Almost all high-tech instruments are there in forensic lab. So next. So gunshot residue with ICP-AES, it will giving the barium, lead, and this particle gunshot residue will be detected. We can say that who has triggered the firearm. So that will differentiate from the person if it has been staged crime scene, whether it is a suicide case or homicide case, or culprit have been immediately arrested. It should be within 4 to 6 hours, it should be taken the hand wash analysis. Otherwise, it will not give the results. Depending upon how fast investigating officer will call the forensic expert and collect the hand wash analysis. Next. So, sir, another 5 minutes. 5 minutes. One DNA, one day one case, just So forensic biology, so biological samples we have to analyze sometimes. So chemistry background, some cases I have given. So biology next. So in the crime scene, if blood is seen, first question is whether it is blood or not. Everything red is not blood. We have to analyze simple chemical analysis using the benzidine test or phenolphthalein test. We can identify whether it is a blood or not. Then next question is whether it is a human blood or animal blood. That precipitation test is there. Then next, how closely it is associated with that particular person, suspected person. That grouping will be there, serology. Serology will work. Then finally, to come to the conclusion, the particular person, then we have to go for the DNA analysis. Next. So earlier to that one, biology, so grouping has been, the ABO groups have been identified, revolutionized the medical field in 1900. Same has been used in the police inquiries in forensic field. Then comes Leon Letters. He has given the techniques how to identify or grouping of the dried blood stains. Here earlier wet blood stain. Now most of the time it is dried blood stain. That technique is also there. Next. And one more luminol test. Aminophthalene hydrazide with the sodium carbonate and sodium perborate. It is one of the chemical shortly came as known as luminol. It is having the capacity to highly sensitive. It will detect the blood stains up to 3 lakhs time diluted. And it will be helpful when it is totally washed, blood stains are washed, clothes are washed. If, for example, I show you a sink, it is totally washed. At the night time in dark place, if you spray this luminol test, it will give the glow. It will react with the hematine of the old blood stains and give the fluorescence. That is the chemical test. It will give luminol test. It will be helpful in identifying the washed blood stains and very old blood stains. And still it will give more fluorescence. And when it is too old, very, very old blood stains give more fluorescence. That is the advantage of this luminol test. And it will be done. And from where it is glowing, we can take that part and go for the DNA testing. This luminol test will not interfere with the DNA test. So after spraying also, we can cut that area and take for the DNA analysis. Next. And this forensic serology, most of the time we have to go for serology first. We have to identify which body fluid it is, whether it is blood, whether it is seminal stain, whether it is a saliva stain. We have to fix with the serology test. Then once it is identify which body fluid it is, then go for the DNA analysis to finally identify the particular person. Earlier, when it in 1885, when fingerprint was identified, for 100 years, fingerprint was the only gold standard for the personal identification. Afterwards, some blood tests have come. It is also, then superimposition tests have come. But once in 1985, just next slide. This DNA technology, biotechnology, genetic engineer, this is the, no scientific development has affected life of the person in medical field. Meantime, in the forensic field also, that is DNA. So in Sir Alex Jaffrey in 1985, he has shown that no two persons having the same DNA structure. So this is what unique signature found on each person genetic character. Next. So here each person unique DNA profile except identical twins. There are two types, twins and identical twins. Twins are having different DNA profile. Identical twins is very, very rare. Both are having the same DNA profile. In that case, only fingerprint will differentiate them, no DNA. But both are having two different fingerprints. Each person DNA same in every cell, and throughout the life same, half DNA comes from the father and half from the mother. That will help to solve the paternity-maternity dispute cases. Next. So personal identification, unidentified dead bodies. So rape and murder cases with the biological fluids, the person can be identified, paternity, maternity dispute can be solved, like next. So only by getting one sample it is not possible, because DNA fingerprinting technique is comparative technique. For comparison, one more sample is required. So just by getting the DNA profile, we can't solve the problem. So if it is a crime case, evidence suspects blood sample is required. If child alleged father, paternity dispute, alleged father sample is required. Victims remains biological relatives samples whenever some unidentified dead bodies in mass disasters. Next. Bina murder case, I will not go much about this. In 1988, first case, recently you might have heard in Bangalore, Mahalakshmi murder case, 52 pieces have been done and kept in the fridge. But in 1988, same type of case has happened, Bina murder case. One of the agriculture university professor, he and his son together killed the daughter-in-law, make the pieces and throw all the body pieces in the US campus. After so many months, only bones have been recovered. At that time, just DNA fingerprinting came into the effect. So that time we take the advantage of this DNA fingerprinting which solved the crime in 1988, because 85 it was first introduced. Still it was not much known to all the forensic field. Only CCMB Hyderabad, just it was started at that time. That we have taken the help of the CCMB to solve this case. Next. Bangalore Nanded Express, suddenly fire caught to the 3-tier AC bogie, 26% totally charred to death. We can't identify each person's body, who to it belongs. All the relatives were there to identify and take their relative's body. It was not possible to identify, such a totally charred bodies were there. So then in our lab, we have taken the sample from all the relatives who are traveling into that bogie, and from the charred body, while conducting the postmortem, our experts has gone and taken the small pieces of liver from each body inside and taken the DNA profile and matched with their relatives and compared, and within 3 days we have identified all the 26, because 24 hours non-stop we have worked for 3 days to identify all 26 bodies. Next. This is next. This was very high profile case, very high end car. So it has hit and run case and killed 3 at the night time in Bangalore. Next day morning, vehicle was been seized, and due to the hitting and afterwards it had hit to the electric pole. So airbag was opened in the driver's seat, and owner of the car telling that his driver was driving the car. So there was a suspicion. On the airbag there are some blood stains were there. With the impact of that one, who was driving the car injured, and that blood stain was on the airbag. So that one we have picked and compared with the driver's blood and owner's, and actually 100% it was matching with the owner's blood. We said that this person was driving this car. Still it is going on in the court, still under the investigation, still not finalized. That's why I am not taking the names and this thing. Like that one speck of blood will identify the person. Next. So this is the last case. So Bangalore serial blast when maybe 2010, IPL was going on. Before IPL match, serial blast were there in Bangalore, 7 places at a time. So each batch has gone in all the places, and one of the 3 live bombs are there in the stadium outside the Chinnaswamy Stadium. So it has been opened. The tapes wrap on the live bombs were having, it is a gum tape. It is having 3 strands of hairs have been found in 2010. We have collected and brought to the lab and make the DNA analysis, kept the DNA profile. We don't have any sample to compare it. In 2014, some of the terrorists have been arrested in Tumkur, suspected that they were involved in this 2010 blast. So all of their bloods have been taken and compared. One of that person's DNA profile exactly matching with the hair found in this live bomb. Next. So on this basis, 2017, only this evidence, no other evidence was there. So he has been given the 7 years imprisonment from the only DNA analysis, no other evidence. Like that one. Next. Gate number sikkallali 3 kudlina ಆಧಾರದ ಮೇಲೆ. Okay, this is what. So I have given some examples how we are doing it, how chemistry will help. Most of the each section, whatever the section may be, most of the sections they are having the assistance of chemistry person only. Whether it is physics, whether it is ballistics, whether it is biology, every sections, most of the sections required chemistry background person to work with them, or they are taking the assistance of chemistry background. So next. So here, next. So here competence of laboratory staff and sophistication, how much sophistication it may be, but little or no value if relevant proper physical evidence is collected from the crime scene, and to collect and preserve it properly and send it to the lab, that will count. Otherwise, whatever the sample may be, it is no value. Next. So each and every case forensic expert will not solve. It is a totally team, combined effort of the investigating officer, forensic medicine, forensic scientist, fingerprint, police photographer, dog squad. Their total collective effort will solve most of the cases. So it should be a coordinated manner, collective effort. Otherwise, team effort will fail. Next. So otherwise, team effort will like become this. Everybody thinking that I am right, I am right. So at the end, we will not get any results. Next. So with this, I will finish. So within the short time, I have taken some examples, and I have concentrated mainly on the chemistry, how it helps in the forensic field. So as a forensic investigation, so personal commitment and our what we can say integrity, that will help to solve the crime, and it will give the justice to the deceased and also to the family of the deceased. So if you want to work in the forensic field, make it a mind that you should have a passion. So I have to do it, and commitment. You can't solve. There is so much discussion will come. No, 1 month, 2 months, 3 months I am working, not solving this problem. So sometimes so much disgusted. So why I am telling, once you have started the analyzing the case, you have to finish it, you have to sign the report, and you are totally responsible. In forensic field, who are signing the report, he will be the total responsible for the result to testify in the court. Nobody will come to rescue your senior officer or your junior, nothing will come. Who has signed, he will be the total responsible for that report. So you should have commitment, you should have integrity. Integrity is very, very main thing. What you are doing is totally integrity should be there. You should not tamper with any samples and this thing. So with this background, you are having the opportunity, and one thing, nowadays so many colleges, so many universities open the forensic science BSc and forensic science MSc courses. So my sincere this thing is, don't go for that one. Do it your pure science course. I am seeing who are excelling in the forensic field are who are done their master's degree in pure science, not by the coming from the directly from the forensic science. They are learning direct application of science. They don't know the basic principles of science. That is what in my experience I have seen. So as a pure science people, you are having the opportunity. You decide whether you have to go to the forensic lab, because it is now fast expanding. So many new labs are opening, and nowadays Supreme Court has recently given the order, each and every crime scene should be visited by the forensic expert. You just imagine how many forensic experts are required. In Karnataka itself, now we are having about 1,000 police stations. Each one police station require one forensic expert, because he has to visit each and every crime. So in future, there is a requirement, but only thing is you have to decide. Before going, decide it. Thank you. And next. Okay. Thank you very much. I thought I have given in brief about the forensic, how it will work and how we have to work in the forensic field and what are the challenges, because it is with the limited time, I can't concentrate on each and every case, because each and every case required 2-3 hours to give all the analysis how we have done. We have to present the analysis report and this thing it is. And one thing restricted us is we can't say all the cases here, because so many cases, although it has been decided in the lower court, it will go to the higher court, it will go to the Supreme Court, it will take long time. In Shakira Khalili case, first judgment came in 1998. 2002-3 it has gone into the High Court. 2005 it is in the Supreme Court, and 2006 final judgment. He will be in the jail till death. The Shraddhananda Swami till he is in the jail. And 2-3 days back I have read in paper that he has again asked the Supreme Court to release him, because now he is 80 years. He is in the court jail now. Thank you very much. If any questions, please ask. Otherwise, afterwards also you can ask.
Thank you, sir. Now the session is open for the discussion. Audience queries will be taken for the discussion. Thank you very much for your valuable information regarding the forensic science. Now I would like to request Mrs. Jyoti M. Alfonso from the Department of Chemistry to present a memento to Mr. Vijay Nayak as a token of appreciation and gratitude. Thank you, madam. With this, third session regarding forensic science come to an end. Next session will be paper presentation by delegates, which is hosted by Mr. Dr. Babu M., Department of Chemistry. Over to you, sir.
Good evening, everyone. Hearty welcome to you all to this paper presentation session of the National Seminar. I, Dr. Babu M., Department of Chemistry, M.G.M College, have the honor of hosting this session. First and foremost, I heartily welcome the honorable moderators, Dr. Murthy Dharmapura, Associate Professor, Manipal Institute of Technology, Mahe, Manipal, and Dr. Nagaraj Nayak, Deputy Manager, Process Chemistry, Sravati Advanced Process Technologies, Bangalore. Though the dignitaries need no introduction to us, as a formal duty, I take this opportunity to introduce Dr. Murthy Dharmapura to the august gathering. Dr. Murthy Dharmapura works as faculty at Manipal Institute of Technology, Mahe. He received his PhD in chemical engineering from TU Delft, the Netherlands. Later, he worked as special researcher at AIST Tsukuba and Tokyo University in the group of professors Kazunori Domin and Akihiro Furube in Japan. He worked on advancing sunlight-driven solar fuel production and developed femtosecond time-resolved in situ transit absorption spectroscopy for opaque wave samples. After moving back to India, he worked in several industry-sponsored research projects on electrochemistry and fuel cells. He is one of the unique personality in the integrated clean energy materials acceleration platform on bioenergy and hydrogen funded by DST. His area of research interests are designing materials for advancing solar energy conservation through offering mechanistic insights. Now I request Mrs. Pushpalata P, Department of Chemistry, to offer a rose to Dr. Murthy Dharmapura sir as a token of our love and affection. Thank you, madam. May I now request Mrs. Suchitra, Department of Chemistry, to introduce Dr. Nagraj Naik sir.
Good evening all. I am Suchitra from Department of Chemistry. It is an absolute honor and privilege to introduce our distinguished guest, Dr. Nagraj Nayak, moderator for paper presentation, is a proud alumnus and a former lecturer in M.G.M College, Udupi. Dr. Nayak has an impressive academic journey and professional career. He completed his Master of Science in Chemistry from Mangalore University, where he graduated with the first rank and was awarded the prestigious Shivaramaholla Gold Medal. He later earned his PhD in Organic Photochemistry from the Academy of Scientific and Innovative Research while conducting research at CSIR NIIST Trivandrum. Dr. Nayak is currently the Deputy Manager at Sravati Advanced Process Technologies in Bangalore. He has over a decade of experience in research with a focus on process intensification of industrial reactions using continuous flow chemistry as well as material chemistry and organic photochemistry. His work has led to the development of API intermediates along with advanced materials for applications such as sensors, drug carriers, and solar cells. His contributions to the scientific community are extensive with numerous publications in high-impact journals such as Journal of Material Chemistry, RSC Advances, and European Polymer Journal. Furthermore, Dr. Nayak was worked at some of India's top institutions, including IIT Bombay and Manipal University, where he has also held postdoctoral positions. In addition to his academic and research achievements, Dr. Nayak has cleared multiple prestigious exams, including GATE, NET, and KSET, and he has been recognized with the fellowships from CSIR. His journey from Udupi to becoming a respected scientist is truly inspiring. We are incredibly fortunate to have him with us today, and I am confident that his insights and expertise will inspire us all. Please join me in welcoming Dr. Nagraj Nayak. Now I request Mrs. Jyoti M. Alfonso, Department of Chemistry, to florally welcome Dr. Nagraj Nayak. Thank you, madam. Now I call upon Dr. Babu M., Department of Chemistry, to take over the session. Over to you, sir.
Thank you, madam. Friends, this session could realize only because of the interest taken by the delegates to present their papers. Hence, I extend a warm welcome to all the delegates. With these words, I hand over the proceedings to our respected moderators. Sirs, the podium is open for the presentations. The list of paper presenters are as follows. The list is as follows. Serial number 1, Dr. Sujit KV. Serial number 2, Hemant S. Bandari. 3, Ms. Ananya Kamila. 4, Ms. Irene Sunny. 5, Ms. Abhinashri Anand. 6, Ms. Sitara K. 7, Ms. Rachel Alvira Meneges. 8, Ms. Madhushri. 9, Ms. Mangala Shenai K. 10, Soumya Maya. Now I request Dr. Sujit KV to present the paper to August gathering. Time for the presentation, 4 minutes plus 1.
You make it full screen, please.
Good evening all. Thank you Department of Chemistry, M.G.M College for this nice opportunity. So because of these time constraints, I shall straight away move on to the presentation. So myself, I am Sujit, working as an Associate Professor, Department of Chemistry, Pioneer College, Kannur, Kerala. So you can see that my main aim was to synthesize certain heterocyclic compounds, which is a derivative from ibuprofen. So normally ibuprofen is a drug that is a non-steroidal anti-inflammatory drug. So it is mainly used to cure inflammation as well as pain. So it acts as an anti-inflammatory as well as analgesic agent. So of course, along with the drug, we know that certain heterocyclic compounds are known to exhibit a wide range of biological properties. So like triazoles, thiazoles, oxirazoles, etc. All these compounds exhibit a wide range of properties. But when you use ibuprofen for a long time, especially for the chronic use of ibuprofen, it carries some ulcerogenic activities, some problems with the stomach ulcer. So in order to reduce that ulcer activity, so my main aim was to incorporate certain heterocyclic compounds with the ibuprofen, or my major aim is to make certain derivatives of ibuprofen. So normally by replacing its carboxylic acid by certain heterocyclic derivative, we try to find its biological activities, especially the anti-inflammatory, analgesic, as well as ulcerogenic activity. You can see here, so mainly ibuprofen is an acid. So this acid can be on hydrogenalysis, you can prepare the corresponding hydroxides. So this hydroxide, by treating with the carbon disulfide and potassium hydroxide, we can make either oxidizole, and by further treating with hydrogen hydrate, you can prepare the corresponding triazole. The same triazole can be again prepared by a one-pot synthesis by treating the ibuprofen with the thiocarbohydrate, TCH. Again, in two ways. One is a green technique, that is by employing microwave analysis as a technique, as well as by simple fusion technique. So again, by fusing this ibuprofen, it's an acid, ibuprofen, as well as thiocarbohydrate, we can prepare the initial triazole. So this triazole having this ibuprofen, now you can see that that acid group has been replaced by a triazole moiety. So that triazole can be further converted into triazolothiazole, because normally triazolothiazole is known to exhibit a wide range of biological activities. So now by using this ibuprofen triazole, by treating with certain different types of acids, again by employing two methods, that is by microwave, that is a green technology, as well as by using POCl3, just by refluxing, we are able to synthesize triazolothiazole. The same way, we can change the triazole as well as the, instead of different acids, we can use ibuprofen acid also to prepare the same triazolothiazole as a different substituent as a compound 5. You can see the compound have been characterized by mass. You can see the mass spectra. I'm not going to detail. You can see the NMR spectrum of the ibuprofen triazole. You can see the both the upfield shift as well as the aromatic field peaks as well as the downfield peaks. Next, the same compound have been further characterized by the single crystal X-ray data. And as I told, the ibuprofen triazole, which on further treating with the different types of acids in POCl3, we can prepare this triazolothiazole. So, which is being characterized by the mass spectra. Next, again, this triazolothiazole have been characterized by proton NMR spectroscopy. You can see all these methyl, methylene, methane protons in the upfield. You can see the corresponding aromatic peaks, and you can see the downfield peaks also. Again, the same compound have been further characterized by using C13 NMR. You can see all the corresponding C13 peaks with respect to the compound triazolothiazole. Again, the same final compounds, some of the final compounds are further confirmed with respect to the single crystal X-ray structure. So moving on to the results and discussion, you can see these are the different types of triazolothiazole were made with respect to. And finally, you can see anti-inflammatory activities. So I'll skip all these things. Next, you can see the ulcerogenic activity. And finally, you can see that these compounds have shown better analgesic as well as anti-inflammatory activity with reduced ulcerogenic activity. Thank you.
Yeah, very interesting talk, Sujit. I was just wondering, the POCl3 reaction that you carried out, what was the solvent that you used there?
DMF.
DMF, okay. Yes. So how did you grow the single crystal? What solvent system you used for growing the single crystal?
So normally the molecules have been recrystallized using ethanol. In some cases, we are using a mixture of ethanol as well as ethyl acetate as a proportionate. Like it's a trial and error methods. It's not a proper solvent, cannot be explained for a single molecule. So most of the crystals have been grown by using ethanol itself. In some cases, we have added ethyl acetate also.
Okay, thanks.
Nice work. So just have one question. So you try to modify the property or the chemical functionality of the ibuprofen and hopefully get a different property. Why do you expect that modified ibuprofen, what is the mechanism you expect it will actually play a role?
So normally ibuprofen is known to exhibit its property by inhibiting the COX-2 enzyme. So actually COX-2 enzyme produce prostaglandin.
Ibuprofen is clear, but now you're trying to modify. It shows lower activity.
Yeah. So when you change this acid group, COH, when you change this acid group to certain biomolecules like triazole or thiodiazoles, so normally ibuprofen lacking its property because it's acid. So when you consume huge amount of ibuprofen, this acid group is actually the responsible for the ulcerogenic activity. So when you replace that acid group with certain bioactive compounds, so we are expecting to get a synergic effects.
But while not compromising the actual role of ibuprofen, is there any proof?
Actually, that's what ibuprofen can bind with the COX-2 enzymes. So actually, COX-2 enzyme is responsible for synthesis of prostaglandin.
That is like if you have this functional group OOH you removed, and assuming that is the reason for inducing ulcerogenic activity.
COX-2 studies have been done.
But while the actual chemical or the functional role of ibuprofen is still being maintained, any proof on that?
Sir, I haven't done the COX-2 studies of these compounds actually. Okay. So normally some other compounds have been done, like triazole, the intermediate. So that intermediate is properly binding COX-2 rather than COX-1. So ibuprofen, the actual thing is that it is binding with both COX-1 as well as COX-2. So that's the main reason for the ulcerogenic activity. So the synthesized compounds, most of the compounds are binding with only COX-2. Because of the large size, because COX-1 is a small binding site. So ibuprofen is a small molecule which can bind with both COX-1 as well as
simple question, son. Ulcerogenic activity reduce the number of acid group, I understand. But the functional role of ibuprofen is still maintained or not? That was my question. So like if you think purely from an ulcerogenic activity, I understand, because eventually you are reducing the number of acid group and it will eventually play a role in the, probably inducing acidity in the some.
Yes.
But what is the actual role of ibuprofen remains some analgesic or some antipyretic, that kind of application. How that property will be affected or not affected?
So actually the actual role of ibuprofen will not be maintained because we are changing the molecular structure. Because ibuprofen is an acid group. We are replacing that acid group with some other heteroscalic moiety. So literally speaking, ibuprofen as a structure, it is losing its structure. Okay. So normally the drug will lose its properties.
Yeah. Good luck. Thanks.
Okay. Thanks.
Thank you, Sujit sir. Now the serial number 2, Mr. Hemant S. Bandari.
Hello. Okay. Respected dignitaries and all delegates present here, good afternoon everyone. Myself M.G.M Bandari from M.G.M College, Ujre. Today I am here to present my paper, next one. Paper on the synthesis study of spectroscopical study on the copper complex and its bidentate skip-based ligand from 4-amino antipyrimidine and its antibacterial activity. So in this study, we are going to focus on the synthesis of our skip base that is bidentate and its metal complex, and relieving its antibacterial properties So this skip base was derived from the 4-amino antipyrimidine, which shows an significant biological activity such as an anti-inflammatory, antibacteria, and antiviral property. And also it has a unique structure that allows to form a coordination bond with a metal, makes a metal complex, which enhance the efficiency of this metal complex in biological activity. So we are more inspired to do this activity, these compounds, that skip base. In this research, we have reported the synthesis of our ligand and its metal coordination bond with a cobalt and a copper, conforming its complex through the many spectroscopical techniques like UV, NMR, and FTIR. And also it has tested its biological property to check its therapeutical application. Next one. So materials and methods used here, all the chemicals and the reagent used here are the A grade one source from the Sigma Aldrich. Without any further verification we are used. And the UV spectroscopy, which is used here, solvent as DMSO and DMF. That is instrument is Ocean Optical USB 4000 spectrometer, and FTIR, KBR pellets are used. And in NMR, the methyl trichloride is used as an this solvent at 400 megahertz, and TMS as used as an internal standard here. Next one. So this is what our schematic representation of our synthesis of skip base, where you can see here 4-amino antipyrimidine and bromosalicylic acid is used. Ethanol is used as solvent here, reflex for 2 hours and 30 minutes we cooled. And then the solvent we got here, it is the skip base, and the same skip base is reacted with a copper salt to form a copper complex, where 3 hours for reflection, where ethanol is used as solvent here, and then we get a complex of black greenish crystal. So the same thing was did with the cobalt also. Ethanol used here ethanol solvent and reflex for 3 hours. Then we get reddish orange crystal, which is our cobalt complex. Next one. So antibacterial study, where the this skip base and the metal complex where did antibacterial activity in a germ-negative bacteria, that is E. coli, where the stock solution and the bacteria were incubated for 18 hours at 37 degrees Celsius, and agar plate were prepared by using NaCl, yeast extract, and then agar paste, where wells were made, where bacteria and compound were placed and incubated for 24 hours for 37 degrees Celsius, and the incubation zone were measured in terms of diameter to check its antibacterial efficiency. Next one. So result and discussion. So atomic absorption spectroscopy, that is UV spectrum, where DMSO as used as a solvent, and these are the data were given in terms of absorption in terms of nanometer and centimeter units. And next one. So pi to pi star transition, N to pi star transition was shown here to confirm aromatic rings and presence of transition metals. So these are the spectral data. Next one. So then next IR spectroscopy, where KBR pellet were used. So this is what the data were given below in a table. Next one. So this is for ligand, skip-based ligand, IR spectral data, where from 500 to 1500 shows fingerprint region, that where all the functional group are present. Around 3500 we see OH group, and then around 1600 we see C double bond O group. Next one. So this is what copper, where 1500 to 500 to 1500 fingerprint region, where all the functional group was seen. Next one. So this is for an cobalt complex, where in cobalt complex we can see OH broader peak, H2O broader peak. So we predict that this cobalt complex may have the octahedral geometry, where in last one. So where in copper complex we doesn't see such type of peak, so it is square planar we assuming. Next one, NMR spectroscopy. So NMR spectroscopy data, where the two singlets of an methyl protons groups and the multiplates of an multiple rings and singlet of an OH group are seen. So next one. So this is what result of our antibacterial activity, that the comparing two with an copper complex and ligand. So we see that cobalt complex exhibits an good activity. So next one. So these are the result for a different concentration. The next one. Conclusion. So in this study we have dealt with a synthesis of our skip base and its metal complex, where all the structures were having a good structural property comparing with our experimental value, and the synthesized compounds and are tested for an antibacterial activity, which shows and moderate to and good activity. So therefore we can use this drugs for an further cheap and efficient way. So next. These are the reference paper we are used, and if any queries or doubts, you can say.
Hello. Yeah. Hello, Mr. Heyman. Nice presentation.
Thank
It's my one simple question, like why this copper or cobalt? What is this role in realizing this antibacterial activity? If I don't have copper, it still work as antibacterial. That's first question number one.
Yes, sir. We can do. As I said in that introduction part, why we did complex means it will show good biological activity, means it increase its efficiency. So that's why we did. Like stability, it will increase in structure, and leuophobic activity, that it can penetrate the walls of the bacteria easily and kills the germs. So we have furthermore did the complex.
Now you expect this bulk molecule to penetrate in the cell wall of bacteria?
Yes, sir.
Okay. What is the size of the cell wall?
So as I'm seen in the table one. No.
That's fine. Like generally, like what is the cell wall? Like you have a cell membrane. So you expect the molecules. Like what is the function? What is the nature? What is the mechanism behind getting the antibacterial activity of the molecule you synthesize? And have you tried a simple control experiment, just without anything added, just some solvent?
Yes, sir. We have did with a collaboration with the biotech department from Chemsem University. So in that we have seen only its incubation zone, sir. Furthermore, we are studying on it.
Okay. For the molecule, I just saw the molecule. Isn't like too big molecule? What is the size of copper, one metal ion itself, and compare that with the cell wall membrane pore size? How do you expect such a big molecule to penetrate inside, or it can break, or that for me it's not clear to me at this point. Yes, no worries.
Hi Hemant, yeah, good presentation. A few quick simple questions. I saw that you recorded NMR spectra of your molecule.
Yes, sir.
Which solvent you used for recording NMR?
We didn't use solvent, sir. There we have used FTIR has a pellets to pressurize.
No, NMR solvent. Which solvent you used for recording?
NMR.
NMR, proton NMR.
Proton NMR.
Yeah.
CHCl3, that is methyl trichloride.
What is that?
Methyl trichloride.
Is a normal solvent you used or deuterated solvent you used?
Sir?
Deuterated solvent.
Chemical formula of that, please tell me.
CHCl3, sir. I have mentioned, I think so.
Can you record NMR in CHCl3 or CDCl3? Yeah, because since you showed it, so I was just curious.
I think there was some mistake
Is
in
it
that.
CHCl3 or CDCl3?
CTCl3. Okay. So it is CTCl3.
CDCl3. Why you can't record it in CHCl3?
Because the compound metal complex will not dissolve in that. So sorry, the ligand complex may be not dissolve in that.
No, it will dissolve in CHCl3 if it dissolves in CDCl3.
Some mistake was there.
It doesn't matter. Yeah, thank you. Yeah.
Thank you, Nadal. Thank you.
Thank you, Hemant. Now, serial number 3, Miss Ananya Kamila.
Good afternoon, everyone. I am Ananya Kamila. I am a MSc student of St. Agnes College, Mangalore. So, I am presenting a seminar on the study of the physiochemical parameters of the regions of the seawater of Udupi region. So, this study offers a detailed analysis of the seawater of the Udupi region by examining various physiochemical properties to assess the water quality and the impacts of the industrial discharge. So the various physiochemical parameters investigated are like temperature, pH, conductivity, turbidity, total dissolved solids, total alkalinity, chloride content, hardness, dissolved oxygen, biological oxygen demand, chemical oxygen demand. Introduction. The crucial component of the earth is water. We all know that water is a very important component for the existence of the human being. In addition to the existence of the human being, water is also necessary for the agricultural production also. So, who is the reason for the water pollution? That is human. Humans are the reason for the water pollution. Water pollution is caused when the natural ecosystem is affected by the amounts of pollutants discharged into the water bodies. So this water pollution affects the human health adversely. So rapid urbanization, industrialization, agricultural practice changes, organic pollutants such as petroleum, hydrocarbons, municipal wastewater, industrial wastewater will rise the water pollution. So let's move to the materials and methods. So the analysis of the seawater are done for different physiochemical parameters in the different regions of Udupi district. So the samples were taken such as Padubidri beach is taken as sample number 1, Ermal beach is taken as sample number 2, Uchila beach is taken as sample number 3, and Kapu beach is taken as sample number 4, Kattapadi beach is taken as sample number 5, and Malpe beach is taken as sample number 6. So the parameters, as I told earlier, such as temperature, pH, conductivity, chloride content, alkalinity, total hardness, turbidity, total dissolved solids, dissolved oxygen, chemical oxygen demand, and biological oxygen demand. Next, results and discussions. Temperature. So all the measured parameters, the temperature will come within the range, that is on the acceptable range. According to CPCB, the temperature which should not. According to CPCB, the temperature should not excess above the ambient temperature, that is 5 degrees Celsius, which will cause the thermal pollution and disturb the aquatic habitats. pH, the elevated concentration of the impurities or the organic or inorganic substances leads to the fluctuation of the pH levels. According to CPCB, that is Central Pollution Control Board, the pH should be from 6.5 to 8.5. So in the measured samples, sample 2 and 3 are showing the lower pH when compared to the other samples, and all other samples are showing in the pH in a normal expected range. Conductivity. Conductivity is a measure of capacity of a substance or the solution to produce electric current. In this sample 2 and sample 3 is showing the elevated concentration when compared to the other samples, which is due to the introduction of the industrial discharge. Chloride content. Chloride content is large in the seawater. So chloride content will vary according to the salinity and introduction of the fresh water or industrial discharge. Here also sample 2 and sample 3 is showing a lower chloride content when compared to the other samples, which is also because of the industrial discharge. Alkalinity. Alkalinity is a measure of ability of the water to neutralize acidity. Here sample 1 is showing the higher alkalinity, which means that it has a stable environment. Sample 2 and sample 3 is showing the lower alkalinity when compared to the other samples, which is also because of the industrial discharge. Total hardness. Total hardness, it is a reflection of the presence of essential minerals such as calcium and magnesium. Here sample 2 and sample 3 is lower when compared to the other sample. This is because of the introduction of the effluents. So because of the lack of time, I am coming to the conclusion. By measuring all the sample, we have concluded that the sample 2 and 3 are more polluted when compared to the other samples. This is because of the industrial discharges or agricultural productions or runoff, etc. So BOD and COD levels are also high when we measured in this analysis, which means that the pollution is very high in the seawater. So on our measurement, all the samples are safe except Ermal and Uchila beaches, which is more polluted when compared to other 6 beaches or the 4 beaches. So this is the reference. Thank you for the opportunity.
Hi Ananya, interesting compilation. So yeah, the pH studies that you were showing, what is the pH of normal distilled water? Because your study says the seawater is slightly basic. Normal distilled water? 7. What is the reason for observed high pH range of the seawater? Any idea? You observed around 8.1 pH for the seawater that you collected near Padubidri.
6.2, 8.5 pH.
No, the sample 1, the Padubidri sample, the pH is 8.1, where the normal water you said it is 7. You have any explanation why you observed more pH?
Actually, the experiment is done by my senior. I have just done the writing part, so I don't know much about the practical thing.
All right. Second question is related to chloride content. Did you do this chloride content yourself?
What?
Determination of chloride content. Yeah. Did you do this yourself?
No. My senior has done, like with the guidance of the senior,
okay.
He has done the practical part and I have done the writing part.
Okay, yeah. So, but you have read how you determine chloride content, what reagents we use?
No.
Not read. Okay, thanks.
Yes, in fact, it's relevant to understand such behavior, seawater for the human life. And so, my simple question is like you mentioned temperature, okay? Like the temperature of all those beaches measured taken at the same day, same time?
Yeah, same day it was collected.
No, same day, same time at all beaches. You had like 10 of your friends, and same day you just spoke over phone or sent a message in WhatsApp. Okay, all of you collect the sample right time, or done it collected at a very random day, random time.
It was actually taken on the morning hours only.
No, morning, but same time.
No, not same time. Just morning hours.
Because in principle, even minute difference in even 10-15 minutes in such a sunny area can already make a huge difference, right? So another data, like you mentioned sample 1 and 2, but what is surprising for me is that acidity is also increasing, alkalinity is also increasing, right? How is it possible? In the table you showed, right? Acidity is also increasing, alkalinity is also increasing. Both for the same sample, how it is possible to increase?
It's in the sample 2 and...
Yes.
Because it is more polluted.
No. Same sample, like how? Yeah, no problems. Okay. Good luck. Yeah.
Thank you.
Next, serial number 4, Miss Irene Sunny.
So good evening all, myself Irene Sunny and I'm from St. Agnes College Autonomous. So the title of my project is Synthesis and Characterization of Functionalized Copper Oxide Nanoparticle for Enhancing Corrosion Inhibition Using Maraging Seal. Next. The content includes introduction, objectives, methodology, result and discussion and the references. So coming to the introduction part, now what is nanotechnology? Nano or nanoparticle. The word nano means small. So the particles whose size ranges from 1 nanometer to 100 nanometer is the nanoparticle, and it is reduced from micrometer to nanometer to enhance some properties. So coming to the application, due to small size and the enhanced properties, they have various applications in the field of biomedical, textiles, food industries and so on. So coming to the methods of synthesis include two approaches here, bottom-up approach and the top-down approach. So the method which I preferred or which I used here is the co-precipitation method. And why I choose the co-precipitation method? Because of it is simple to use and the low cost process which come under bottom-up approach. So the copper oxide.
The bare copper oxide compared to the nano copper oxide has enhanced properties due to the size, especially the size, and it is mainly used as the antimicrobial agent as well as it is used for the catalyst purpose and so on. So what is functionalization? Functionalization is adding of functions to the material to enhance the properties. So functionalization can be done by two methods, direct functionalization as well as the indirect functionalization. So what is corrosion? Corrosion is a vexing problem that we face in our day-to-day life. 1/5 of our steel industries has deteriorating from our side due to corrosion. So the corrosion can be studied by using two methods, or the corrosion rate can be studied by two methods. First one is the Tafel extrapolation method. Here, as you can see, there is the two branches here. One is the anodic branch and other is the cathodic branch. By extrapolating these branches, we will get the current, corrosion current, which is directly proportional to the corrosion rate. So we can find out the corrosion rate here. The another one is the electrochemical impedance spectroscopy. So here we are finding out the impedance via which we can find the corrosion rate. So coming to the objectives of the studies, to synthesize the copper oxide nanoparticle and to functionalize the copper oxide nanoparticles, and to investigate the corrosion inhibition activities, and to characterize the following. So the methodologies used here is the first one is for copper oxide nanoparticles. First, we are, as I mentioned above, this is synthesized by co-precipitation method, where the copper nitrate trihydrate is taken in a standard flask and 1 ml of glacial acetic acid is added to that, and it is heated to 100 degrees Celsius. And then to maintain the pH up to 7, we are taking 100 ml of 2 molar sodium hydroxide. Then there will be a color change from green to black. Next. So the EDTA functionalization is also done by the same method. After adding 2 molar sodium hydroxide, here we are adding 50 ml of 0.1 normal EDTA. So the corrosion study is done by using maraging steel. This is the composition of the maraging steel. Now coming to the result and discussions. The first one is FTR studies. From the FTR studies, it's clear that the first one shows the bare or pure copper oxide nanoparticle. Its peak or its band is from 588.29 centimeter inverse, whereas the functionalized copper oxide nanoparticle has 1052.12 centimeter inverse. So the scanning electron microscope studies. So this is the studies, and from this it is clear that the flower-like structure is obtained from here. Next. The X-ray diffraction studies shows that its range is from, the size of the material is 40 nanometer. So the applications include corrosion studies using Tafel and electrochemical impedance spectroscopy. These are the graphs which I plotted, which I got. So the conclusion is that from the study it is evident that the functionalized nanoparticles have much more applications compared to the bare copper oxide nanoparticles. These are the references. Thank you.
Yeah. So first question is, you mentioned nanotechnology will play a great role and will be helpful, but you use the co-precipitation method, and the method, eventually the conclusion is that the nano or functional copper oxide nanoparticle is helpful, right? But how do you really know it's really nano?
actually functionalized copper oxide nanoparticles has more enhanced properties as compared to the bare nanoparticle due to the size and surface area of that particle synthesized.
But when you actually functionalize means you are actually reducing the surface area, right? You have a
is added to the
you have a 100 surface. When you functionalize means your sum of the chemical is actually formed a bond or absorbing in the surface of copper oxide nanoparticle. So eventually, actually technically speaking, it is reducing the surface area.
Yes, but
right?
actually the results shows that it has more functions compared to the bare one.
Any possible reasons? Okay, no worries. Good.
Hi Geeta. So during corrosion, what will happen actually? Iron will get transformed to what?
Metal oxides.
The formula or something you can elaborate?
Maybe hydroxide of oxides.
Hydroxides or oxides? You be precise.
Oxides.
Okay, so now when you say copper oxide coming there, how it will help it to prevent that? What is the hypothesis?
How copper oxides
will help to prevent iron from getting oxidized.
through the size and
What will happen to copper oxide? What will happen to copper oxide?
it gets oxidized.
It also gets oxidized. Okay. Right. What is the oxidation state of copper in copper oxide?
2+.
Okay. Thanks.
Now serial number 5, Miss Abhinashri Anand.
Good evening, everyone. My name is Abhinashri Anand from St. Agnes College, Autonomous, Mangalore. Title of my paper is Synthesis and Characterization of Cerium-Doped Barium Titanate and its Photocatalytic Activity. Next. These are the contents of the slides. The objective of the paper is to synthesize cerium-doped barium titanate nanoparticles, to characterize that, and to study the photocatalytic degradation of the same. Next. Now, nanoparticles, as we know, they are the small range particles, 1 to 100 nanometers of range. Because of that, it has wide applications. Here, perovskite nanoparticles, those are class of materials with unique crystal structure. The crystal structure is of the form AbX3, where A is a large cation like barium, titanium, calcium, etc. B is smaller cation, mainly transition metals. X will be mostly oxygen. Next. These are the advantages of perovskites. Excellent light absorption, versatility, high efficiency. Because of this, enhanced photocatalytic activity. This is barium titanate nanoparticles. These act as a photocatalyst because of its properties like high dielectric constant, low dielectric loss, good thermal stability, etc. Next, doping, as we all know, it is the intentional introduction of impurities to the nanoparticles, hence enhancing the properties of nanoparticles. Here we can see that undoped nanoparticle compared to undoped, copper-doped nanoparticle shows more absorption of light and transition takes place in doped one. Next. These are the criteria for doping. The dopant and the nanoparticle should be of similar size, chemically compatible. The distortion should be minimum and it should be thermally stable. These are the advantages of doping: increased strength, durability, electrical conductivity, enhanced catalytic activity, etc. Now, properties. The bare nanoparticles will have, the cerium doping will enhance the properties of nanoparticles. Those are the properties. The characterization was done by SEM, XRD and FTIR. Next, the application part, photocatalytic activity. Photocatalytic activity, the ability of a material to accelerate a chemical reaction under the exposure of light. Those are the applications of photocatalytic activity. Next. This is what happens when light gets incident on the nanoparticle. Excitation takes place. From the valence band, electrons gets excited to conduction band, creating holes in the valence band. Electrons helps in photo reduction and holes helps in photo oxidation, hence degradation of dyes. The dye I used was malachite green. We know that dyes plays a more important role in textile industries. It is highly toxic. Next. It is carcinogenic and affects kidneys, livers and other organs. So degrading this plays an important role. Method used was hydrothermal method, bottom-up approach. Next. These were the chemicals used. Due to lack of time, I'll go to the conclusion part. Characterization was done by FTIR, SEM and IR. Now the study have shown that as the dye concentration was lowered, the degradation efficiency was more. The bare nanoparticles, the cerium doped nanoparticles showed more degradation efficiency than the bare nanoparticles. This is what it is. As time increased, the degradation efficiency also increased. Thank you.
Good work. So just I have one question. Where is barium titanate? What is absorption? Yeah, absorption wavelength, where it starts? Optical absorption, light absorption. Yeah, range, okay. Okay, no problem. When you say dye degradation, what do you mean by dye degradation?
Degradation of dye means dye is toxic. It is degraded into unharmful material substances.
Okay. So when I use barium titanate, when you shine light, it degrades. How and why? Okay, no worries. Yeah, read more. Thank you.
Yeah, just one quick question. Cerium doped barium titanate nanoparticles you made, right?
Yes, sir.
Yeah, so how did you prove that cerium is present in your material? Is present in your material? Yes.
That FTIR was done.
Okay, how FTIR will tell that cerium is present?
Cerium is present.
Yes.
That peak introduction of that cerium into bare nanoparticles, the grain size decreases.
Okay.
So XRD and that morphology by SEM we can identify that.
No, morphology will not tell you that there is cerium.
Grain size XRD.
Okay, yeah, based on the grain size. Okay, because it's very critical for you to know that cerium is present in your material to get the required property. So I was just curious, how did you confirm that? Thank you.
Thank you.
Next, serial number 6, Sitara K.
Good evening, everyone. I am Sitara K. I'm from St. Agnes College, Autonomous, Mangaluru. I'm here to present my project work. So title of my project is Cerium-doped storm-shed titanate and its photocatalytic activity. So these are the contents of my PPT. Objective of my work include to synthesize cerium-doped storm-shed titanate nanoparticle by hydrothermal method. Characterization is done by FTIR, XRD and SEM, and its photocatalytic activity was studied. So about nanotechnology, it is an interdisciplinary subject which involves interconnection between chemistry, physics and biology, and it is science and engineering of manipulating matter to nanoscale level, that is to particles which ranges from 1 to 100 nanometer. So these are some of the applications of nanotechnology like energy storage, metallurgy, electronics, etc. So this is the nanoparticle dye synthesis, that is strontium titanate. It belongs to a class of material known as peroxides. General formula include AbX3. So this class of materials has some unique features, like it has high thermal stability, high chemical stability, and it also shows high photocatalytic activity. So this is the structure of strontium titanate nanoparticle. So general formula include AbXO3, where A and B are cations and O oxygen. So strontium is occupied by the corner of the cubic cell is occupied by strontium, and oxygen surrounds titanium, which is present in the center. And that oxygen forms, like titanium is surrounded by 6 oxygen, and it forms an octahedron structure. And this is one of the characteristic feature of peroxide crystal. Doping. Doping means introduction or inducing an impurity to a conductivity, or means introduction of an impurity. So this will increase the conductivity of a material. So these are some of the advantages of doping, that it enhances the properties of nanomaterial. Already nanomaterials has many properties, including magnetic strength, photocatalytic activity, but by doping we can increase the properties. So I did a cerium-doped strontium titanate nanoparticle. So it has an excellent photocatalytic activity, high temperature, superconductivity and all. So characterization was done by SEM, XRD and FTIR. This is the application part. So photocatalytic degradation. Photocatalytic degradation is defined as, or it means, a photocatalyst is activated by light and it initiates a chemical reaction to break down the pollutants to simple unharmful substances. So nanoparticles is used as photocatalyst here. So this is the mechanism of photocatalytic degradation. So first, photocatalyst is exposed to light. So this leads to creation of electron-hole pair. Electrons are excited to conduction band and holes are excited to valence band, and both participate in redox reaction, and hence photocatalytic degradation is done. This is the pictorial representation of what is happening there, photocatalytic degradation. So dye I used for study is malachite green. It is the most commonly used dye in textile industry, paper industry, etc. And we all know that industries are releasing wastewater, and this wastewater contains harmful contents of this dye. So it is necessary to degrade these dyes so as to prevent water pollution. And we all know it is a toxic dye, and it affects aquatic life, water pollution, it causes water pollution and all. So materials used for study are this. So I used hydrothermal method for synthesis of nanoparticle. This is the procedure. Moving on to result and discussion part. So from FTIR spectroscopy, the molecular structure of the synthesis in nanoparticle was confirmed. So strontium titanate oxygen stretching absorption band was found at 564.2 centimeter inverse, and cerium oxygen stretching band was found at 746.64 centimeter inverse. Scanning electron microscopy confirmed the particle morphology, that it exhibits a spherical shape. Then EDS analysis confirmed the component of the nanoparticles. From XRD, the crystal size was confirmed as 17.7 nanometer. Next. So this is photocatalytic activity, how I studied it. So this is the data acquired from that. So 3 types I did. First one is by keeping the concentration of the dye varying and amount of cerium doped strontium nanoparticle constant. Next. So next study was by keeping concentration of dye constant and the amount of nanoparticles varying. So result I concluded from the study is degradation increases by decreasing the concentration of dye, and I studied it with both cerium doped nanoparticle as well as bare nanoparticle, and it was found that cerium doped strontium titanate nanoparticle has more photocatalytic activity than bare strontium titanate nanoparticle. And also I did by keeping the concentration of the dye constant and by varying the concentration of nanoparticle. So it was found that by increasing the amount of nanoparticle, concentration also increased. So these are the conclusions. Thank you.
Good work, yeah. So, again, what is the color of barium titanate? What is the color of barium titanate? Color. Yeah.
Pale yellow.
No, this one. This is cerium doped.
Cerium doped.
Yeah. No, if I don't dope, just take it as it is. Any.
Strontium titanate.
Yes. No.
It was like pale color, right?
White.
Pale color. It was.
Pale color. Okay. Have you tried the, just simply like without any photocatalyst, some control experiment? Like say, all your experiments are done in the presence of photocatalyst. Then you shine light. What if the dye itself degrades under light without any need of photocatalyst? Like any control experiment that you just keep in dark and just shine light, but without any photocatalyst.
Without any photocatalyst.
Yes.
Without any photocatalyst, the degradation was not occurring. Like it was taking more time.
Okay.
So I analyzed like one sample like that way, but it didn't show that much degradation effect.
Okay.
But when compared to nanoparticle, when nanoparticle is added, the degradation rate was increased.
Okay. Thank you.
Hi, Sitara. Yeah, the most powerful data from your presentation comes from XRD analysis. So, the basic of XRD analysis is one law, Bragg's law. You have any idea about Bragg's law? Bragg's law. Yeah, because your whole analysis is based on XRD there. Yeah, because you have done that, so I just curious. Also, you mentioned superconductor. Superconductor. Yeah, what is a superconductor? Yeah, okay. Because these materials that you made are primarily known as superconductors. Okay, so it's a very big subject area. So when you cool the material to low temperature, they will be, without any resistance, they will conduct the electricity. Okay, thank you. Yeah.
Thank you, sir.
Next, serial number 7, Rachel Alvira Meneges.
Good evening, everyone. Myself, Rachel Alvira Menezes. I'm from MIT, Manipal, under the guidance of Dr. Subramanya Bhatke. The topic of my today's presentation is managed basis of chalcone derivatives, synthesis and characterization. chalcones. So when we speak about the chalcones, these are the alpha beta unsaturated compounds, and they are present naturally, exceedingly and abundantly in plant sources, and they can be availed through the synthesis as well. So they are in limelight because of their intense usages in the pharmaceutical areas, and they have been indispensable of the life processes because of their intense usages as well. So I said they can be synthesized using the Claisen-Smith condensation. It is one of the basic techniques where the aldehydes and ketones, in the presence of the base, they give the chalcones. So next we find the applications. They are antioxidant, anti-inflammatory, anti-cancer, antiviral, and anti-diabetics. Next. So the objectives is to synthesize and characterize the managed bases of chalcone derivatives, to study the ADME properties using the Swiss ADME, which is a free web tool. So here it's a general methodology which involves the general synthesis, characterization, and Swiss ADME. Again, Claisen-Smith condensation, NMR, IR for the characterization techniques and ADME properties. Yeah. So when we speak about the organic chemistry or organic compounds, their contribution towards the medicinal area is really vast, as we have witnessed this morning. So I would like to speak about a compound which the presence of it enhances the biological activities. So if we see here, one of the things which is very much common in all of them, these all are the drugs, and one of the things which is very much common is that they all contain the morpholin group. So morpholin group is the tetrahydro 1,4-oxazione, and it has been found to enhance the activities such as antimicrobial, anti-inflammatory, and so on. So now we have seen that chalcones enhances the biological activities. Even the morpholin group also enhances the biological activities. So we wanted to bring these two together. So the main motivation comes from the paper which I have presented there, and it tells us that they have synthesized the similar type of the compounds, synthesizing the managed derivatives. If you go to the next slide. Synthesis, that is 4-hydroxyacetophenone. In the presence of the formaldehyde morpholin, refluxing it, the base morpholin derivatives were obtained. Further treating it with the different aldehydes, the chalcone derivatives were obtained. If you look at the characterization, IR, C double bond O stretching is found to be at 1671 per centimeter, and NMR, the aromatic protons are satisfied. If we go towards the chalcone derivatives, the CO stretching is found at 1654 per centimeter, and the number of protons are satisfied in the NMR, which was recorded at 400 ppm. So I said about the Swiss ADME, it is nothing but which can be, we are able to see the pharmaceutical, pharmacokinetics or the physiochemical properties, drug likeness. So the main thing is that when we consider or when we think about the drug, their solubility in water. So we find that our compound, we can see their water solubility, our compound is soluble in water, and also when we go to the drug likeness, Lipinski's rule. So the Lipinski's rule is the main rule which has been considered, so that is also satisfied. It's going to the conclusion, so we synthesized the chalcone derivatives and FTIR NMR was done, and Swiss ADME was also conducted. Acknowledgement, I thank Mahe for the financial and infrastructural facility. Thank you.
Yeah, interesting topic. So the FTIR of the molecule that you made, you analyzed yourself?
Yes, sir.
Yeah. So I see that there is C double bond C aliphatic. Yeah. There is C double, not this one probably. The other one.
Next.
Yes. You have aliphatic C double bond C.
Yes, sir.
You have C double bond O, yes. And you have aromatic C double bond C. Where they are approximately appearing. So C double bond O you have given 1654. Compared to this C double bond C, can you speak?
Sir, when C double bond O and C double bond C both are there, most of the time C double bond O is, we get C double bond O, and C double bond C is like weakly, we can find the weak this one, so we always
No. The question is whether it stretches above C double bond O value 1654 or it is below that number.
16?
Well,
No. It comes around like that till 1810, but when we go with
1810 is C double bond C aromatic.
C double bond C?
Yes.
No.
What is the value?
1680, sir.
Aromatic or the aliphatic? You have written C. B to C there is a C double bond C. In the structure between the carbon B and C there is a C double bond C. What value it appeared?
1680 only.
And aromatic ring C double bond C. No, you understood the question, right? Aromatic ring also has C double bond C, and you have C double bond C between B and C. What numbers it appeared? Because you have analyzed this yourself, so I asked.
Aliphatic is, it is 1680 only.
Okay.
That comes around, I'm not sure.
Okay, no problem, yeah.
Ratio. So if I give you benzene, if you measure NMR spectra, how many peaks you get? Proton NMR?
Once.
So you mentioned here carbon is touching 1654, okay? So I replace oxygen with C. Whether the stretching frequency will be higher or lower?
It will be higher, sir.
Why?
Because mass will increase, we have the formula 1 divided by, m is equal to, mu1 mu2 divided by mu1 plus mu2. So when the mass increases, so because k by mu, this decreases.
Okay.
Mass increases means the
Fine.
frequency will decrease, sir.
Fine. Okay, good.
Thank you.
Next participant, Miss Madhushri.
Good evening. Myself Madhushri, research scholar working under the supervision of Dr. Subramania Bhatke sir, Department of Chemistry, MIT, Manipal. And I am here to present on surface modification of sugarcane bagasse using oxidation reaction with the presence of sodium percarbonate. And these are my contents and introduction. Biomass waste. So biomass waste has been having serious impact on the environmental issues where these biomass are discarded causing landfills and all. Sugarcane bagasse where in the sugarcane industry gives the byproduct of this sugarcane bagasse as a waste, and this waste itself contributes around 17% to the 17% of total biomass waste in the whole world. And India is second largest country to produce this biomass waste from the sugarcane industry. So management of this biomass waste is to be of a serious concern. So how to convert this biomass waste into a valuable and useful product? For that, so there are a lot of treatments, physical methods, biological methods and chemical method. One such chemical method I have discussed, a very small experimental experiment. Extraction and processing. So here I have focused on the component cellulose. This cellulose is a biopolymer that is present in the cell walls of the bio waste. So this cellulose component is present on the cell walls of the sugarcane bagasse. For the extraction, here I haven't extracted completely the pure cellulose structure, but partially I have taken the cellulose for the further chemical treatments. So before chemical treatment, a pre-treatment is done. Pre-treatment is nothing but I have taken the fibers and treated it with alkaline treatment, sodium hydroxide. 5% of sodium hydroxide is being prepared, solution is being prepared and the fibers are soaked in it. This is done, this basic pre-treatment is done to remove excess wax or other components that are present along with the cellulose like hemicellulose, lignin, wax and other impurities. So first the sugarcane fiber is taken, and then as I have previously told, 5% of sodium hydroxide solution is prepared, and the fibers are soaked in it for overnight, and then again they are dried and washed properly, and these are again further chopped, and these fibers are taken for the further chemical treatment. Here I have taken potassium before the chemical treatment. First is preparation of catalytic solution. So in the preparation of catalytic solution, first potassium dichromate is taken, along with that androgen, which is a phase transfer catalyst, and organic solvent 1,2-dichloroethane is taken. This mixture forms the catalytic solution. In this catalytic solution, 2 grams of the previously pre-treated sugarcane fibers are added, along with the sodium percarbonate, and here the reaction is taken over for 24 hours at 80 degrees Celsius. So here we are studying 2 properties. One is crystallinity and other is thermal stability. So for crystallinity, the raw fibers had, as you can see, that is 59%. After the alkaline treatment is done, it is 62%. And for chemically treated fibers, it is 48.5%. Here the crystallinity index after the treatment of alkaline solution has been increased, because this is due to the removal of the impurities such as wax or lignin or extra components that are present in the fibers. After the chemical treatment, oxidation reaction has occurred, thus the crystallinity of the fiber is being reduced. Next, TGA analysis. Here you can see the untreated fibers maximum temperature is 490 degrees Celsius, and after pre-treatment the maximum temperature has increased, so increasing the thermal stability of the fiber after the treatment of the alkaline solution. After the treatment of chemical treatment, again it is for the thermal stability is further increased, and you can see 459 degrees Celsius is obtained. And these are SEM images. The first 2, A and B, are the SEM images of untreated fibers, which also contains the impurities of wax, other components. You can see the surface is not smooth. After the treatment of alkaline solution, it is not completely smooth, but it is better comparative to the raw fibers. And this is chemically treated fibers. Here there is more, as you can see, the surface modified with this chemical, the fiber and matrix is bind to the interface. So here sugarcane bagasse waste, which is usually discarded, causing to the lot of pollution, here is converted into something that is valuable. So here the modification that is done, these chemically treated fibers can be used for polymer fiber matrix in industries to improve the resin properties. These fibers are mixed with those resins to improve its properties. So here after the treatment of the fibers, its thermal stability is being improved and crystallinity is being decreased. These are the references. Thank you.
Yeah, can you go to that thermal stability studies?
Yes, sir. Back.
If you see the graph, your decomposition started well below 100 degree.
Sir?
Your decomposition of material started.
Yes, sir.
So, okay, so that is weight percentage.
Around 200.
Okay, this is 200. So so from this angle I used
Yes,
that
sir.
I was not readable properly. So what is the decomposition from 100 to 80%? First 20% you lost, right?
Yes, sir.
Yeah,
Basic
so
moisture that is being present in the fiber sample and certain volatile components that are present are first gone, and then after complete water removal is taken place, hemicellulose content, lignin content slowly are being degraded, and then last cellulose component is being degraded around 360 degrees Celsius or
okay. What is the percentage remaining at the end? It is nearly 20%.
where, sir?
Though that y-axis after 400, 500 degree, how much material still retaining? 20% of that?
Yes, sir.
So that is,
very
that
tiny,
is
yes,
as
sir.
much as expected.
Yes, sir.
20% is the one you expected, based on your theoretical input.
Sir, can you repeat the
No,
question?
no, you have charged, while doing the reaction, you have charged inorganics, and based on the calculation, you will expect some 20%, 30%.
Yes, sir. That T20% is like basic. First, the water content that is being present will be
evaporated. Okay, fine. Thanks.
So how do you really know that it's after heating or after this treatment of with alkali?
Yes.
How do you really know is the cellulose component is separated, lignin is being removed?
Sir, for lignin, lignin is not completely removed because some partial amount of lignin is present, but majority of cellulose content is being focused. Lignin is removed. Actually, FTIR also is done, sir. I haven't included the FTIR, where for lignin also the peaks are being reduced, but complete removal of lignin is not done. As I told previously, pure cellulose component is not taken. Lignin is also present in that, but most part of the lignin is being removed.
No, that's what, like the color itself, if it is really pure cellulose,
Yes,
it should be white. So the color of the fibers you showed eventually
Yes,
at the
sir,
end,
yes.
it is still
not,
like yellowish only.
Yes, sir. It is still yellowish. It's not pure component. Pure cellulose is not being extracted.
So what you see after 20%, let's say after 350 degree heating, some 20% remains. What would be the color of that remnant?
Last.
Yes, after TGA.
Charred, sir.
Charred.
Charred.
Okay. Yeah, okay. Thanks.
Thank you, sir.
Serial number 9, Miss Mangala Shenai K.
Good evening all. I am Mangala from Department of Pharmaceutical Chemistry, Manipal College of Pharmaceutical Sciences, presenting a review on topic From Nature to Nanotech, Molecular Glues in Targeted Protein Degradation. So what are molecular glues? Molecular glues are the bioadhesives which mimic the natural property of the which is seen in the mucil cells. Here the 2 or 3 proteins can be glued together using these molecular glues. So coming to the timeline, we can see that the molecular glues were first started to be studied in the year 1991, and it took almost around 20 years to reach the clinical trials, and in the year 2022, the first molecular glue was in the pipeline of the clinical trials. So we can link this molecular glues to targeted protein degradation. So before that, we have to know what is targeted protein degradation. So as the name says, degradation is deleting of something. So here this helps us in treating certain diseases where the protein cannot be treated. That is, the proteins are named as undruggable targets. So such places we cannot treat it with normal small molecules. So here we use targeted protein degradation. So molecular glue is one type of targeted protein degradation. So we can use it for the treatment of cancer where KRAS is involved, KRAS is involved. So such proteins we can use this targeted protein degradation to treat such cancer types. So here we can see PROTAC is another type of targeted protein degradation. So molecular glue and PROTAC are almost similar, but in their structure there is a tail which is involved in the PROTAC which is not there in the molecular glue, but when we see their activity, both of them act very similarly at the target. So how can we include this in cancer treatment? We can create novel small molecular glues which can exactly target the target which we need, protein which we need by degradation, and helps in solving the treatment problems which we are facing nowadays in the cancer treatment, and helps us to give a better treatment opportunities. So what are the challenges here? So as we know, every drug has a drug toxicity and also a drug resistance. So by seeing the drug toxicity and drug resistance, we can move forward to use the molecular glues in the present treatment methods.
Now coming to the future directions, how can we improve these molecular glues which are trending now? Because as I said, they have reached into the clinical trials recently. So these future directions will help us to lead in a proper way to treat the cancer. We know cancer has almost affecting all the parts of our body. So we can first use the computational tools to design a proper molecular glue which can exactly target the protein and give us a better result. So coming to the conclusion, we can use this targeted protein degradation in comparison with the present cancer treatment methods where only small molecules are used. So we can use this targeted protein degradation to solve the treating problems in the cancer nowadays.
Okay. So if you take a three-dimensional quaternary structure of a protein,
Yes.
which is the strongest bond, which is the weakest bond?
In the sense?
Like you have a protein, so now
Yeah.
you worked on protein degradation eventually. So if you really want to degrade a protein,
Yeah.
then you really need to understand the structure stability where the nature of chemical bond will play a critical role. So if you take a protein, quaternary structure of a protein, okay, which one would be the strongest bond, which one would be the weakest bond, which holds the protein structure?
Okay, so actually when we consider this, the protein, we are going to target it into a pocket. So that pocket will give the pi-pi bonds and as well as hydrogen bonds will be there. So according to different targets, different proteins, the bond will be changed. So the degradation what we do according to different proteins will be changed. So now coming to CRAS pathway, there the degradation method will be different and some other pathways, say PI3K, the degradation method will be different. So based on that we can do the degradation.
When you say this degradation, what exactly happens?
Actually the pockets where which are already there the small molecules will not go and fit properly. So coming to CRAS, the small molecule was not fitting properly, but CRAS pathway was one of the main pathway which resulted for the pancreatic cancer. So in the recent years, only 1 or 2 discoveries were seen where the pathway was targeted. Earlier till then, we were not able to drug properly dock the pathway in that particular place. We could only do the computational studies, but coming to the in vitro laboratories, we couldn't target those particular pathway. So that's why we are doing here the protein, whatever is reason for blocking the druggable pockets, those are removed, and with the molecular
No,
glues,
simple. It's not complicated. So you have a protein.
Yes,
you want
sir.
to degrade. How
Yeah.
this degradation would proceed?
removing the molecules which are reasonable for this one.
No, protein will have anyway this quaternary structure.
Yes,
only
sir.
the active sites, if it is an enzyme, only
Okay.
those few amino acids will be exposed.
Yeah.
Now, whatever the molecule, the small molecule you would like to use, and how this would actually eventually lead to the overall degradation of the protein.
No, overall protein is not degraded. A part of the protein will be degraded, which is the reason for blockage of the
Okay, this is the active
drug.
site basically. Active site which is
Yeah.
responsible for the enzymatic
Yeah, that
action
part
would be.
which- yeah, that will be
Some
degraded.
small molecule will go and
Yeah.
block the active site.
Yes, sir.
So it's not really a degradation as such,
No,
right? Technically.
no, not full protein is not
Yeah, that's
degraded.
what
A
I
part
just
of
want
it,
to-
yeah,
okay.
yeah, and using molecular glues, we will seal it together like
Yes,
how
clear,
adhesives.
clear. Okay. Fine.
Yeah, hi. This is the work that you did, or it's a review that you
It's
are
a review, sir.
So you started working on this, or this is your
Yes, sir.
area?
Yeah, started in the sense computational works have been started. So
Okay.
currently, based on that, I have done the pre-study, which is a review.
So, okay, since you're doing computation study, what is the parameter that you will fix? For example, now if you administer a drug and if you want it to go to mitochondria, for example, specifically, what is that you will incorporate in your drug so that it specifically goes to mitochondria or RNA or DNA? What is that you will incorporate?
Sir, actually we use proteins here. When we are doing computational studies, we use the proteins. So
Okay.
first we will see if it gets docked properly or not. So if it is not docking, we will check to eliminate those part of the protein which is blocking the druggable sites. So after that we will again redock it and we will see the results and compare it.
What if it goes to other parts of body and gets docked?
Sorry, sir?
What if it goes to other parts of body
Huh.
which are not affected, and
Okay.
this drug goes there and docks?
No, sir, this will be target specific. No?
And that's why I'm
So-
asking, what is that makes it to be specific to go to that
Because we
protein?
are only targeting the particular protein which is needed for us. So according to that, we will do the drugs, we will synthesize the drugs, which accordingly goes and targets to the particular.
Okay, this is the approach you're using.
Yes.
Okay, got it. Thanks. Yeah.
Thank you.
Serial number 10 is the last paper presenter, Miss Soumya Maya.
Good evening, everyone. Good evening, everyone. My name is Soumya from Department of Chemistry, MIT Manipal, under the guidance of Dr. Santosh Lakshman Gamkar. My topic is about design, synthesis and characterization of novel chalcone for fluorescence studies. These are my contents. Introduction. In the field of organic chemistry, numerous organic compounds have been synthesized and their applications are also studied. Among those, chalcones are widely used because in modern days, all modern science and technology, they are high sensitive because of their high selectivity, sensitivity and rapid response time. General form, these are water chalcones. Now, simple molecule with two aryl rings separated by an alpha-beta unsaturated carbonyl compounds having general formula C15H12 and O. Naturally found in fruits, vegetables and spices. Naturally occurring chalcones are generally crystalline solids and melting point 55 to 57 degrees Celsius. Colors pale yellow, white and orange. Some of the synthetic methods includes Claisen-Smith condensation, one-pot synthesis, Heck coupling reactions, solvent-free synthesis and microwave-assisted strategy. And applications includes metal sensing, intermediate for heterocyclic synthesis and fluorescence studies, and also biological applications such as antimicrobial, antifungal, anti-cancer, anti-diabetic and anti-inflammatory. My objectives: to synthesize and characterize novel chalcone, to study the fluorescence characteristics of the synthesized chalcone. Synthesis: equimolar ratio of 4-hydroxyacetophenone and dinanthracene carbaldehyde was taken, and to this few drops of base were added, and solvent as ETOH at room temperature stir 24 hours. We got novel chalcone, 3-anthracene 9-while 1,4-hydroxyphenyl group, probe 2 in 1. NMR IR spectra in the C double bond O, OH and C single bond C. These are all peaks in centimeter inverse. NMR spectra which confirms the novel chalcone. My feature work: sensing applications, fabrication of OLED from synthesized compound and prediction of biological properties. These are my references. Thank you.
Hi, can you go to the synthetic scheme?
Synthetics.
Yeah, you have a aldehyde there, right? I'll ask few quick basic questions. And you are using sodium hydroxide. So whether that aldehyde will not undergo Cannizzaro reaction there? Did you observe? Because you are writing only one product.
Yeah.
Did you observe any Cannizzaro product? No.
No.
Why?
ELC method.
You know what is Cannizzaro reaction?
Yes, sir.
You have an aldehyde group there.
Yeah.
You are using base, right? The question is whether the molecule, that anthracene carbaldehyde, underwent Cannizzaro reaction. Yes or no?
No, sir.
No. Are you sure?
Yes.
Why it will not undergo?
Room temperature.
Okay. So how did you do the reaction? So what you have added to what here?
4-hydroxyacetophenone.
Okay.
To this 9-anthracene carbaldehyde.
Okay.
Stirred with solvent ETOH.
Okay.
Then after 10 minutes, base NaOH was added.
Okay.
Then RT reaction 24 hours after this TLC checked. Then we confirm this product, and aldehyde was present initially. Then it was removed by recrystallization method.
Okay, so what is the mechanism, how it works here? Which carbonyl?
Claisen with condensation reaction.
So which carbonyl will form? What will happen here, mechanism wise?
Neutralization to first electrophilic reactions.
Sodium hydroxide will abstract proton from your hydroxyacetophenone?
Yes, sir.
Yes? You have studied mechanism of this? Okay, yeah, thanks.
The future work you mentioned, you would like to fabricate OLEDs. What is LEDs?
Organic light emitting diodes.
So why do you expect this molecule to be fluorescent or phosphorescence or the photoluminescent?
This molecule, this work is like it was fluorescence only.
Okay.
I have studied UV spectra and like characteristics. So it shows a fluorescence property.
Okay.
So based on this.
Okay. Yeah. Okay. Thank you.
Thank you.
Thank you all, paper presentators. Now one small announcement. All the delegates are requested to fill the feedback form and hand over to our volunteers. Thank you all, paper presentator once again. Now, I request Professor Arun Kumar B. Judges, please share your opinion about the paper presentation session.
Yeah, it's a nostalgic moment for me to come and speak right in front of you people, because where you studied and where you worked. I take this opportunity for thanking Arun sir and all the members for inviting me here and giving me this opportunity. Yeah, the dais is given, I can continue to speak, but in the interest of time I will stop because the events are lined up. Coming back to the specific event that was assigned, it was really interesting. 10 presenters really did a great job. I was very happy to see the presenters speaking the terminology like ICM, TEM, nanotechnology, or XRD analysis, which were earlier were confined to the islands of excellence like IIT or CSS. Now they are deeply penetrated in the curriculum of colleges. I'm very happy. Take this opportunity to congratulate all the 10 presenters. All the best for your futures. Thank you.
Good evening, everyone. So let me first thank Arun sir and Principal sir and all the students, colleagues and speakers here. My first observation is that most of you have done really well, and my 2 cents advice would be that it's a presentation, it's not reading. Okay, when you actually make PPT, please only mention just few points, rather you actually speak to the audience. And when you actually make figures, ensure that this is clear and the color composition you are presenting is clear enough to the audience and keep them engaged. Okay, this also I would like to. But overall, most of you presented really well. And other question you would like to actually ask yourself is that when you present some data, you ask yourself what I am presenting, why is that happening? You choose a material, what would be the application, why such potential application you are trying to target would be fitting only for the given material you are choosing, why not any other material? So when you have these questions are kind of curiosity driven, or when you try to question yourself, why only this material, why not other one? So then most of the answers will be answered by your own, and you will be presenting even better in your presentation. That's my 2 cents advice. Would be hopeful to make you done a better job. Definitely you'll make even excellent job in the next time. Okay, thanks so much. Good luck.
Thank you, judges. Now I request Professor Arun Kumar B, Head of the Department of Chemistry and convener of this national seminar, Chemsem 2K24, offer a memento to Dr. Murthy Dharmapura sir. Thank you, sir. Now I request Professor Veera Pinto, Department of Chemistry, Associate Professor, Department of Chemistry, offer a memento to Dr. Nagaraj Naik, sir. Thank you, madam. Once again, thank you all present here. Now, the session for the valedictory ceremony.
Good evening to all. After 3 continuous brainstorming sessions and paper presentations, it's time to draw curtain to today's program. Myself, Mrs. Pushpalata, from the Department of Chemistry, standing before you to host the valedictory session. On behalf of M.G.M College, Udupi, Department of Chemistry, Association of Chemistry Teachers, Mangalore University, and IQAC, I extend a warm welcome to all of you to the valedictory ceremony of National Level Chemistry Seminar. May I now request Professor Arun Kumar B, Head of the Department of Chemistry, Convener of National Level Chemistry Seminar, and Mrs. Jyoti M. Alfonso, Assistant Professor of Chemistry, Coordinator of Amrutha Mahothsava National Level Seminar Series, to escort the dignitaries on the rostrum. With a big round of applause, let's welcome President of Valedictory Session, Professor Lakshmi Narayan Karant, Principal, M.G.M College, Udupi, Chief Guest, Mr. V.G. Nayak, Retired Deputy Director Forensic Science Laboratory, Bangalore. May I now request Mrs. Jyoti M. Alfonso, Assistant Professor of Chemistry, to welcome the dignitaries and the guests.
Education is the most powerful weapon which you can use to change the world. Good evening, everyone. It's my great pleasure to welcome you all to the valedictory program of this one-day national level seminar on new Vistas in chemistry, organized by the Department of Chemistry in collaboration with Association of Chemistry Teachers of Bangalore University and IQAC. After a day filled with inspiring presentations, engaging discussions, we have now gathered here to conclude this enriching event. First and foremost, I would like to extend a warm welcome to the President of today's program, Professor Lakshminarayan Karan, Principal of M.G.M College, whose leadership and guidance have been invaluable, and we are grateful for your support, sir. Thank you, sir, and welcome you to the program. I feel privileged to welcome our esteemed Chief Guest, Mr. V.G. Nayak, former Deputy Director, Forensic Science, Bangalore. We are truly honored to have you with us today to share your valuable insights and expertise. I welcome you, sir. It's my pleasure to welcome Professor Arun Kumar B., Head of the Department of Chemistry and convener of the seminar. Your leadership and dedication have been vital in organizing this seminar. We are deeply thankful for your continuous support. I welcome you, sir. I would also like to extend warm welcome to the co-conveners of the seminar.
I'll say that the negative point of this one is one point is it is too late, so little bit late. So that is the negative point of this seminar. So everything is overall good. So I once again thank you for giving opportunity to share my opinion. Thank you.
Respected dignitaries on the dais, my dear colleagues and my dear students. Students for organizing this seminar in a very, very beautiful manner. And one point as I remembered, this is the only seminar from morning, entire hall is full. That's a point I have to note, right? Many seminars have taken place here. So thanks to my students and even for teachers also. That shows that, all the deliberations, were very good.
To thank our esteemed dignitaries for their valuable contributions. May I now request Professor Lakshminarayan Karan, Principal M.G.M College, to present a memento to the Chief Guest, Mr. V.G. Nayak. Thank you, sir. Before we conclude, let us extend our heartfelt gratitude to all those who made this event a successful one. So on this note, to express the words of appreciation and gratitude, I would like to invite Professor Arun Kumar B., Head of the Department of Chemistry, Student Welfare Officer, and convener of the National Level Chemistry Seminar, to propose the vote of thanks.
Good evening to all. Showing gratitude is one of the simplest yet most powerful things we can do for each other. As we are in the concluding session, it's my duty as convener of the seminar to express my deepest gratitude to all who are responsible for the success of this seminar. At the very outset, I am very grateful to our management members, especially Sri T. Satish Upai, President, M.G.M College Trust, Dr. H.S. Ballal, Pro-Chancellor Mahe Manipal, Sri C.A. B.P. Varadarayapai, Secretary, Academy of General Education, Manipal, for the magnanimous support rendered by them in organizing this seminar. I thank Professor Lakshminarayan Karan, sir, Principal, M.G.M College, Udupi, for his continuous unwavering support throughout this seminar. Thank you, sir. Let me thank Mr. V.G. Nayak, Deputy Director, Retired Forensic Science Laboratories, Bangalore, for accepting our invitation and present here as our resource person. Thank you, sir. I also thank all our resource persons, Dr. Raghavan Sunoj, Dr. Shashidhar B.S., Dr. Nagaraj Nayak, Dr. Murthy Dharmapura, who took their valuable time and joined us today as our resource persons. Thank you, sirs. My special thanks to Dr. Edwin D'Souza, President, Association of Chemistry Teachers of Mangalore University, and all the office bearers and members of ACT who supported us in a big way by attending this seminar. I also thank all the research scholars, faculty members from different institutions who have presented their research articles today in this seminar and made our seminar a grand success. I also thank all the student delegates and faculty members from different institutions who actively participated in this seminar. I also thank all the invitees, retired staff member, that is Bhaskar sir, and all our faculty members for their fullest involvement in this seminar. I also thank Mr. Suchit Kotyan, Mr. Manoj, Department of Journalism, and their entire band of journalism students for their continuous support throughout the seminar. I also thank all the print and media persons for their support. Let me thank Kishore sir, Chief Librarian, and Vinit sir, and all the office staff members, and Mr. Satish Sagri for their technical support in smooth organizing of the seminar. I thank all my dear students who actively participated in this seminar. My deepest heartfelt thanks to my department colleagues, both PU and degree. Without them, this seminar wouldn't have been possible. Firstly, let me thank Mrs. Veera Pinto, Dr. Babu M., co-conveners of the seminar, and Mr. Jyoti Alfonso, coordinator of the seminar series, for their unwavering support throughout the preparation of the seminar. I also thank our seminar committee members, Mrs. Pushpalata Madam, Rekha Madam, Pooja Madam, Mahesh Sir, Priya Madam, Mr. Nixit Sir, Smita Madam, Suchitra Madam, and our non-teaching staff members, Mr. Ratnakar, Satish, and Nitin, for their fullest cooperation and support throughout the seminar. Last but not the least, I thank from the bottom of my heart to all my dear students, volunteers, welcome dance students, artists, who have helped us in a big way in organizing this seminar. Thank you one and all.
I also thank our HOD, Professor Anukumar B., for his unwavering support during this seminar.
Thank you, sir, for your benevolent gesture. Now I would like to request everyone to raise for the national anthem.
अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जाहे तव शुभाशिष मागे गाहे तव जय गाता जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 जय